I'm delighted to be here. I'm even more delighted to be able to host today's events. I've been down to Hooke Park a number of times, and I think it's the sort of, I hope not so hidden gem of the AA, and not just because it's a beautiful forest, but it has, I suppose, it has a sort of purpose that is unique. And I was just speaking to John about how it's not just unique in the kind of context of architectural education, but it is very particular to the AA. It's a working, sustainable forest. It is there really to answer a series of needs. And I sit through so many crits, juries, reviews that talk about tall timber buildings, or I suppose, demountable structures that call upon a kind of understanding of the use of timber without really understanding where all that timber is going to come from. And so while we want to build in it, we seem unable to understand how to cultivate it. And I think today is a really wonderful opportunity to address the relationship across that spectrum and the kind of interwoven nature that is so essential to Hooke. And I'm just delighted to have all of our guests here today, and particularly you, John. It was a pleasure to meet you earlier, and it's wonderful to have you here. So I'll pass on to all of you, and I'll enjoy the rest of the day.
Thanks, Ingrid. Thank you, Ingrid. So I'm just going to give a very broad, brief overview of the day, how it's structured, and then I'm going to pass on to John and Emmanuel. Hopefully won't take up too much of your time. It's exciting, as Ingrid said, it's exciting to be here to have this kind of day of discussions, which I think is bringing together a diverse set of people who perhaps don't always talk to each other. It's a day of talks as part of the AA Wood Lab, focused around long-term forestry thinking, the material wonder of wood, and the architectural experimentation in timber. It's been generously funded by John Makepeace, the Wood Lab itself, and it's a forestry and architecture research initiative, and those two things go closely together, based at Hooke Park. It builds on a legacy of work to date at Hooke. Hooke Park has been a material-led laboratory for about 30 years, 30-year history of experimental timber buildings, and experiments that are really born from a deep engagement with the inherent properties of timber. The lab has two main strands of focus. Forestry research. I could actually pull up the slide. Got it. That's the one. Forestry research to inform long-term forestry strategies for Hooke Park. Developing Hooke Park as a research forest and a testing ground for forestry innovation. And today we'll hear, in the next session, the first session, from our newly appointed Forest Research Fellows, Catherine Byrne and Jez Ralph, Evolving Forests, as well as our own Hooke Park forester, Chris Saad, and Gabriel Hemery from the Silver Foundation. The second strand really is research through fabrication, which is the bottom one, architecture and space, prototyping timber applications for architecture, which utilize the inherent properties of timber and contribute to an urgent and broader conversation within architecture around the use of timber as an essential building material for a lower carbon future. Ordinarily, these two areas, as I said, areas of expertise don't always meet, but these two things are deeply interconnected at Hooke Park, which is what makes that place so special. And Wood Labs looks to position the forest at the center of this architectural research. The linking piece between these two in the middle, obviously, is the material itself, the wood. So today we make our way through talks and discussions on forestry, ecology, material, craft, engineering, and architecture, beginning with a bit of context, historical context. John will say a few words about Wood Lab and the ambitions behind some of the original buildings built at Hooke. And Emmanuel will give a broad flavour of some of the more recent built works and fabrication research of the Design and Make postgraduate programme at Hooke. It's worth noting Wood Lab is a distinct thing to the Design and Make programme, but very closely aligned with its development. we're going to try and keep that as tight as we can, because what we really want to do is open out the discussion into these 3 panels of external experts as a kind of big collaborative working meeting for Wood Lab, if you like. So we really want your engagement. We're here to generate conversation that feeds into Wood Lab. That's the purpose of today, is to feed the research through all of the amazing people that are gathered here today. Okay, I think that's enough for me. I'm going to hand over to John Makepeace, founder of Hooke Park.
Is this live?
And the generous donor for the project. Actually, before I do that, I did want to say a couple of thanks, to John, to Manager and Harriet, the public programme and the AV team for organising today, to Dmitry Fedorov, wherever he is, our amazing Wood Lab research assistant, Ryan and the publications team working with us on the case study books, and to Jack, Finbar and Zach, who started this work, and from whom we're taking on the legacy. Okay, John, I'll put up your presentation.
Can I stand?
Yeah. Do you want the mic to
Right.
stand?
I don't know. Is this one going to work?
That one's probably better.
All right. Great. Well, I have to say there's been a lot of work gone into making today happen. And Kate wears the load seemingly rather lightly, but there has been a huge amount of preparation, and it's taken a little while to make it happen, but here it is, and that's very thrilling. It may just be helpful to say that I was first involved with forestry when a consultant to the Indian government back in 1972. So I'm giving you a bit of a date line here. Appointed by British government to advise organisations in India about their use of timber and what they made from it. But it was then that I became really aware of the clearance of forestry and, of course, the huge colonisation of the use of their resources for our purposes back here. So their forest resources were already depleted back then. Sorry. Yes, I didn't need to push slides. That's fine. Thank you. Okay. The next experience was being commissioned by the Marquis of Bath at Longleat House to make furniture for the house and to use timber from that forest. As a result, I came to know the forester rather well, and we used a variety of materials which were grown there. When it came to paying the bill, Lord Bath said, would you like some timber? And they had felled 36 magnificent oak, planted in 1740. 240 years later, on his 80th birthday, these trees were down. 30, 40, 50 feet to the first limb. Beautifully managed oak, 240 years old. And he said, well, you better take the pick of them. There were 6 trees out of those 36 that were sound. The rest all had ring shake, which made them of a much lower grade of timber. But it really demonstrates some of the issues involved when we're planning to grow fine timber and making that commitment. In the 18th century, we were already importing timber on a substantial scale for construction. Ports up and around the country were bringing timber in from Scandinavia to build houses. We've continued and increased our imports to about 90% of the timber over recent years, now diminishing slightly. But that has happened because of our huge dependence on imports and our failure to use our own resources more effectively and to cultivate our own resources better. I was responsible for establishing an educational trust to train designers and furniture makers, one of whom is going to be speaking later, in Sean Sutcliffe. Within 4 years of that, starting that, I thought, well, we really should be addressing the forestry issue and trying to get furniture makers to understand the materials they're using. bought Hooke Park from the Forestry Commission, and that 350 acres was half conifer, half broadleaved, so was a very good representation of our national forest resource. The objective there was to use the produce from the forest to construct buildings. The early produce was largely thinnings, material down to 5 centimeters in diameter to span 15 meters. So roundwood, material which is undisturbed and inherently complete. Once we saw timber, we disturb that balance, and we always have something which is out of balance within itself. Whereas, of course, trees have this wonderful stress within the outside skin and compression on the inside, which makes it such a beautifully balanced material. And now the trees are growing, so we have to address those issues, which are different but equally important. Just how do we use the resource that is coming out of managing woodlands more effectively? The buildings that are shown in some of the slides that are circulating, and I'm going to start showing you some slides now. Thank you. Hooke Park we bought from the Forestry Commission, 350 acres, as I said, beech, oak, Norway, Douglas, and a number of other species. Managing woodland is about, well, if we're going to grow timber, one of the priorities is to produce clean stems of timber that are balanced. One of the problems with when trees branch, of course, is that you're getting a structure there which is no longer consistent and therefore warps and twists and is generally regarded as unusable. And so clean stems are really what a lot of that is about. Forestry Commission had not managed to achieve that. Much woodland is neglected, as was that. But what was very interesting was that to find out how to use the material that was coming out, the thinnings, required research. And I'm not talking about book research or reading what other people have done. I'm talking about research where actually we get people who are materially focused to understand how do we use timber better. I don't think any other industry would not have a lively program of research into the material which is its lifeblood. And whilst it's very easy for us to specify timber, that is not really getting to grips with actually understanding what our own forests can provide. And one of the reasons for this project is actually to get architects more confident in understanding materials they're using so as to be able to use them more intelligently. Let's just go through these slides, because Hooke Park is, I'd say, 350 acres. This was about 1982, 83 probably, when we built the first building, which we shall then see. So timber from, as I say, 5 centimeters. In this case, we're seeing some of the bigger timber, probably 15 to 20 centimeters. All trees needing to be taken out to favor the remainder of the crop. Timber used in compression to take load. Timber used horizontally, again in compression. And then tension between the ridge and the eaves, where the small material is take a load up to 5 kilonewtons. Because it's held at the ends, it cannot bend beyond its point of breaking. So we're using small material for its very best properties, and it directly reflects the nature of the crop from managing that one particular stand in the forest. So the connection from the resource to the building was absolutely on the mark. Another building, these were all we worked on these buildings with Ted Happold, Bureau Happold, Ahrens, Burton and Korolik Architects, and Fry Otto. I think I was probably unusual as a client in that I said to the architect, look, this building is going to have to be designed, the initial work on this building has to be by the engineers. You as architects will not know about this material until it's researched. And so there were programs of research into the properties before one could actually make an approach to the Department of Environment, which who had no building codes for using this material. So the research had to prove that the buildings would meet the purpose of the regulations, but not the regulations themselves. So totally new approval for building types. Right, thank you. And that's the interior of the main workshop. There's been another lovely workshop built since then, but that was a different formula. And here you see timbers being bent over to have a gap which was then bridged by a third component. Good. Well, now, just to conclude, I just want to talk a bit about the future. It's really wonderful to be working with Kate and Emmanuel, and now Jez and Kate, on looking to the future. It's very rare for a school of architecture anywhere in the world to have its own forest. We're now looking at planning the future plan of a forest that is the AAs with the specific objective of educating a future generation of architects in the better use of timber. That suggests to me that Hooke Park is going to become more and more special as a place with a clear purpose. And how on earth can you have forestry without purpose? You know, so often we're planting things and we don't know who the market will be. But here we actually know why we're doing things, and it will dictate so much of what one actually does on the ground. It'll have its own landscape. It'll create its own landscape, which will be distinctive because of the purpose. So it's a unique opportunity now that we have at the AA to achieve that. I don't know what your view is, but for me, the most interesting architecture is almost always coming out of research, new learning. It's that is enabling buildings to change. It's on the edge of knowledge. What we build, we want to be of today and the very best of today from the best science that we can generate. And I think one way that will probably happen, and I would encourage this, is through collaboration with specialist research departments within related universities to understand the material and to give forestry a much more focused way of thinking about what it's doing and why it's doing it, and aiming for quality as opposed to just planting trees. I think the AA has a lot to demonstrate. Thank you.
Thank you, John. It's always so inspiring. Just want to bottle it sometimes. I'm going to hand over to Emmanuel.
Thank you so much, John, for a fantastic intro. John mentioned Hooke Park. What a fantastic satellite campus to the AA. I'm here going to show a little bit of the more current research and the activities that's been taking place over the last couple of years. 350 acres of woodland, approximately 17 different species. I won't go into too much detail about the forest because the next group of speakers is going to do that for us. But what an amazing setup to have this young man, Chris Sad, our head forester, help us navigate the forest and our operations. But really fundamentally, what does it mean for the education of an architect to be rooted and nested within the woodlands, within the forest, which is our building site and our material library and our building site, our place of operation. Not many architects have access to any form of timber, right? So we have all the tools and the equipment to actually intervene in any moment of the timber production, which gives us this affordance of a material which is not linear. So, for instance, working with low-value material as natural forked beech trees kind of offers us all kind of opportunities for experimental architectures. It means that we can study timber and analyze it. Our facility allows us to also make our own tools. Robotics is quite interesting. We don't have a fetish for the digital realm, but robotics allows us, because it doesn't come with the tool doesn't come with a clearly defined function. It allows us to make new tools, make new end effectors, and reinvent what we could do with the timber. It allows us to locally operate on these natural complex geometries. So here you have the beautiful juxtaposition of the beech tree in the round, as John mentioned, in its strongest form. But precision joints have been cut by a chainsaw mounted on a robot. So a chainsaw is not really known for a tool of precision, but once it gets guided by a digital control tool, we kind of gain something there. And it allows us to build architectures which are inventive and trying to find a place for these natural timbers. So today we'll talk about the forest, about the material, but also the spaces that it creates. And we're looking to really position digital tools really precisely within the workflows. So in this case, I often say that the production of our tool is kind of the holy grail within fabrication. So all our operations, I think it's important to say that it's a team effort. This is not just me or Kate, but there's a whole team behind us that helps us, from robotic developers to people in the workshop, to people on the ground like Chris cutting down the trees. We learn from our tools. So this was a first iteration bandsaw. We learned through making. So this is the third generation bandsaw, which kind of changed this geometry quite significantly because we learn of the constraints of production. The current research looks at natural geometries, but it also looks at engineered timber. Some of the timber in the UK, I guess, is not of the highest quality. So aspects or strategies like glulam and CLT allow us to potentially make stronger timbers than we have. So we're interested in developing inventive new workflows. So in this case, the prescribed workflow was to look at CLT and glue lamination for a structural frame that had to use the robot with the bandsaw mounted as a main tool. So we look at the production of data for the tool and for production is not just your Rhino model, right? It's informed by all kinds of aspects of timber, of material behavior, fabrication knowledge, but also a constant conversation with the team at Arup that will help us resolve structural components, connections, and details. So this is the framework of the library. So digital tools are important. Another one of our secret weapons is the LiDAR scanner. So we could work of information as built and not information as designed. So this scan is actually an overlay of the digital Rhino model combined with the LiDAR scan. So we could see the variation and the change through material behavior and slippage and tolerance between what was designed and what was made. So as I mentioned, scanning is really important. So LiDAR scanning allows us to take a fingerprint, pretty much, of the construct that we make. So we could do reverse engineering and run analysis after production. I wanted to use this opportunity, and we're pretty excited to talk about our latest addition, Hooke Park, which is a field station, which is a provocation or a present really to the main school to go out and sit with and kind of be nesting the building deep into the tissue of the forest. So we actually ask you to go out and teach and sit and experience the forest. So John talked about harvesting and timber production. This is what timber harvesting looks like these days. So this very intelligent machine crawls through the forest, cutting down our timbers. This is what it leaves behind. So for the field station, we looked at finding a use for this timber, for these small diameter timbers, 50 to 90 mil in diameter, so they're pretty much branches. So we prescribed to build a space frame out of it. So the branches would form the diagonal component, and to be able to work with this geometry, we developed a robotic workflow. I'm not going to explain it in much detail. I hope this film will do that for me. So we developed a vision system for the robot. So Latoya, our robot, would pick up the timber. We had a little feeding station, and she would scan every branch. So we'd make a digital twin of our physical branch, and a clever bit of scripting by Wyatt and the team would optimize the position of the tenon joint. So this really, 256 branches that have all unique geometry, but were cut to length, and the position of the tenon was scripted. So all of a sudden, this quite random material became a building component that we could use as a universal component. So this is some of the affordance of the technology. To cut a single piece, the team got it down to just about 6 minutes per component, which was fully automated. So fully automated from picking up the component, scanning, cutting, and then Wyatt built this little slide so the component would slide out of the robot cell so we could pick it up. So this was a setup, a 3D camera, a feeding station, and a circular saw mounted on a lathe. This little let's go back. I think this is really quite important little slide that gives you the accumulation of all the individual pieces that show you how much diversity there is within the geometries. And again, this is the affordance of the technology, that these really unique components can function as a universal component. We learn by making. So the very first space frame that we built was very clumsy, but we learned a lot. At the end, we have, I think, 7 generations of space frames before we got to the final piece, which was a 90 square meter roof structure. As I mentioned, Arab is a really important component in this conversation, because unlike our first initial naive thoughts, the force distribution is not equal. And it kind of really is important for us to understand the nuts and bolts, kind of the force schedules that go in. So in the end, we made a flat, packable space frame. So this is all the components separated. The way it works is the 2 top frames are held together, pushed together by threaded rod. That's the only mechanical component. So that means the round timber is in compression. Some of the initial ideas was about the space frame, that we wanted to have this idea of being in the forest, so this idea of the thickest of the forest when you look through the space frame. The site was really specific, was really important, and what a beautiful site to work on, to assemble. So the program of the field station is for us to go out and sit in the forest, but also to engage with the local community that use the forest. The view is really important. It's out to the Mapperton estate. They just made this big statement of a rewilding. So the landscape that we're looking at is going to change significantly. So the field station is there. One of its objectives is to do long-term observations. So we're doing a time lapse of 10 years at the moment to see the landscape change. And these are some final images, what it looks like yesterday. With the MSc team are just finishing. So again, this is the hard work of 10 students and the whole team at Hooke Park. And particularly Romain and Garrett kind of worked their socks off to produce this lovely piece. I'm just going to leave you with that slide of the field station at Hooke. Thank you.
Thank you, both of you. We're actually going to move swiftly into session 1, forestry session. So we're going to go do a quick change up here, and I'll load up Chris's slides. We're going to start with 4 amazing people. Chris Sadd, who's a forester at Hooke Park, is going to give a little bit of an introduction. I'll put his slides up here. Followed by Jez Ralph and Catherine Byrne from Evolving Forests. Catherine is a newly appointed Wood Lab Fellow for the AA as part of Wood Lab. Followed by Gabriel Hemery from the Silver Foundation. And this is a session really to discuss the forest, right? So the forest material space.
Good morning, everybody. Just to reconfirm that I'm Chris, I'm not Jez, okay? Just in case, some of you are asleep back there. Flip the order, yeah. So we've spent the last 3/4 of an hour being incredibly impressed by slides, images, and what was talked about. I'm going to keep mine very brief. Most of the information that I was going to tell you has been already said, so mine will be even briefer than brief, all right? But what's been interesting up until now, some of you in this room don't know where the hell Hooke is. Is it in Scotland? Is it in Wales? No, it's not. It's in Dorset. So we have an image here of Hooke Park as a woodland. In the top there, it's a lined out, just picked out there. So we're in West Dorset, and it shows you the very intimate countryside that surrounds Hooke. We're incredibly lucky to have this landscape. A lot of people are very enviable as to where Hooke is sited. To the southwest here, we have the Jurassic Park, the Jurassic Coast. Yeah, well, it could be the Jurassic Park as well. It is the Jurassic Park as well. And then we have Bridport down on the coast there with West Bay. Great. Okay, so shall we just nudge along here? Right, so there is a closer view of Hooke Park and the lands immediately around it. So we own just a block of woodland. We do not own, or the AA do not own any outlying property. So we have our main block of woodland, and to the north we have a smaller block of woodland which is under our ownership as well. But a very interesting landscape, as you will see, which is very critical, is you see a lot of smaller woods that surround Hooke Park, and some of these woods, so the large Mapperton estate to the west here, interconnect into Hooke Park, which is ecologically, historically of great importance. And we've lost a lot of these interconnections over time, certainly since after the Second World War. Okay. The campus you can see as a white blob there. Okay. Right. So let's give you a few facts and figures on here. So John alluded to the size, but he spoke in imperial. I'll give it to you in metric. So it's 150 hectares in total, and that includes the small block to the north there. Right, 70% of Hooke Park is what is designated as ancient woodland. Now, it's a term that developers, people involved in HS2 may well be familiar with, and those who read and listen to the news about the progress of HS2, they are coming up against problems with ancient woodlands on the line of HS2, which causes a lot of controversy. So principally, the definition of an ancient woodland is it's an area that has had trees on that same site since the 1600s. Okay, that's its definition. And so seen as a very valuable resource for many reasons, and therefore, where possible, needs protection. Right, so let's give you a sort of potted history of Hooke Park. We'll start at during World War II. It was owned at the time by the Unigate Pension Fund. After many decades, centuries of private ownership, then it was taken over by the Unigate Pension Fund. Come 1947, the Forestry Commission purchased the woodland as it was, or the best part of it. To the northeast it was open fields at the time. And so they proceeded to clear fell what effectively was a natural woodland, so a native woodland, which was oak, ash, and they started down here, and they proceeded to move up to the north there. So during the 50s, it was felled and replanted. Primarily was beech and Norway spruce. And then come 1983, when the Forestry Commission at the time were, if you want, divesting themselves of smaller woodlands in the southwest of England and elsewhere. And one of the woodlands that came up for sale was Hooke Park and Powerstock Common, which again was Forestry Commission, which is to the east of Hooke Park, of a similar size. Okay, and that's the idea of starting at the beginning of a campus was thought about and set in train. And as you can see from my hairstyle, the colour of my hair, I've been there since that time, 1985, 84. Okay, and so effectively I fell the trees with a team of people at the time, and we supplied the building team with the timbers that were required. Again, quite an interesting relationship at the time, and this is a theme that needs to be discussed today, is the architects, the engineers at the time had really very little idea, no idea at all, as to things like trees have tapers on them, trees have branches on them. Okay, I think you're slightly better informed now, but you'll be even better informed by the end of today on that. And then since 2001, the Architectural Association have become the owners of Hooke Park. It was interesting at the time, just to go back to the theme of ancient woodland, is one of the prospective buyers or owners of Hooke Park when there was the Parliament Trust put it on the market, was the Woodland Trust. The Woodland Trust saw a great interest in purchasing the wood, and they decided to back out, the reason being that the Parliament Trust had built a campus on what was ancient woodland site. So they decided, no, that's not for us. That's not what we're interested in. Right. Let's just show you. We have our principal species, softwood species, is Norway spruce. I've sort of separated out, you'll see two groups of different species. The species that I will be listing, the next 4 or 5 species, are those where there's the greatest dominance of the species, are these 4 or 5. And we have, and at the moment continue to be focusing our management around these particular species. So Norway spruce, a lot of that was put into the buildings in the first building that was built and in the workshop, and continues to be used. Then we have a lot of beech, as you've seen already. Again, primarily used when the Architectural Association took over. Little beech was used prior to that. Okay. And then we have quite a large area of oak, which as yet we haven't been harvesting it to be used on the campus. And we have also western red cedar that pops up from time to time through the wood, and we certainly are focusing our attention on that. Interesting conifer, it's naturally very durable. So a lot of our cladding in our current buildings are clad with western red cedar. And we also have Douglas fir, which is potentially of significant importance because it's structurally a very strong timber. Unfortunately, the legacy of the Douglas fir we have, it comes from a very poor provenance, so it's not the best Douglas fir that we could grow really. And then we have what I sort of designate as a minor species. Alder is one. Alder is an interesting tree in as much that it will grow in the wettest of spots. Its yield class, so its performance, will sometimes outgrow conifers. So it's certainly a species to explore for the future. It also is one of these trees, you cut it down and it will regrow. So from one tree you may get four or 5 stems once that first tree has been cut down. We have a small area of coastal redwood, which is one species that's being considered when it comes to considering species for climate change. Okay. So, likely to certainly outlive me, the coastal redwood, likely to outlive all of you, and likely to outlive everything else on this planet, because we know that, you know, this tree is capable of living for 3,000 or 4,000 years. Lime, we have a few lime trees. Not sure why, but it's just a tree that I like. So we tend to plant this at track junctions and along the side of tracks. Yeah. Corsican pine, we have some Corsican pine on the eastern, northeastern edge here. That was as a result of the new plantings after the Second World War. It was a field, and the whole slope was planted with Corsican pine. Unfortunately, Corsican pine is also under threat, and probably not a tree that one would wish to replant with. Okay, it suffers from red needle blight, which effectively will reduce the growth of the tree. So a lot of our part of the world, there is a lot of Corsican pine forests which are being clear felled and restocked with something else. And we have a bit of Scots pine. Right. I put all other species. What I mean by that is woodlands, we mustn't forget, they are a source of, we need to continue with the theme of growing trees for timber. But woodlands have so many other resources available to them. And one of the species is we have students on site. So students need to be sort of managed. So that's part of the sort of management process. The public need to be managed. The ecology of the site needs to be managed. So we mustn't forget all those other subtle species that are incorporated at Hooke and in many other woodlands. And then finally, just to close up here, so I've just put future species and future management. Well, that's over to the experts, more so than myself, but it's really, you know, we're in a crisis situation at the moment, and, you know, what do we do? What tree species do we select, and how do we sort of future-proof the management of these species and our woodlands? All right, so that's all, folks. That's good.
It is. It's an honour to be back here. Actually, there's some people in the room I know, a lot that I don't. I used to work at Hooke Park a few years ago and went on to start Evolving Forests, which we'll talk about in a minute. But what I want to get out of the next 20 minutes or so is just partly an idea of the complexity. I want to take Hooke Park and take it outside of Hooke Park and put it in some context and sort of ask the question that why the hell a bunch of foresters are standing in Bedford Square today when we should be out in the forest, and also why when we go to Hooke Park there's a group of bloody architects trying to interfere with what we do in the forests, because, you know, it feels like life would be much simpler if we all sort of kept apart as we have done traditionally. And try to start answering this question, which I think is a global question that Hooke Park can be a big part of. And this is two articles from the same paper, from The Guardian, from the same year, and one of them's asking, you know, why do we have to chop down trees and kill these amazing organisms? And the other one is saying, well, timber architecture is the way we have to go in the future. And if the same editorial is writing these same articles, do we not have a huge problem on our hands that we can be part of addressing? But we need to go back a little bit, I think, and try and understand where forestry in the UK has come from and where it's going. And we could go back to the last glaciation, but actually there were so few trees in this country at the beginning of the 20th century that we can almost start there. And there was a reaction to the lack of forestry and trees. 3% tree cover. And to put that into context, it's about 14% now. Sweden, the Scandinavian countries, 75%. Germany, 35-40%. Imagine what 3% is like. That is virtually no trees that you will see on your average day out. And the way we responded to that is by planting, and planting an awful lot of timber. And in some ways, it was an incredible achievement. But it was very much set in a world that was seen as human dominating the landscape, and asking the question quite explicitly, with this quote at the bottom, of how exactly we can dominate a landscape. And that was the way things were in architecture, in land use, in social sciences, and everywhere. And so we planted these monocultural plantations, and we did them in our uplands, and Hooke Park and the conifer element of Hooke Park is a part of that as well. And they were single-aged, and they were meant to put trees on our land very quickly. And they did that very well. And this is the result of it. And if anyone wants to go home now and get a coffee, just go and read Dr. Seuss, because that is the summary of the day. It's probably the greatest work on forestry ever produced, as a lesson in the dangers of planting this kind of thing. The danger is that we take on this industrialized scale of land use, and perhaps afterwards, amongst the panel, we can discuss how things like CLT fit into this pattern as well. The result was that come the 1980s and 90s, there was a response to this kind of industrialized land use, and we went down the other extreme, which is continuing today in rewilding, of looking at a more naturalistic way of planting trees. And since then, especially in England, there's been a huge amount of planting what we call native broadleaves. And these are mixed stands that perhaps don't have a timber focus. They have an ecological focus, an aesthetic focus. They're sort of set in this sort of romantic verdant idyll that you can see in paintings of the Renaissance. There's a question as to whether this is a real forest or what we imagine in our heads culturally that we want a woodland to look like. And this is the route we've gone down for the last 20 or 30 years. And Hooke Park fixed into this whole situation very neatly. It was planted as a conifer forest with a ring, with beech within it. There was a very few number of species in it. It was part of the move to create a timber resource, a strategic reserve of timber for the country. Because what we realized at that point was, if there's another war, or if anything happens, we can't just keep importing timber from everywhere else. We need our own reserve of timber. And perhaps that's been forgotten about, actually, in the last 20 or 30 years. But Hooke's species mix has expanded. It's gone down a route where we've tried to broaden what's happening at Hooke Park, but it's still only part of the way there. And then, of course, the forest itself is just a small part of the landscape. A Hooke is a small part of the landscape. Any woodland is in this country. It's not like the Amazon, and it's not like Scandinavia. Hooke is a big forest in an English landscape, remarkable as it may seem. I know a lot of Australian farmers and foresters and American farmers and foresters who think our forestry and the amount we think about it just laughable. The fact that we can all sit here for a day talking about Hooke Park at 150 hectares is kind of obscene luxury in a way. They'd ask what the hell we are achieving here today. But what it is England has an incredibly complex landscape and an incredibly complex society and an incredibly complex ecology as well. And somehow Hooke and all these small forests need to fit into that landscape. And it's not just the landscape that it needs to fit into. There's the complexity of the landscape as it is, but there's complexity in the way climate's changing as well? And do we know how much it's changing? And what are the repercussions of that? This is storm damage from Hooke Park. On the left, we're going to get increasing storms. Are we going to get increasing storm damage? What does that mean for Hooke Park? What does it mean for all the woodlands in England? And we have decreasing amounts of biodiversity as well. And what does that mean? Although we're all here to concentrate on how we can use timber, actually the biodiversity in our woodlands is critical to how that timber is produced as well. And then all of that comes together into this graph which represents what is going to happen to the timber resource in the UK over the next 50 years. And what it shows is that our timber resource, the amount of available timber that we have in the UK, is going to go down by about 20%. This is probably a very optimistic graph. It's perhaps 30%. Part of that is because of this planting we've done, of non-productive planting. Part of it is due to ecological loss. Part of it is due to storm damage. Part of it is due to putting things like wind turbines in and deforestation. But this is what's going to happen. And if we want to use more of our local timber, this is the culmination of what we need to address somehow. And we need to move away from looking at this as quite a pessimistic slide to something that gives us an opportunity to expand from. So this complex picture of society and ecology translates directly into the woodland. This slide's taken from a graphic. We run a little plug for our Tree Radicals podcasts, where we interview people we think are exciting, illuminating, interesting, or slightly crazy within forestry. We've talked to John, we've talked to Gabriel, a lot of other people. And I want to get this across that everything is connected. Growing timber is not isolated from the ecological productive potential of a woodland. So the mycorrhizal fungi that connect trees together, that allow minerals to be taken up from the soil, are critical to growing trees. They're critical to producing timber. They're critical to soil health. Without them, we don't have healthy soils, we don't have healthy ecologies, we don't have healthy timber resources either. If we don't alter the light levels in the woodland, we don't have healthy ecologies. We can't regenerate wood. We can't regenerate trees to grow timber with. We have to spend money on planting trees. And everything is connected. And this is mind-blowingly complicated. Right? It makes my head explode. When we're thinking about what trees to plant, the number of decisions we have to make is insane. And it's, at one time, feels like almost too much responsibility for my small head to cope with. And in another way, it's truly exciting. We have to say, when we decide what to plant tomorrow, or what Hooke's forest ought to be, we're not asking what we want, what you want, what your great-grandchildren want. We're asking what your great-great-grandchildren are going to need. And we have to, as foresters, face that question every day. And I find that a really exciting and vibrant industry to be in. And so our forests are changing. They're becoming more complex. In a way to be resilient and adaptable, nationally, one of the ways we're going is, rather than having monocultural plantations, mixed species, mixed ages, trying to find a way that the forest becomes resilient to whatever it's going to face in the future. And our knowledge is changing as well. And it's changing so fast. Our knowledge of timber properties and timber products is changing. We're starting to think about how we can use timber from a cellular level, how stiffness translates from the cell wall through to a building. Things we could never do in the past, we're beginning able to do now. And critically for this discussion, we can start taking that, and then we can ask silviculturally, how can we grow timber that is stiffer, based on our knowledge of how a cell wall reacts to bending. And we can start to move away from just thinking of a forest as a high forest as well. We can start to think of a forest as an urban forest. The trees outside here, the trees in a field, the trees in a glade, perhaps the trees that go into the campus at Hooke Park can be equally a part of the forest and of the timber as well. This tree is from Elephant Park, in Zone 1, and out of it comes furniture and interior joinery for the development in Elephant Park. And there's no reason why that can't happen with trees from outside here that might have to come down. And to put that into context, in London, they fell about 30,000 cubic metres of timber a year. And you use about 4 to 5 cubic metres in your average house. Think about it like that. And suddenly urban forestry becomes a critical part of our timber supply chain. And then we can start to take things that we know about from a craft setting into a modern technological setting. So we all know about charred timber and cladding. Yeah, it goes through phases of being incredibly fashionable, not fashionable, whatever. Does it do anything? Doesn't it? Who knows? But we do know that what it does on a cellular level is pyrolyze timber. So between the charring and the raw wood underneath, there's a very tiny layer of pyrolyzed, almost plasticized timber. And we can take that knowledge and we can now heat treat timber in a vacuum. We can toast it to create thermally modified timber that does exactly the same thing, but in a very modern, much more considered way. So we get whole depth, durability and dimensional stability in the timber. And I suppose this is one of the main points that I want to get across, and why Hooke is so important, is that I think it's really important to take that complexity, which in the past was dealt with through a very craft-based approach. People like Chris, whose knowledge of the woodland is based on being there for so long, is so critically important to the future, and perhaps something in a lot of forestry we've lost. But we need to match that with technology as well, and new technological crafts, whether it's scripting, whether it's scanning in the forest, and try and put those together to a new craft of silviculture that acknowledges both sides of that equation. And I think that is the way towards a much more resilient type of forestry. And of course, Hooke Park has demonstrated that in the past and has been at the forefront and the beginning of that journey. But there's still a hugely long way to go. And within that, we might look at alternative species. A question to ask is, what is a good species mix for Hooke Park or any of the UK? Do we concentrate on native, or do we go exotic, or is there a mixture of both of those things? And I suppose this is the point where we come into this, and probably worth saying very quickly a little bit about our company, Evolving Forests. It grew out of a number of influences, part of it being the Dartington Trust in Devon and its long history of innovation, and a huge amount of it from Hooke Park and having worked there. And what we do is inhabit this sort of middle ground between architecture and timber use and growing timber itself. And there's not many people working in this realm, but we think it's an area ripe for development, because you should know as much about your material origins as much as we should know about where that material is going. And it's starting this conversation that Evolving Forests is about. And it's not just at Hooke Park where we do this. This is on Dartington Estate, where we're looking at developing the old sawmill site. And the idea is that we have a cluster of, rather than it being a traditional sawmill, it's very difficult to make a small sawmill work. Actually, that site, why don't we have a forest manager there and an architect and a company that makes playground equipment and a company that's involved in forestry education? What we want is for them to be all in one room together, so that the architect can shout across the table and ask the forester about material. And the forester can say, I'm thinking of planting this. Do you think anyone's going to want to use it in 100 years? And everyone goes, I don't know, but give it a go. And it's this vibrant cross-pollination of expertise that I think is critical. And I think Hooke Park is so far ahead of the game, but we're all so much at the start of a journey that it's exciting to start to work with Hooke again. And it's a way of perhaps thinking where the future might be. Chris talked about the beech at Hooke Park. For me, beech is a bit of a problem species. I don't think it reacts very well to drought, for instance. We've seen a lot of drought this year. It's getting quite old. It often gets butt rot. This is from Hooke Park. You don't get much understory underneath it. It's not ecologically brilliant. And we want to address at Hooke Park and elsewhere in the country what we do with that. And perhaps a way forward is glue laminated timber. And on the right here is a beech glue lamination project from Devon that's going in at the moment. And Hooke Park is a way where we can carry on talking and experimenting with this kind of story. But to finish off, I think, I use this side quote a lot. This is the Chanel catwalk from Paris from a few years ago. And it is amazing that Chanel tried and wanted to make this connection between fashion and the forest in some small way. You know, trees clearly are so important that they thought it was worth that investment to make that. But of course, rather than sending everyone out to a forest, they try and bring the forest into an urban setting. And to me, this feels like a bit of a cynical abuse of what the forest is. It's everything that we shouldn't be talking about today and everything we should be trying not to do. I think we have to, as foresters, we have to have an honesty about what we can produce. And as architects, you have to be honest about your connection to the forest and ask yourself when you're using timber, is it the right thing to do? Is it resilient way of using timber? Is it the right timber to use? And what we want is to be having this sort of conversation in the forest between architect, between engineer, between forester, because timber is going to be the material of the future. And if we don't have these conversations now, then we don't address the opportunities and the issues and the problems that might be there. And perhaps what we need to talk about is perhaps changing the balance of power a bit. Those monocultural forests came about as a result of us foresters wanting to fulfill the needs of timber users. And that's how we've responded in how our forestry works for the last century. Perhaps we need to change that round a bit and think about the forest itself and ask what is right for the ecological health of the forest, what is going to make sure there's a healthy forest there in 100 years' time, and then learn to use what the timber outcomes of that silviculture is, and some way find a middle ground between those two settings. So at that point, I'm going to shut up, and I'm going to hand over to Kat, who has joined Evolving Forests and is going to be working with Hooke Park part-time for the next year as the Wood Lab Fellow, and she's going to explain a bit about what you're doing. Plug for the film festival. We're about to start advertising, which will be going online in the next week, online and live in Dartington.
Okay. So I'm going to start with this picture again, which you've already seen, but just to kind of talk about past Hooke. Why do we need to kind of think about this long-term strategy? So this is Hooke from about in the 1980s, and as you can see is pretty much dominated by 1 or 2 species, the Norway spruce, the beech. And in terms of ecology, it's not great for the kind of biodiversity and the soil health and things like that. Then it's not a very happy environment. So moving on to Hooke now, it's a lot better. So you can see this map again with all the different species. There's a lot of different species now, which is important, but at the same time, it's still dominated by Norway spruce and beech, you can see. And also the trees are all very similar in age, which leads to a kind of a lack of diversity in structure, which is also not great for forest kind of biodiversity and ecology. So this brings me on to talk about the future. So why do we need to think about a long-term strategy now? Why is it important? And it's, I mean, at the moment, there's a woodland management plan for Hooke that's kind of coming to an end in 2024. So that's one reason we need to start thinking about the next 10 years. But on a much longer scale, you know, we're starting to really now feel and start to see the impacts of climate change. And this means that we need to think about, you know, not just, like everyone's been saying, you know, not just what we need now from the forest, but what are we going to be needing in the next 100 years, and how is the environment going to change the way that we can use the material of the woodland. And this kind of like the planting and the work that we do in the woodland now is going to is going to affect future generations and take so many generations to kind of have an impact that it's just basically important to start now. But what kind of am I going to start looking at in terms of research at Hooke? There needs to be a really like strong baseline understanding of the health of the woodland. So there's been monitoring of various elements of the biodiversity, but they're not for a while and not across the board in terms of the trees and their health. And they're also thinking about things like the soil health, which is often kind of forgotten. So we're interested to start looking at new ways of monitoring the soil. So maybe taking soil samples and looking at eDNA. So that's just like sampling the DNA in the environment to understand like bacterial communities, the fungi. I'm particularly interested in the use of acoustic monitoring to measure things like birds and bats, because it's a way that you can upscale your monitoring really quickly and kind of get a really nice, or like easy to kind of, a result that's easy to present in terms of what the communities are there. So you can actually listen to the ecosystem as opposed to just seeing a list of species names, which might not be, you know, so engaging for people to understand actually what is going on in terms of the ecosystem health. And really importantly, there needs to be an ongoing monitoring program. So it's not just about finding this baseline. You need to be able to, you know, see what the impact of the management that we're doing is going to have, and then check back and see if this has actually improved these ecological and biodiversity kind of factors. Alongside this baseline monitoring, the plan is to kind of gather a massive body of evidence. We want to look at all the different silvicultural techniques that are possible and available and understand what combination would be best for Hooke. So you can see on this image here that the lower part is kind of like a more uneven age structure that you might get from like continuous cover forestry. And we're kind of looking into ways that can be possible for Hooke, trying to, because this kind of diversity and age is so important for the biodiversity and the health of the ecosystem. Also, this is a LiDAR scan here, so talking about the technologies again, which keeps coming up, we want to try and look at new ways of measuring that not only produce really accurate and kind of fast results, but also present them in an interesting way. So LiDAR makes quite nice images as well. And then in terms of the wood products that Hooke is producing, so this is an image that I took the other day, which is about a year's worth of biomass fuel. And a lot of the wood at the moment is being used for firewood, and you want to kind of think, and obviously the students' projects, but beyond that, what are different options? Speak to the local communities and try and understand what the market is there for use of the wood in new and different ways. So this kind of brings me on to the first kind of like research question that we're going to approach, and that is the idea of the concept of is Hooke resilient? And if it's not resilient, how can we make it more resilient? When I'm talking about resilience here, it's kind of the ability of an ecosystem to absorb change and recover despite things like climate change and the environment changing. So this image in the middle here is a kind of demonstration of that. It's not necessarily immediately clear what it means, but basically the cup on the left, like the depth of that represents how resilient an ecosystem is. So that's like, if we look at the left-hand cup, that's like a state that's like an ecosystem or woodland in a healthy state. And then a certain amount of environmental change will push it over the threshold into a maybe less healthy or balanced state. And the idea is we want to try and make that kind of cup as deep as possible and keep so that the environmental change that we're so uncertain about exactly which way it's going to go or how extreme it's going to be, that the ecosystem can remain within this like stable state despite that. So this picture on the left is also one that I took at Hooke the other day of squirrel damage. So that's being resilient to things like pests and disease we need to consider. And then, yeah, obviously climate change. And this image here is just of a forest I took a while ago that looks particularly diverse. So again, when it comes to being resilient, one of the most important things is diverse species, diverse genetics of the species, and diverse structure. But not all species that are present now are going to be suited to this future climate that we're talking about. And so this result here is from, or this table is from the Forestry Commission's ecological site classification tool, which basically runs all the kind of key species through it and tests their suitability for the climate. So this is based on 2080 medium scenario climate predictions. And as you can see already, there's a lot of, the red is obviously unsuitable species. You've got beech coming out there straight away as red, and so this is a really important consideration. And it's not necessarily, this is not obviously something just to follow directly. There's a lot of knowledge that needs to kind of come behind that, but it's quite an interesting, kind of fact there, well, not fact, but this brings me on to my second research question, which is about adaptability. So where resilience is kind of being able to absorb this change, adaptability is actually the process of being able to change to become more suitable to the environment. So this is particularly important when we're looking at such a long-term plan, because obviously we don't know exactly what's going to happen. There's a lot of uncertainty there. So we need to be able to try and be able to adapt to the changes that are going to happen. So this image on the left here is an example of, adapting to material use. So the students at Hooke building this with beech, I think it is, and in using materials in new ways. So we need to be able to think about whether we can use the species that might be no longer suitable, what we're going to do with the wood and things like that. And then also in terms of taking kind of understanding the risk involved and being a bit more innovative in terms of silviculture techniques. So this on the right here is just an example of a kind of silviculture experiment that was done in Japan, where they planted trees in concentric circles with decreasing density to show how the density of tree planting affects the height that they're growing to. I mainly put it up because it looks nice, but it's an example of experimentation, and this is the kind of thing that we're going to need to be doing so that we have options to take depending on how the changes do kind of take place. So what we're going to try and come up with is a long-term strategy, and in terms of long-term, we're thinking of the next 80 to 100 years. Why 80 to 100 years? So this image on the left is just showing it's kind of the average amount of time for a forestry rotation. So you can see the kind of maximum volume felled is just under 100. And then also that kind of curve underneath is showing carbon storage. So it's a way of maximizing carbon storage as well. So that's kind of on that time scale. And then also the climate predictions at the moment are reaching about 2100. So it's within that kind of time scale that we need to be looking. And then from that long-term strategy that we're going to come up with, we can then extract a more detailed 10-year management plan to look at first. My picture's gone up. So just to kind of finish with some general ideas of what this long-term strategy is going to incorporate. So forest management has been reasonably stationary for a long time, but it needs to be evolving at the pace that the climate is changing and people are using materials in new and different and interesting ways. So like as the architects at Hooke are using more innovative things like the robot arm in timber processing. Why can't we do that kind of innovation, but in terms of the forestry as well, alongside that? So diversity again comes up. That's just a kind of underlying theme that has to always be increased in terms of species and genetic diversity, structural diversity, and also diversity in the way that we use the woodland. Again, like I said before, the experimental silviculture, the ability to adapt. So within this long-term strategy, it needs to have options that can be taken depending on what happens, and any kind of rigidness will not be good, basically, in such a long-term strategy. I haven't spoken that much about people, but obviously people will be really important to this strategy, and we're going to talk to the local community and understand how they would like to use the woodland. And so there used to be like forest schools and bushcraft kind of classes going on. So the idea of starting up some of that kind of interaction with the forest to create this more symbiotic relationship. I'm also interested in the use of like sound and listening to environment as a way to connect people with it. So maybe, leading some workshops related to sound. And then, like was mentioned before as well, the kind of outer edge of Hooke is connected with a lot of important ancient woodland and conservation sites. So you need to be speaking with the people who own that land to understand, like, so for example with the land that's being rewilded, how we can kind of work with that and maybe diffuse some of the boundaries of the edge of Hooke so that they can be conservation benefits across the board. And I'm just going to finish with that picture that has already been, but to hopefully with this kind of long-term strategy we'll end up with the forest that is diverse and healthy and able to be kind of productive over a long period of time.
Good morning. Nearly, yes, it's still good morning. Well, what a privilege to be invited to speak today. Thank you to Kate and Emmanuel and John for inviting me. I've got a hard act to follow. Hopefully I'll try and connect things together in some way or reinforce ideas. My name's Gabriel Hemery. I work for the Silver Foundation. I was just trying to think of a good analogy. I like analogies. You might pick on that while I talk. It's like a woman walks into a shop and says, electrical shop, I'd like a toaster, please. Yes, madam, what colour would you like? Green or red or orange? I think I'll have green, please. The man goes into the back of the shop, brings out a nice green toaster and unpacks it for the customer. The woman looks at it and says, yeah, but I can't plug that in. That's got the wrong prongs on it and it's got the wrong voltage. And the timer's like an old-fashioned manual thing. I want a fancy digital one. So the man says, okay, madam, but we don't have that. This is one we made 100 years ago. And the woman says, yeah, but I don't want that. I want this modern technology, this functionality, this quality. And she says, well, okay, well, you tell me what your grandchildren want. Tell me the voltage and what size bread you want and all those sort of things. And then I'll maybe get inventing for you and come back. They can come back in 100 years' time and have it ready for you. That's a challenge we have in forestry. Maybe it's a bad analogy, I don't know, there's lots of frowns. The challenge we have between forestry and timber use. So hence the title of my talk about straddling the forest gate. There is a sort of proverbial forest gate, a barrier between the forest and the wood user. There are also other barriers between the forest and other interests. There's the socio-economic interests and political interests in our forests. And they're really difficult things to overcome. So I think that's kind of part of what I'm going to be trying to say. And I'm taking a somewhat strategic oversight of things, which, as I say, will hopefully connect together. I need to make sure I've got the right arrows. So I'm going to just introduce the work of Silver. You probably haven't heard of us, so I'll tell you who we are. The good, the bad, brackets, and the ugly. A bit about wood culture, and just to build on Kat and Jez's brilliant talk, a little bit about resilience using some slightly different analogies. So some blatant self-publicism. I've written a book. It's called The New Silver, and that's where the name Silver Foundation comes from. in terms of it, came from a book by John Evelyn in 1664. It's the very first book about forestry in Britain. It actually came out of the Royal Society, which Sir Christopher Wren, Robert Boyle, Isaac Newton, and other luminaries of the time, sadly all men, came together. And the greatest challenge they felt at the time was not architecture, sorry guys, not biochemistry or physics or medical science. It was, we don't have enough trees in Britain. Seriously. So the very first book for the Royal Society was about Britain's trees and the need to plant more and manage them better. Is that sounding familiar? That's from 1664. So I wrote a book in 2014 to celebrate and maybe just commiserate how terrible it is we haven't solved the problem 350 years later. So I'm going to start with a bit of a reading. I don't know if I can do this with a mic at the same time. Humans are part of this living earth. We're not merely passengers, nor tenants, nor owners. We are sentient beings, yet we are only beginning to appreciate our impact on Gaia. As enduring guardians of our forests, foresters have a unique perspective on this impact. Being a forester is akin to running the slowest relay race, the baton changing hands after decades or human lifetimes. Each generation aims to honour the vision of the previous generation and leave a legacy for the next. Perhaps in the future, wider society will attain the same long-term environmental perspective as a forester. So I suppose I'm trying to champion the idea that I am a passionate forester with a background in productive timber production. But I also recognise the need that modern forestry is about many other things, as you've heard. It's about sustaining the environment. It's about producing a beautiful landscape. It's about conserving our soils, improving our air quality, cleaning our water, reducing our flooding. Are you getting the message? It's a very complex and the best and most privileged position to be, sorry architects, is a forester. It's the very best job in the world. And what a privilege it is. So at the Silver Foundation, we envisage a wood culture, which I'm going to talk about a little bit, where people understand and promote the good stewardship of woodlands and are mindful of their utility while being conscious of their fragility. And that's really important because really what we're trying to do is tackle three big things at Silver, and that's halting biodiversity loss, sustaining society, which is where productivity comes in, and reducing climate change. And of course, there's a sweet spot in the middle there. And that's ultimately where all foresters are trying to operate. We are trying to produce good timber, we are trying to clean the water, but we're also mindful of the impacts of climate change to adapt to them and to reduce them. One of the things we've done at Silver is we've got an online platform. You're very welcome to go and have a play. We've got a kind of sandbox account where you can manage your woodlands, completely digitise them, and produce management plans which are compliant with the very good UK forestry standard for Britain. And that's used by about 160,000 hectares of woodland mapped across Britain now. It's about 7% of privately owned woodlands, used by owners and agents. And we hope in our small way, our model is hopefully going to be quite effective. So we don't own much land at all, but of course we're able to nudge, support, cajole, encourage, whatever the words we might need to use, those woodland owners who have these woodlands to think about their responsibilities to produce all those outcomes we've been talking about. So you can look that up and have a play. And that's one of the sort of a simple outcome of just some very simple focused GIS basically, but it's all cloud-based and quite simple to learn. Another thing we have is called NatureBid. This is a project encouraging effectively good use of money. It's like an online auction platform. And as I said, you probably haven't heard of Silver and certainly not of NatureBid, but we've helped support about £30 million worth of funding in the last 4 years behind the scenes through this online sort of matchmaking platform called NatureBid. We also do a bit of research. We funded a PhD program for a while. The last student I supervised wrote this paper about the cost of ash dieback, which hit the headlines, with it being an estimate of £15 billion to deal with the cost of ash dieback. This led ultimately to a lot of funding coming forward from government to support tree pest and disease management, which is a great outcome for us. We also do research around what we really are interested in private land ownership are a triptych of awareness, action and aspiration. What do the landowners who own these trees want to do with them? And what are the barriers to them trying to achieve their ultimate ambitions? So this British Woodland Survey, we tend to reach 1,000 or 2,000 owners, ask them a lot of questions, and they tell us what those issues are, and we try and tackle them in the work we do. And sort of finally, where we're based in Oxfordshire, though we work across the whole of Britain, we've got a farm we're donated in Oxfordshire, and we're in the process of converting some old buildings. This is the old grain store, and we saw the thermally modified timber earlier. This is a demonstration of the product called brimstone, and we've got ash, sycamore and poplar on this elevation here, using different fixings and so on. So it's also a test case for some novel materials, and we hope in future some architectural innovation too. It's kind of a very different version of Hooke Park. We don't have many trees. Well, we do, they're little. We don't have big trees yet. And as part of that centre, we have a wood school. As you see in the door there, it's close up to the cladding. And in the wood school, we do a lot of furniture education. So we have a course for 6 months for people coming out of college primarily, and to give them industry experience. And these are 3 products we made for the National Trust this year. So we're taking the product from a client, designing it in the school, making the product with the students, and then sending it back to the National Trust. We do that with a few other clients. So we're not architecturally engaged, but we're mostly furniture engaged at the Silver Foundation. And this is a summer school we ran last year for female non-binary students, which was very powerful. We've just completed another one with the V&A. So if you want to go and see an exhibition, it's in the V&A, 4th floor, in the Sue Webber. Yes. Thank you, John. Thank you. 4th floor furniture gallery. You can see the latest version of the summer school. So that's enough about silver. The good, the bad and the ugly. So let's start positively. We have a really good thing called the UK Forestry Standard, or the UKFS. It is kind of world leading. It sets out this balance between society, the economy, and the environment, and how we as foresters and how those foresters on Hooke Park will try and have to balance those things. It's not always very easy, but it sets out that standard. So you can still have a focus for, say, timber production, but you must be mindful of those other 3 pillars of sustainability. So that's a good thing. It's a really good standard. We have a great professional body. In fact, we have 2 really. We've got the Institute of Chartered Foresters and also the Arboricultural Association, another AA, but a different one. And they are very good at setting a standard for professionals. We have some amazing, unique habitats in Britain. You're probably aware of the Caledonian pine woods in Scotland. We have temperate rainforests along a lot of our western coast in Britain as well. And I've put this word in cognizant. And what I mean by that is I think, in a positive day, that we are truly cognizant in this country in a way we haven't been before. So in the rip-roaring gallop that Jez presented of where we've come from in forestry, from the dark satanic rows of Sitka spruce monocultures that were very quick to produce timber, we learned that actually that wasn't always the best thing for the environment. We ruined our peatlands, we removed habitats, we acidified our watercourses, all those bad things. We are now cognizant. Even I would say government is cognizant. There's a massive expansion of the team in DEFRA to support tree planting and dealing with pests and diseases. That's never in my lifetime been the case before. So I feel quite positive that actually we are truly aware of sustainability and trying to do something about it that we haven't before. So just to balance that out a bit, really low tree cover, as Jez explained. We're still the 2nd least wooded country in Europe. A significant proportion is unmanaged. I'll say more about these things in a moment. We are a huge timber importer. We've got declining associated biodiversity, very high competition for land, and low resilience. And we heard from Kat some of the reasons about that because of our monocultures and so on. So just looking at those in a bit more detail, here we are, if you can see that at the back, languishing, United Kingdom at 14% woodland cover, the 2nd least wooded country in Europe. That's one way to look at it in terms of land area. In another way, I find it's really interesting looking at how many trees we have per person. So a count of trees based on an average per hectare and our population. We have 47 trees per person. It's one of the lowest anywhere in the world. Quite shocking. Another way of looking at it, which maybe should be a lobbying thing, is... Oh, where's that gone? The constituency levels. So some constituencies across Britain have incredibly low levels of tree cover, as low as one tree for every 125 people. That's pretty shocking, isn't it? So there's some really interesting maths in that, and you can see the link there. I'm sure the slides will be shared. You can look it up. So you don't very often see that. You tend to see the hectareage presented, but in terms of connection with trees, both in an urban and a rural setting, I think that's quite an interesting perspective. So woodland ownership, very briefly, most of our trees are in private hands. I think there's a perception that somehow the Forest Commission own most of our trees. It's not the case. We have some large organisations like the Woodland Trust, the National Trust. They own about 20,000 hectares each. That's still quite small. But generally, most woods are in the hands of individual private woodland owners. Some are traditional estate owners, some are the new generation or investors and so on. Unfortunately, in terms of what's being managed, that's a slightly positive picture on the right. This is a percentage of woodlands that are managed in one sense, and that's using the certification, so FSC, PEFC certification route. If you actually look at which woodlands have a management plan, and you remember the UK Forestry Standard, a UK Forestry Standard management plan is only 50% of privately owned woodlands are in any state of management. And just remember that figure a minute. So we've got on the highest levels of ownership, private ownership in Europe. More than 1/3 are managed by sort of certification standards. So you look at that in another sense, 1/3 of our farmed wheat crop is going to waste every year. Imagine that. Imagine 1/3 of the NFU membership saying, yeah, we're just going to plough up our wheat, we can't be bothered. That's the kind of area that we're just neglecting in this country. It's pretty shocking. And you say, well, hang on, you said you're proud to be a forester. What are you... What? Not good, is it? So tree planting is a big thing. Everyone wants more trees. Personally, I would rather we get our own house in order first. You know, why are we wanting to plant huge amounts of woodlands when you just heard me say massive amounts of existing woodlands aren't being managed? There's something wrong, isn't there? What's the logic behind that? Well, it is because intuitively, you also told us, Gabriel, that we don't have many trees. So, of course, we need to plant more trees, but we really need to work harder on getting those existing woods into management as well. So, we've got this great target. We want to plant 30,000 hectares of new woodland every year. How good are you at hectares? You imagine a hectare? So it's kind of like an international football stadium, but that's not quite a hectare. But it's a lot of football stadiums, isn't it? So if we're going to do that anywhere close to that, we've got to really transform things. So we would move from 13% to 17%. Doesn't seem that much. We'd still be right down the bottom of that graph, but it'd be better than the current situation. And sadly, though, yes, to be equal to the current level unmanaged. But actually, in the recent years, we're struggling to get to 10% of that target. And you think about it for a while, with the Common Agricultural Policy going and the new ELMS scheme that's been developed by government, farmers are saying, well, maybe I'll get paid better in another couple of years, I'll just hang on a minute. Equally, price of wheat's gone sky high with the war in Ukraine. So it's no surprise really that landowners are saying, well, why should I plant trees? On top of that, the risk, or I'm going to reduce my crop cover, or there's too much shade on my field edges, and all these other issues that we're not being very good at articulating to landowners about. So there's a big problem. And this is why I mentioned this guy earlier, John Evelyn, and his Silver of 1664. He was tackling with the same issues. His issue was really the lack of us being able to bash our nearest European cousins by building great warships. And that was kind of the challenge. So this came along because in 1664, there was looked like we were falling off a cliff edge in terms of timber productivity. And then along in 1919, after the First World War, when we really hit rock bottom, that's when the Forestry Commission was born in 1919, and this massive effort of coniferization saw this hockey stick. It got us up to 10%. So, in summary, what we're saying is we're one of the least wooded countries in Europe. Half our woodlands are unmanaged. We're the second largest importer of the timber in the world after China. Think about that a minute. Is this kind of making any sense? We don't have many trees. We need to import a lot. Okay. We don't have many trees. Let's leave half of them unmanaged. That's not making much sense. It's all a bit of a mess, isn't it? And you think about the amount of money we spend, 7.5 billion importing timber. That's even before you start thinking about wood miles and the environmental picture of that. So, taking another angle on this, talking about wood culture. You're not quite the right audience for this, but I like it when there's kind of families around and say, well, when did you last go to a farm open day and feed some cute lambs? You know, it's a lovely thing. You go with the kids and bottle feed the lambs, and they're very cute and cuddly, and maybe next Sunday after they might have a roast lamb and put no connection between the cuddly lamb and the joint of meat. Apologies to vegetarians. So you see where I'm going with this? We have these beautiful things called woodlands. They're an open-air abattoir, you could say, when the forester's involved with a chainsaw or on a fancy forwarder like they got at Hooke Park, and they fell the tree in public eye. Here's our patron, Martin Wood. This is a 222-year-old oak, so not that dissimilar to the one we saw earlier that John was talking about, grown on the Blenheim estate. And we turned that tree into 80 products, from beams in buildings and boats to even the sawdust went to Le Manoir from Raymond Blanc to smoked salmon. But when I told about these things and showed them the products we made from one tree, it was the noise of the chainsaw and a video of the tree being fell down. People cried, they shouted at me. Genuinely, I went on a roadshow and showed this film. It didn't help that the kids were cheering, cut it down, because we had 400 kids in the woods watching this thing being felled. It's part of the story, you know. But people couldn't understand why you would kill a tree. And you can go blue in the face to say, well, how much wood have you got in your life? And they say, well, what do you mean? Well, have you got wooden doors, floors, skirting, you name it? Oh, yes, I have. Well, where do you think that timber came from? Well, if I say to you, well, it probably came from North America. Oh, that's okay then. You know, it's someone else's problem. And they had to kill those trees for you. The point is, it's not an easy thing. So when you have ancient trees, can we get over this issue that somehow it's something we could celebrate? That what an amazing gift that a forester 222 years ago had the foresight to plant this beautiful tree for me to pick up that baton, to fell that tree, and for me to see those things made from it. And hopefully, I hope all the trees I planted, I've actually lost count now, it's about 100,000, I hope all of those go to great things. And that would be the best thing that I've ever achieved in my life, maybe other than my children, I've got to put that in. But it's a challenge, isn't it? Where, you know, as I said, with my probably very bad analogy around toasters and shops, this idea that the slow relay, this idea of trying to match the vision of a forester with future society's needs is incredibly difficult. And it's hard, it's trying to get the public to come with us. So I'm a massive advocate personally of forest school, this idea where you can get young people embedded in woods in a way that they can just become comfortable with nature. It's the affinity with nature. If you don't have an affinity with nature, you then can't build any knowledge or compassion or skills, the other things we want from a future society. So a small plea, if you don't already, please do forest school in Hooke Park. Right, finally, because I think it's nearly lunch and you don't want to hear me drone on for much longer, a little bit about resilience. So we had really nice stuff from Kat earlier. And it's important, and I'm really pleased, Kat, you said this. Very often we talk about resilience in a very really washy way. So the resilience of what is really important to answer. So In this case, we're talking about woodland. So in Hooke Park, we're talking about the resilience of the woodland. But equally, there's a society around it. So how resilient is the social group around it? The natural system as a whole, not just the forest. How resilient is it? And what is it resilient to? What are we talking about? Are we talking about pests and diseases? Are we talking about flooding, economic fluctuations, architects' crazy needs 100 years in the future? That's what we need to plan for. Maybe they're not shocks, but perhaps they are. Adaptive capacity. So how vulnerable are they? How sensitive to these changes? And what's their capacity to change? How likely is it that the beech we never pruned and it was eaten by squirrels and is now forked could have been now solved with robots producing amazing joints? Great, so we've overcome that by being adaptive. But equally, there might be other cases where we haven't high pruned something or we haven't got the right provenance to grow quality that will never be able to reach the capacity of the system to be efficient. So worst case scenario as a result of all these things, if we have a collapse in the system, Hooke Park, woodland, fails to deliver any benefit for society, the economy, or nature. It collapses, if you like. Or perhaps society around it collapses. We could, perhaps, we managed to, with Kat's and Jez's brilliant interventions with Chris, we managed to recover from some of the worst collapses. We managed to deal with the next pest and disease that's coming along the way, of which there's a list of about, what's the latest list? I think it's about 400 pests and diseases waiting in the wings. You know, you thought ash dieback was bad. There's things coming that will kill every tree. It doesn't matter what species it is. We should be worried, and we should be very, very concerned about it. But we want to be trying to recover. Don't want to scare you now. Ideally, we want to bounce back, because that's another way of what Kath was saying. That's what resilience is to bounce back from something, to get over that curve. But even better, and forgive me my little silly graphic, is to be able to bounce back better. That's what we really want. So we want Hooke Park not only to deal with climate change, to deal with pests and diseases, but to come back stronger. We want John to be really excited by the fantastic timber that's coming out. In 200 years, you'll be looking on us, won't you? Say, did a good job. And we'll remember in the annals of how Jez and Kat came along and came up with this amazing resilience image and this vision. And people will thank you for it. And you will have passed that baton in an amazing way. The legacy you would have left will be insurmountable. So finally, and this is just to bang home maybe some of the stuff we talked, I've got to say silviculture because I'm a forester. At least 2 slides, maybe 1 slide, I can't remember now. So silviculture, just to bang home what Jez was talking about. We've come from a history of single species, even age, and a very simple structure. And it's led to lots of issues. What we want to move is to what that looks like, what Kat was talking about. So we want tall trees, we want small trees. We want multiple species. And we want it to be complex. And therein comes skill, both in terms of foresters and their education, and the market in terms of what we can produce for the market. Thankfully, we've got things called like AI now, which will help us in dealing with these really complex structures. So we want to move from a position where we had very specific markets in mind when we planted. Give you a good example. Let's plant poplar. Brilliant for matchmaking, they said in the 50s. And then someone invented a thing called a lighter. Goodness me, that's no good anymore. So, dealing with specific markets is not a good idea. Oh, by the way, a pest and disease came along and killed all those clonal poplars anyway, so that's fine. Lack of diversity, that's because they planted clonal poplar. They didn't plant lots of different species. Leads to high risk. So that's where we were. That's not resilient. We want to move to multiple markets. We want to invest in great innovations in technologies supported by the high diversity of that forest, and that will lead to lower risk. So that's that's where we're trying to get to. That's what Jez and Kat and Chris will be producing in this plan. It's that sort of forest. You just have to tell them what you want in 100 years' time. Don't forget that. So that is the brilliance of resilience. And don't forget that. That's the brilliance of resilience. So just to wrap up, as I said, silver, we're trying to do that. Those 3 big things. So we want to use our forestry knowledge to innovate and support by good evidence. And it's not just physical evidence, but social evidence. I was really pleased to hear Kat talking about the need to engage with local communities. We want to work selfishly together, and I think it's brilliant that we've been brought together today to have this sort of conversation. I'm really looking forward to getting stuck into some good arguments, good discussions later today. We need to be bold, open, and honest. You know, we need to be able to say to you, I don't know what you want in 100 years' time, but I'll do my best to grow you something good. You need to say, well, I think that's what we might want in 100 years' time. Let's work together, let's keep talking. So we need to accept that we need to alter some of these long-held views and stances to reduce risks and broaden participation and encourage action by all, which is exactly what we're achieving today by coming together. And finally, I'd say, and I think this is what John has particularly done, is to endow people with knowledge, passion and ambition. And that's what I hope this brilliant group of people today will be able to build on. So thank you very much.
We've probably got a couple of minutes for questions. I don't know if you guys want to come up and sit around the table so people can fire things at you. And can I open? Yeah, one at the back. Hang on.
Yeah, thank you. Hi, a question for you, Gabriel. I was wondering if you could expand or define what unmanaged means.
Yeah, brilliant question. So technically the best way to answer this, and you're going to say this is a ridiculous thing to say, is the only metric we have to judge managed and unmanaged is whether there's a management plan. So if you go to a forest and you make a conscious decision to do nothing at all, because that's the best thing, for example, a beautiful wet woodland full of willow and alder that's wonderful biodiversity, the best thing you could do would be do nothing. But you would produce a plan in which you would say, I'm going to do nothing. That is in a management plan. As opposed to someone over there who has an amazing stand of Douglas fir and has never pruned it for 40 years and doesn't have a management plan because they never thought about it. So it's making a conscious decision to manage it, and what you manage it by is the UK forestry standard. And there's a thing called a UK FS compliant management plan. It's a big, long thing. It comes out of a 222-page document that tells you how you should manage your woodland sustainably. And if you go to My Forest, little plug, it's all in the system, and it helps you produce that plan.
All right. Thank you. Thanks for the talks. I only knew about Hooke Park about 4 months ago. So today's talks I thought were fascinating. And actually, the reason I wanted to speak was, I thought your comment about why would you get excited about 150 hectares of woodland? I picked up on that really because I normally live in New Zealand. So, you know, for someone to buy a sheep farm, plant up 10,000 hectares of woodland for tax credits alone is not unusual. But coming to the UK, what strikes you is the preciousness of the countryside, the fine-grained of things as you travel along, say, Dorset. And this prompts me to ask you a question, really, all of you, when you think about the long-term strategy. The idea of planting up timber, cheap timber for, say, construction, is probably a no-no because the free trade deal with the UK and New Zealand would mean that all the timber that's going to China at the moment, which is vast amounts, in 10 years is probably going to arrive here for political reasons. So if you think, well, I need to actually perhaps focus on quality rather than quantity, how could you do that in the long-term plan? And in doing that, I suppose, could you comment on this relationship between not just the timber, but the ecology and society in the context of a rural-urban divide? Because you did pick up about Elephant Castle. I think that's a really potentially a powerful one for Hooke Park. So just to repeat, the whole urban-rural divide, and how do you address that in a beautiful setting like Hooke Park that could be translated that integrates society, ecology, and architecture? I apologize for the length.
I think that's probably a PhD's worth, isn't it? Okay, so well, let's deal with that urban-rural divide first, because I think that's a really interesting thing, as we're sitting in the middle of Bedford Square at the moment, and I have a particular interest in this sort of unwritten agreement between the urban and the rural, that we provide, the urban provides things that we want, Netflix, pensions, hospitals, that kind of thing, that are very nice. We provide things that make you not dead, like shelter and food and these kinds of things. And I don't think that's properly recognised in this unwritten agreement between the rural and the urban. It's perhaps something we can all be part of addressing in quite a serious way. In terms of that production of timber, you are absolutely right. Personally, I'm not interested in producing volume timber in southern England. I'm more than happy for New Zealand to pillage its landscape to produce that kind of timber, or anywhere else in the world. Southern England is so unique and peculiar in the density of its population, the types of landscape it has, these small-scale forests, that producing that volume timber just is not applicable, I don't think, to the landscape that we live in. And you're absolutely right, we need to look at quality. And my feeling is that we can have a whole discussion as to what that quality means, but that's a discussion between engineer and architect and user and forester as to about what is needed and what that quality means. We then have to decide how we're going to grow that within a resilient system once we've defined it. And I think we are getting very good at that. So if you were to go to an estate called Stourhead Weston, that used to be part of the main Stourhead estate, Nick Hoare manages forests that his family have managed for generations and produce the most incredible quality Douglas fir. But they've altered the way they look at the forest into one of these continuous cover systems. So a much more diverse and complex system. And what that's allowed him to do is to look at, when he creates a gap in the forest, is to look at how the regeneration starts. And he can alter the density of the natural regeneration of the Douglas fir in that stand, and the light levels, and the crowns of each tree, and how that relates to the canopy of the forest. And on the one hand, take that. On the other hand, take the PhD that we did a few years ago, looking at the structural properties of homegrown Douglas fir and how silviculture can enhance stiffness, and combine those both together and start to grow really very good quality, we hope, timber. But of course, within this diverse, resilient system, we hope, of course, that there is also the idea that we do have to remember that when people planted all that Sitka spruce, they were absolutely 100% sure they were doing the right thing. And they were doing the right thing for that situation. Just as we might be absolutely 100% sure that we're doing the right thing now. And that is not to say in 3 or 4 generations' time they might look back on what we do and say, what on earth were they thinking about? And that is the challenge of forestry. But
can I just jump in?
Yeah.
Yeah, it's interesting. I think there's also a question of granularity, isn't there? I agree with Jez about the complexity of our landscape, but it's not like every woodland doesn't need to be focused primarily on productivity. You could, within a woodland, try and do everything. So, in theory, there's no reason why you can't have a high-pruned stand of something and a really rich floral and fauna attached to that stand. There will be compromises. But equally, you can have granularity in the sense that one woodland might focus on one outcome, and the neighbouring woodland might focus on a very different outcome. So at landscape scale, you do provide all the benefits of sustainable forestry, but you would lose some benefit in some and gain in others. And that's what I guess the UKFS is about, and what we're trying to be about in terms of how we look at forestry in a strategic way. I absolutely agree with Jez. I mean, the likelihood is people are going to say, what were they thinking? Even if we think we're brilliant and we think we're cognizant, we're bound to be doing something really bad, aren't we? Or very ignorantly.
That's probably just to finish off that bit. That's where people like Kat and most of the people in this room come in, is because Chris and Gabriel and I will be long dead by the time the results of our interventions this year come to fruition, whereas actually it's for younger generations to take that mantle and take the journey on.
I was just going to say, so thanks very much. It's been really interesting. I know that you're all being very politically correct or something like that by describing that you're going to have to think about the future of forestry, but I imagine that you must in your minds already have a view of what you think it's going to be like with climate change happening and London's, or like the south of England's temperature meant to be matching Montpellier's in the future. Do you guys have an idea of what you think it's going to look like? Are there situations where you're already partnering with climates and countries already and seeing what's likely to arrive in the UK? Does that happen? And what do you think it looks like?
Yeah. It's about risk again, isn't it? And I think we should learn from the past where we put all our eggs in one basket, and this is why I was talking about diversity. So we can imagine that all the native species might disappear because they're not well adapted. I'm obviously generalising here. And the best thing we do is go all out on exotics. Let's just plant, Japanese red cedar that they built the temples with, and tulip tree from North America, and all those great things. But they might fail too. And there are those that say, actually, we've got all the diversity we need in our current native species. Geneticists say there's plenty of adaptive potential, is how they put it, in our current native species to adapt to climate change. The reality is we don't know. We know how much confidence we have on the models already provides many questions. I think the simple answer is we need to be as broad as possible and as less selective as we can be, and try and it's not predict, it's to look at the projections that we're given from climate scientists and then deal with the risks, because other aspects of environmental change, such as pests and pathogens, are going to be a disruptor, aren't they? So we can look at all those projections and think we've got the very best species, and then new pests and pathogens will wipe it out. And a great example would be Corsican pine that we heard from Chris earlier. Corsican pine was the next best thing. As when climate change first came out, as it were, yes, we'll plant Corsican pine everywhere, it's so productive, it's brilliant. And then Dothrostoma needle blight comes along, and there's now a moratorium planting. We can't plant it legally anymore because it's so prone to this disease. So the lessons there are about being very, very broad in our approach and not to be siloed.
And this isn't just a question for foresters, I don't think, either, to throw it straight back. It's, if say, what happens if oak fails? It's like any population. If there's a disease, some people or some organisms will survive better than others. In any population, some people get COVID really badly and some people don't. And it's, there will be woodland. The question is how can we use that? So, if we can look this year, or as Hooke evolves, and let's say we're looking at how do we use low-value timber? Well, which is where Hooke Park started. This is exactly the same question. If oak fails or gets a disease, we need to be able to be adaptable enough to think, us designers or engineers, how can we use the properties that oak is giving us, even though it might be failed? Can we use small dimensions of it? Can we use it in whatever forms it comes out in? It's a continuing dialogue about how we use that.
Well, I've got one other thing, sorry, to say about. Also, there's this idea of novel ecosystems in ecology that I think is becoming more and more something we need to think about as in terms of the way that the species are the kind of species composition of ecosystems are changing. And there's, in terms of from an ecology background, there's a very, very strong feeling against any non-native species. And I know that people like the Woodland Trust are very much pushing that we should never look to other countries or kind of expand that. But I think, there just needs to be more of an openness within that, but then also still remembering the potential risks associated with the diseases that are coming in. But yeah, it's like a balance to be found within the openness.
I've got a question here from the back. You made a very strong case for planting more trees, which I think is quite tangible. And I picked up the use of what you do in forestry is kind of material, but also a little bit of energy. There was a little bit of talk of that. But I picked also up in your slides that there were some mushrooms and there were some pigs. And here's my question back to you, because if we start planting more trees and increase the woodland cover, we're probably invariably going to replace where we farm food. Now, if that food is now then farmed elsewhere, perhaps where now the Amazon rainforest grows, I think it's a really bad deal. So my question will be, can we think about even bigger on the forest and make food production part of it to make it more resilient, more protected, and even more productive?
I mean, simple answer, yes, absolutely. We do not make enough of the non-timber products from woodlands, without a shadow of a doubt, and it could be a huge food producer. Similarly, of course, there's a lot of other products from the trees themselves that can be competitive against timber for architecture as well, not least of which the volatile organic compounds in wood that can provide pharmaceuticals and biochemicals as well that we need to be aware of. Probably if we want to get best value from our woods, we could ignore growing quality timber and just grow it for the amount of volatile oils in it to get essential oils out of. But this question of food versus timber is a really important question that I think as a society we need to address and consider more. I don't have an answer to it, but...
Well, it's also slightly annoying. No offence to you. Did you know there's more trees in London than all our national parks combined? Right. So I want go speak to people and lobby people to say, why is this? Why are we conserving green deserts? For the sake of a few sheep and ponies that go to dog food. So is that sustainable land management? No. So could they be rewilded or planted in the valleys and create marvellous green fringes? And they might not be the most productive lands, but they could be amazing space for biodiversity, freeing up other areas to do maybe more productive forestry. I'm not discounting a very good question around planting trees on quality arable land, but I think in a more strategic sense, we've got a lot to fix, and we have to break something up in our brains, our perceptions of what wild is and what good is. And people think national park and wilderness. We don't have wilderness in Britain, we have green deserts, okay? And when we have urban forestry, we create green fluff. So they have no purpose at all other than for people to allow their dogs to poo in them. I mean, we should be producing timber from those forests on the peri-urban and urban forests, shouldn't we? As well as the green space and clean air and all the other benefits. We can be much more creative and innovative in what we do in forestry and land use.
It's not an either or, it's both and.
Yeah. I think, just mindful of time.
Kate, John had a question.
Oh.
He was burning for question. I could see him jumping up and down.
It's been radical with foresters among us. It's a slightly radical question with foresters among us who think of planting trees with a 100-year timeline. Having used small diameter timber to build buildings and recognising its structural benefits, is there a case for planting very dense woodlands and harvesting them much younger in order to use roundwood rather than sawn timber? So we use nature's input that is so large, with using less energy in processing the produce.
I think we have fallen into a trap of talking about 100 years, haven't we, as a group, which is really bad, because if no one's looking, I will go and hug the trees that I've planted, and I'm not that old, somewhat about 30 years ago. They are huggable, large trees that could be made into beams, furniture. Some of them are walnuts, yes, it's true. Some of them are Douglas fir and other conifers. But that's, you know, a relatively short career so far, 29 years, something like that. Decent trees in a generation. So you're absolutely right, John. Thank you for putting us up on that.
I do think there's... yes, we are being way too either or. And actually the question is not dissimilar to the food or forestry question. In a complex forest, there has to be both. And so I would, planting very densely to create intensive timber, I think it has a place in the forest, as long as the long-term plan is that moves around. You can't continue growing that. Otherwise, we end up with the New Zealand situation where we denude our soils to the point where it has an impact on the timber quality as well. And I think it comes back to this sort of craft and knowledge-based approach. It's having foresters like Chris who know a site inside out because they have worked there such a long time, allows that site to be maximised for its ecological resilience and its timber as well, and to know that perhaps that soil isn't suitable for that type of forestry but is suitable for that, or we've grown intensive small roundwood here and next we're going to grow it over there to give that land some time to recover. I think that it's about creating that complexity in the forest.
I'm going to be a party pooper because this is amazing.
No, I'm starving.
In the interest of time, we are going to break for lunch now and come back at 1:30. So you might have to scarf it down a bit. But thank you. Just an amazing morning, honestly. Just so informative, so interesting, so exciting. I hope you guys will stick around to interrogate the rest of the panels for the rest of the day. And we'll have a big Q&A at the end of the day, so we'll be able to bring back these themes together with the other two panels. All right, thanks everyone. Cheers. We're going to kick off with session 2, which is, as we mentioned this morning, this kind of sandwiched subject matter between what are seemingly disconnected or maybe realms that don't talk to each other of forestry and architecture. This here is the glue that holds it all together, hopefully. And we've got Alison Crowther, who's a sculptor and a furniture maker, who's going to talk about her amazing sculpture in wood. We've got Sean Sutcliffe, Benchmark Furniture. And we've got Andrew Lawrence and Francis Archer from Arup. So hopefully this takes us in a kind of, what I said earlier was the kind of wonderful materiality of wood through to maybe some more kind of technical understanding of where that materiality comes from. I'm going to stop talking and hand over to Alison.
Hi. Is that working? No. Is that working? Yeah. Great stuff. Right. The essential thing here is to get your hands on some wood. So I'm going to ask my assistant Kate here to just hand out a few of the tiny pieces that we make that are carved from solid pieces of timber. There are also a couple of sketchbooks that are going to be passed around. Please don't hog them, please pass them around. I want everybody to have looked at a sketchbook and everybody to have handled at least one small piece of sculpture. Okay. I trained as a furniture designer at the Royal College of Art and graduated in 1989. But I would think of myself now in terms of being an artist, a designer, a craftsperson, what else? A wood carver. Did I say sculptor? Oh, and furniture maker, yes. I think my work spans all those things, and hopefully I'm going to show you now some of just a small example of what we do. I'm saying we. I have a small team of assistants sort of 2 to 3 most of the time. Sometimes that swells to more than that, up to 5 carpenters at one time, according to the type of project that we're working on. We make work that's both for private commissions, private clients, and also for corporate clients. And we work from a very beautiful, purpose-built timber frame studio at the foot of the South Downs, within the South Downs National Park in West Sussex. And that is over 30 years since graduating. So 30 years of working with one material, and that is unseasoned English oak. That's predominantly what I use. The timber frame studio we moved into a year ago, and it's taken that sort of 30 years of a career to get to a point where I have a space that is my own and that I can do entirely what I want to do there. So I started in mum and dad's garage, while still being a student. I moved on to various other garages, and then other various units and unsuitable spaces, maybe outdoor or indoor, barns, drafty barns, leaky barns. But now eventually we've got this beautiful space in which to work. So this is a small selection of what we do, and the purpose for that is to keep it concise, but also to focus in on a few of the things that are very important to me working with that material, working with English oak, unseasoned. So this is a picture of scale tree 4. This is one tree, one piece of English oak, and the entire surface is carved with this geometric pattern of diamonds. Some more descriptive images of the same piece, showing the whole ellipsoid shape to the left, in the center showing you a detail of the carving, and this highlights the fact that the material is unseasoned, it's green, it's going to give off an enormous amount of moisture and begin drying and cracking and shifting and moving. And that's something that I welcome and have learnt to hopefully turn to my advantage in the works that we produce. And the slide on the right, or at the right of the slide, another angle which shows what I term as the missing part of the ellipsoid. And this draws the fact to the point that trees, English oak trees, are not perfect cylinders in cross-section at any point. They meander and twist, and actually one of the diagrams here is particularly to sort of explain that missing area from the tree. Okay, thanks. We've done scale trees before. This was done in 2017. This was for a corporate client. This is a large building, One Shenzhen Bay, designed by KPF architects. And this is in the main foyer. There's stainless steel fixings embedded in the foundations of the building underneath the floor surface. This is part of the same commission. These are pieces at the other side of the main foyer. The reason I put these in is that you see the cracking beginning on the sculptures is in line with the pattern, the texture that I've designed onto the sculpture. So this is starting to talk about moving on from the missing piece. This is me and the tree. This is me and the material in conversation. The tree, the material suggests. I, as artist designer, then accept or move with, or so it's talking about this conversation with the tree. Looking closely, looking intimately at the material is what I love doing. And this is a very small scope, well, quite small, 200 millimetre, not as small as the ones that are going round. Please make sure you're circulating those small pieces. Because if you've got hold of one of those tiny pieces, you might look at it as I'm talking about this. Here I've carved the annual rings, the annual growth rings. You all know what, a lot of you will know what I'm talking about, but if you don't, just for clarity, there's a bit of timber technology here. So this is the annual rings that I'm following, carving around that sphere. On a bigger scale, this is 1.2 meter diameter. I've put this in for explaining. This is the annual rings carved again, but because of the undulations that I've put onto the surface of the sphere, the annual rings are thrown around in different directions, giving more liveliness to the form. And also, this shows really, really nicely a concave area, which is that missing area of the tree. So the sphere was a bigger diameter than the tree that the sculpture is made from, and that concave shape is that memory of the original tree. Carving the annual rings, working with material. This was produced this summer, so it was installed in October in a private garden in Umbria. You see the cracks here going right across the annual rings, and these are in line with the things called, or they're an integral feature of the wood. They're called medullary rays. And in oak, you can see them with the naked eye on the surface of the wood. Medullary rays are cellular transport systems that are like the spokes of a wheel on a bicycle, and they take away toxins and tannins and things that the tree does not want. But crucially, it's where the unseasoned timber will crack. These are just some nice views of the garden, and also showing that missing area from the tree on the right-hand side. Knots and details within the timber that I call dilemma areas. So this might be something that is problematic in certain areas of working with timber, but they're areas that I celebrate and want to excavate. I'm still following the annual rings here, but there are also points where there is an artistic judgment to be made, and what one person decides to do and what another person decides to do might be slightly different. And this is something that brings into play this spirit of the maker, if you like, and something being particularly made by a certain person because of how they think or how they react to the material. This is incised walnut 1. So this is taking that, looking at the timber to even more intricately. So this is the medullary rays, a grid produced by a combination of the medullary rays and the annual rings. So if you think of a globe with latitude and longitude, the latitude are the annual rings, and the longitude are the medullary rays. So this, the previous slide was kind of an experiment, but an experiment that took probably a few months to make, and that is realistically what we're talking about here. These things take months to make. So this is Uovo, the egg, which was finished last December, about this time last year. And this is the grid of those annual rings and medullary rays on a scaled up version, if you like. The incised walnut is about this size. And as soon as I made it, I think somebody mentioned as soon as we got these small pieces out just after lunch, the scale of them, and said, yeah, I'm always imagining when I do something on small scale, imagining it, wouldn't it be amazing to do it on a giant scale? So this was courageous clients who were willing to let me take the grid to a bigger scale. So the cracking is starting already, and because the cracking is where the medullary rays are, the cracking is in line with the verticals of the grid, if you like. So visually, what could be a really busy, bonkers surface hangs together in a much more coherent way because the cracking is in line with those the grid. Oops. Sketchbooks. Where are the sketchbooks right now? One's there. Oh, you're next to each other. Come on, you've got to circulate them. They've got to go around. They've got to get round everybody. So the sketchbooks for me are where the thinking happens. It might be to do with a particular project, but it might also just be things I see for inspiration. These were the first sketches done towards the project for Shenzhen Bay with the 5-meter high scale tree. So that was looking at fossilized lepidodendron trees. But the sketchbooks are research, the sketchbooks are development, and I'm constantly going back to the sketchbooks throughout the development of a project. It's not just at the beginning for the idea. It might come back when things perhaps have to be rethought, and also parts, details developed, and so on. The raw material. There have been discussions this morning about woodland management and forestry, replanting and so on. And I could talk so much to you about that, but I'm not, because I think there isn't time. But some of my timber comes to me from storm-felled or wind-blown giant oak trees. And this is one in that same category. This is head forester Neil Humphreys, who manages a massive estate on behalf of a private owner, a private individual. And these forests have been managed for centuries down that family. And yeah, I said I wasn't going to talk about that. I'm not. So I might have storm-felled or wind-felled timber. This has come down. We're assessing whether it's usable, if there's rot somewhere, what size of timber might we gain from this tree. And also, I use timber that's taken down as a legitimate crop. And this would have been planted over 200 years ago. And it's only 5 years ago that it was felled, that actually that crop is gained, if you like. So there was talk this morning about investing for the future. Well, I gained from that forester's investment in the future 200 years ago. So this was the tree taken down for the scale tree that's in Shenzhen Bay. And that weighed about 9 tons when it came to the studio. So I'm going to talk about process now. And the process starts once the log comes to the studio with power tools. And first of all, chainsaws, and that will go incrementally smaller as we're getting more to the refined shape. And we use chainsaws in conjunction with templates and also a thing called an Arbotech, which is this brilliant tool. It's like a regular angle grinder onto which you put a disc, a rotating disc that just chews through the wood. It's brilliant, but it's noisy, it's dusty. You need to wear stuff so you don't get white man's dead finger or whatever it's called from vibration. So yeah, but it's a brilliant tool and can shift the timber. And this is the template for the scale tree one, the 5 metre high one. This was when Phil and Garth had just got the template all the way around the form. Problems in the timber. So that might be to do with rot or shakes. Somebody talked about ring shakes this morning. Don't want that. But we really don't want ferrous things in the timber. But I tell you, 9 times out of 10, there is something ferrous embedded in an English oak tree. And you know about it when you come to it, and you know about it when you come close to it, because it gives off this inky blue staining around it. And that tells you the presence of something ferrous. It's basically the tree dissolving the metal. So this was sorry, Kate, I just need to say, another thing about this. So that is actually barbed wire that the tree has absorbed and grown around. So people will nail fences to trees. I don't know why. Well, I do know why, because it's convenient, isn't it? A great big stable tree, and you've got a fence. Farmers will nail fences to trees, and then it gets forgotten about. Even nails hammered into things. We come across lead shot sometimes. Copper things we come across from old-fashioned communication systems. But the worst thing are the ferrous things that are embedded, and that's nails and wire and so on. This is woven, and we've left that bit of barbed wire in there, because if I excavated that away now, it would have taken away perhaps part of that crucial top edge of the grid. So we've left it, and we meandered the grid around the barbed wire. So we accepted that. It's part of the history of the tree. Model making. Sometimes the process requires, especially if it's for a corporate client, there to be approval of the design, or we even sometimes do full-size samples of the carving for approval. Marking out. Marking out is absolutely crucial. You can't just start carving on that surface. It needs to be designed. We use maths and geometry to work things out. But this is the grid for a wovo, where the maths really is the maths within the tree. So it's the annual rings with those concentric rings, like the latitude, and then the medullary rays, like the longitude, going from the North Pole, if you like, down to the South Pole. And marking out can also not be straightforward. And I think this represents a whole Christmas holiday, working out sort of little intricacies of the grid, because the tree gives me so much, but then there are little artistic decisions here and there that maybe are crucial to the design. And you could just go wholeheartedly with the tree, being completely true to the tree, but sometimes it improves the design if you just sort of nudge it around a bit. And that was there to show you how that resolved, how the lines were resolved, and the scale of the egg. The tools. So the carving is done entirely by hand, and that would be conventional gougers and mallets, but also timber framers tools, letter carving tools, and perhaps tools that I've acquired along the way, even from China and things like that. Working with others to produce the huge sculptures, it requires that others work with me, maybe because of a time scale Yeah, usually because of schedules, something's required by a certain time. So these were timber frame carpenters, master carpenters that worked with me on Scale Tree 1. And they brought their own tools and developed their own system for carving out each of those diamonds. But everybody came to the same result, the same quality result, but they may have gone about it using a slightly different tool and a slightly different method for how they get that waste wood out. We can keep going, Kate. Nearly there. So, as I said, there were up to 5 carpenters working at one time on that Scale Tree 1. So, positions. The job is very physical, and it requires you to be in some strange positions some of the time. The method for extracting the wood, I just said, you know, what one carpenter does, another on the scale trees. It was possible to have lots of people working on that size of piece, and also because the diamonds were all the same. But on something like a rover, each section is unique. Each section was completely different. We could establish the depth with a drilled hole over the entire... There were 768 sections to carve. Yeah, and you needed a range of tools for each section. So you can't just have a method like you can for cutting the diamonds. You need to be deciding and switching tools the whole time. That's working with others again. So this was in the summer. This was Tom and Phil, who did all the diamonds on that piece whilst I was carving La Sfera, the sphere at the top of the shot. Carving the annual rings, it's not as simple as just taking a V-tool and carving along each line. Sometimes there is lots more excavating to do, and I talked about those dilemma areas. It might be that you shift and change the design slightly as you're working. That was a video, but I'm not sure if it's come through as a video, just to show you the carving. I think it hasn't come up, has it? I need to stop now, don't I? So we can whiz on. I think we're nearly finished. Oh, it is doing it. Whoa. Just for a few seconds to show you. So I've got to put the brakes on there because I've come to a crack. So that's the first pass on the each sort of groove, if you like. You then have to go back with multiple passes, different tools to get the right curvature and so on. So it's very labour intensive. And then finally, the cracks are cleared out of splinters. We put linseed oil and terps to protect the wood, and then it's off, transported often to the other side of the world. Yeah. This I've put in just to say this was drawn at the time of that Scale Tree 1 being carved, 768 diamonds. This was drawn out by my son, my eldest son, who was 13 at the time. He's now 19. And I've got 3 sons. So this is just to say there's a whole family going on at the same time as all this work happening. There's normal life and family, spinning player. People will know what I'm talking about. And then the other family is my small but perfectly formed team at the studio. And that's it. Okay, thanks very much. Oh, we do need to have the little pieces back, actually, and the sketchbooks. Thanks.
Hello, I'm Sean Sutcliffe. I'm a furniture maker I've been a furniture maker all my adult life. I started my proper professional furniture making career under the tutelage of John here, who I've known for over 40 years. And it was whilst I was at Parnham doing a design and make furniture making course that John bought Hooke Park. So I've known Hooke Park throughout its life, and was happily went down the other day. Anyway, I'm going to talk about, well, I've called this Why Wood is Good, or Wood is Good. I've had a whole life spent working wood, and I can tell already that I'm kind of preaching to the converted here. I don't really need to tell any of you that wood is good. Maybe we'll pick up some of the nuances of why, my personal perspective on why wood is good. The strength of nature. Trees are believed to be 350 million years old on Earth. It's quite a long time. Man, 350,000, modern man. So about 1,000 times older than we are. And in that time, they have learnt a lot of tricks that we have yet to learn. And one of them, of course, is strength. By the way, for the foresters here will of course notice it's a healthy ash tree, something we're seeing less and less of. And this amused me because this is the oldest discovered human dwelling. It's believed to be 300,000 years old. It's in France. John, does it remind you of anything? Something quite close to your heart down in Hooke, 300,000 years ago. And for those 300,000 years, we built a lot of buildings. In 1666, so 2 years after the first silver was written, this happened, and it kind of put the brakes on our confidence in building in wood in quite a big way. And yet somehow we seem to have got our mojo back. And actually, I wonder, Kai, where's Kai? Are you building that? No. Okay, you know what it is. Yeah. This is the tallest building, wooden building under construction. It's a 100-meter tall building. It's in Austria, I think, isn't it? Yeah. And it kind of shows that the confidence with which we can now approach wood as a material. I mean, we'll all have some questions about this. And this is this is another building under development. This is the largest wooden building scheduled to be in London. This is in Queensway. It's a Foster & Partners project called the William, and it's a CLT construction project. And again, I think it's a really brave and insightful use of CLT. John, we're back to the 300,000-year-old building. I mean, not a lot moved forward, did it, in 300,000 years, except maybe we rediscovered what they found out a long time ago, which is that nature grew a tree very strong. And the closer we can use it to its original form, then not only are we saving a lot of processing, a lot of energy expended, a lot of carbon, but we're actually using the material in a much stronger way. This is the workshop down at Hooke, as I'm sure many of you will recognize. This really fascinates me because this building, for those of you who don't know it, the trees were scanned, the standing trees were scanned, and the building was designed around using the optimal strengths. For somebody who knows better than I do about this, someone will shoot me down, I'm sure. But produced a building which I think is remarkably poetic and beautiful. Here she is under construction, using it pretty much all under, I guess it's pretty much all under compression here. And there it is, it's a wood store, open wood store for storing biomass. And I love the way that this really has utilized the benefits that nature, that 350 million years of evolution of trees taught them how to be strong, and now we're kind of trying to harness some of that acquired knowledge. This building is another Hooke Park building, which is still using the roundwood. I mean, this is a very different approach to the structure, but I still think, it's essentially using all roundwood for its strength, inherent strength. And then I started working with this guy, Simon Geering, who's a German furniture designer. And it kind of, at a miniature scale, he's doing exactly the same thing. Can you guys see? Am I standing in your way? Okay. If I sat down, would it be better? No. Okay. And I really admired this because it's essentially using the same theory and the same lesson of, of course it's really hard in production terms. I would not like to be producing this furniture myself, but I love it for its closeness to nature. And a chair. I mean, it's kind of visionary and beautiful, I think, but it would be very, very difficult to produce this at any kind of commercial scale. However, this building, this is in Devon, it's a timber storage shed, and this is actually the largest span. So that, going back one, we're looking at kind of using nature, using wood as nature grew it. But for the most part, we don't do that. For the most part, we manipulate it. And this building is the largest single-span, British-grown glulam building. It's made of, I guess it's, actually, I don't know the species. It'll be a softwood species. Did you engineer it, Andrew, or France? No, right. But I really like the scale of it. I'm so used to timber barns, and they're always steel. I love the scale of this and the fact that it's on the land where the timber grew, and it's storing timber. A very lovely building to be in. And then this is a fabulous building. This is Homerton College, Cambridge, designed by Field and Fowles. And again, it's using glulam. In this case, it's sweet chestnut glulam. And we'll come on to the reasons of sort of why wood is chosen for its obvious benefits in terms of carbon sequestration. But this is kind of a fabulous building in terms of it, the scale and the airiness of it, and the singularity of the material within it. It's really charming. Actually, this scooped the Wood Awards last week with 3 Wood Awards. Never seen that happen before. But it's a really stunning building. This is one that we were involved in. This is a CLT project. This is Niall McLaughlin Architects, and it's an Oxford College accommodation. And we worked on all these buildings. And one of the things that it was really informative for me, this was the first CLT project I worked on of any scale. And I went to site on a really cold, miserable January day. And I'm very used to being on construction sites. And the thing that immediately struck me as I walked into this building was that it was pleasant. And concrete construction sites are never pleasant in January. This building was still open to the elements, and yet it felt warm. The oral resonance, the sound within it was really pleasant. It felt good underfoot. It lacked that harshness of concrete. And suddenly you realize, it was a real eye-opener to me that CLT creates beautiful environments to be within. It's all clad in brick on the outside, so you wouldn't know walking past it that it was a CLT building. And this is a little building we made as part of an exploratory project into thermally modified timber. This is a sort of rotating shed built in thermally modified ash. And so we're looking at, my journey here has taken us from the natural, what nature produced in its round wood, and utilising the scanned shapes of it through the processing via glulam, through CLT. Thermally modified, I think, has a huge role to play. I mean, to me, it's utterly tragic that we have one single thermally modified plant in the UK. I mean, my wife is Danish. We spend a lot of time there. There are lots of throughout the mainland, and you will bear me out. It's not unusual to find thermally modifying plants in mainland Europe, and we have one sort of experimental one, which limps along. But it's a way of, by heating the timber, for those of you who don't know it, by heating the timber, to somewhere about 160, 100, about 100, okay, about 100 degrees for 48 hours. You're burning out the parts of the tree that the microbial life will like. You're burning out the sugars that the microbial life will live on, and therefore you're protecting it from microbial attack. And so ash that you never could normally use as an exterior timber, and all the non-durable species can be thermally modified and become durable species. So I think that's got a real future and a real good way of harnessing a lot of wood that is currently undervalued because it's not durable. Durable, for those of you who don't, for us woodworkers, durable is a very specific term. It means, does it rot outdoors? Can it live outdoors? Can you use it outdoors? So it's slightly different to most people's understanding of durable. And then in my workshop, we did quite a lot of work with American timbers. And for reasons that we'll touch on in a minute, I'm actually quite a big fan of the American forestry system, or lack of system perhaps. And this was one, Andrew, you will recognize this, you can see yourself in the picture. This was an experimentation with looking at the properties of red oak opposed to white oak. And so we built various exercises, we put it through its paces of the sort of typical processes that we as furniture makers and joiners would expect to use in our woodworking lives. Whether that's bending or top right, we built a little jig for stress testing, brake testing it, twisting, bending, and we destructively tested it all. And then Andrew gave us the benefit of his opinion, in which, although he did, I remember him saying, it's not really scientific enough, Sean. We needed a bigger sample. We did like 5 of everything. And he said, you really need to do about 105 of everything to get something that was meaningful. But nonetheless, it taught us quite a lot about the properties of this timber. And I think the purpose of me showing you this is that I think in my workshop, and I know in your workshop, research is absolutely crucial to how we move our woodworking forward. So in this case, it was really looking of how could we start using American red oak, Quercus rubra, as opposed to the Quercus robur that we're more traditionally used to, and could we expect the same results? And there's a very good reason, we'll come on to in a minute, for why we would want to use Quercus rubra. But without this starting point of taking an analytical and sort of semi-scientific, it's about as scientific as I can get in my workshop, approach to it, we wouldn't have known these answers. And so I really encourage everyone, and particularly obviously Hooke, to pursue this adoption, the integration of sort of analytical and engineering approaches into our woodworking, because that way we will develop our knowledge a lot more. So, for those reasons, one reason wood is good is it has tremendous strength. It over 400 million years, it has 350 million years, it has learned to be very strong. Most people, very few people would stand up and give me an argument about about wood not being the most sustainable wood material in the world. I will argue very strongly that it is. But why is it? Of course, it's only sustainable if it's renewed. So the certification process, whilst deeply flawed, far from perfect, is really important to us. And FSC, the one that you probably are most familiar with, is beneficial. It's far from perfect, but it's very beneficial. PEFC being the European mainland equivalent and stream of it. So we have to know with confidence that the material we use is being replaced equivalent or more in order to claim its sustainability. That's really crucial. And then we get to the dilemma when we get to America, that up until now they haven't really had any sustainability certification scheme and equivalent to FSC or PEFC. And the one thing that we can tell by satellite imaging over the years is that the forest mass, the hardwood forest mass of North America is increasing year on year, quite a lot. So we can take a sort of global view and say, okay, globally, it's a sustainable forest. but they are now working quite hard on a new standard. You may be involved in it, you are involved in it? No, okay. In actually getting a more specific sustainability in place. But this kind of throws me back to red oak, because sort of between 35 and 40% of the entire hardwood forest mass of North America is a single species, Quercus rubra, red oak. And it's massively undervalued. I mean, its price on the market is less than a third of white oak, which means if you're a forester in North America, what do you do with all your red oak? There is not a sufficient market for it. And because their forests are managed in a very different way, I mean, they're pretty much all the East Coast forests of North America are naturally regenerated. They're selectively felled and natural regen, which kind of comes back to the sort of continuous forest cover that was spoken about earlier. But if nature grows 40% as a single species, then we have a responsibility to use 40% as a single species. So I'm actually very active in trying to persuade architects, clients to use that material. I continually get the question, what about the transport miles? The transport miles, as sea freight uses less than 1/10 the carbon per ton than road freight does. So I can afford to go 100 miles for every 10 miles traveled by road. And so we've done the carbon calculations from sort of Pennsylvanian grown red oak, and it's coming at a reduced transport carbon cost to my workshop than white oak, which principally we're buying out of Croatia nowadays. And that's making the journey from Croatia through the French mill system and up to us, considerably cheaper in carbon expenditure terms to bring over red oak. So we sort of counter that argument. But what I was very taken by the images of the forests, and Gabriel, your sort of what a healthy forest looks like, an unhealthy forest. I think this looks like a pretty healthy forest. This is very mixed species, and it's a result of natural regeneration. Now, why? Probably you all know this, but a lot of people don't. When I say that, then when I boldly say that every ton of wood contains 1.8 tons of sequestered CO2, people go, well, that's impossible. I get 1.8 tons in a ton of wood. You all know that plants and trees especially breathe in CO2 and they breathe out O2. And the missing bit between those is the sea. So where does the sea go? The sea gets sequestered into the structure of the tree. Some of it also gets sequestered into the root and root cell respiration and sequestered into the soil. But the greater part of that sequestered carbon is in the structure of the tree. And half, and it's kind of unfortunate that it is half, because everyone thinks it's when you say half of something, everyone thinks, well, that's a made-up figure. But between sort of 48 and 51% of all trees of any species anywhere in the world, half their dry mass will be carbon. So it's really accurately 50%. So how do we get to that figure of 1.8 tons? You'll all remember your atomic weight from doing chemistry at school. So carbon has an atomic weight of 12, oxygen 16, so the atomic weight of CO2 is 44. In order to get the ratio of carbon, sequestered carbon, within the forest, within the mass of trees, you have to divide the 44, the CO2, by 12, being the atomic weight of the carbon molecule, and you get an answer of 3.67. So the ratio between carbon dioxide and carbon is 3.67. But remember, a tree is only half carbon, so we get to 1.8. And that's how we can tell you that 1 ton of wood will contain, in its dry, raw form, unprocessed, 1.8 tons of sequestered CO2. And that's a really important thing, because that's the crux of what makes timber the most sustainable material in the world. So 10 years ago, this year, we started working on life cycle assessments, and we did a project then. I can't remember whether you're involved in that one, Andrew, but with Imperial College in London, PE associates in Stuttgart who were sort of early adopters of life cycle assessment. And for those of you who are unfamiliar with life cycle assessment, and we did this with the Royal College. These are Royal College students, a very young me 10 years ago, look, and Imperial College who gave us the kind of the knowledge base the scientific knowledge base to feel that we were making some progress towards a reliable way of measuring the life cycle assessment. And a life cycle assessment or life cycle analysis looks at the cradle to grave impact, environmental impact of anything. In our case, it happens to be furniture. It could be a motor car, it could be a microphone, it could be a chair, whatever. So we have to take the raw material, we have to count at every process along the way the inputs that we're putting into this. So the carbon expenditure, the primary energy, whether it's renewable or carbon fuel primary energy, that it takes to fell it, transport it, mill it, crucially drying it. This is the biggest carbon expenditure in the processing of wood. Transportation, core processing into product, packaging, transportation, and then the downstream. Now, in the case of wooden furniture, there isn't much downstream, but if you're making a motor car, there's a hell of a big downstream, a diesel car, there's a hell of a big downstream evaluation to be made on that. So, and we have to measure the top line down to the truck arriving at our workshop. We have to rely on external assessors within the timber industry knowing those figures. And the Americans were much quicker to do this than the European timber industry. The European timber industry is now doing it, of course, but they were much quicker to be able to give us those figures. We have to measure our own core process energy. So we time every process, every machine, we know how many kilowatts it is, and that all goes onto the sum that we add on to the carbon cost. And it's not just carbon we're measuring. Packaging, we personally we try to reuse all our packaging. We make a virtue of that. We use no plastic packaging. Transportation is quite measurable. And then lifespan is kind of arbitrary. I mean, my base rule for my workshop to all my staff is every decision you make, you think, can it last 100 years? That's the baseline. If we're less working for Oxford or Cambridge College, when you say, will it last 200 years? But we don't give everything a 100-year lifespan. We actually trim that back, and that's a judgment thing. And then, of course, you can recycle. There's a recycling back in a sort of circularity argument, back in from potential end of life, back into repair, refurbishment, and reuse. And that's something that's much bigger for us. And the figures from that then feed into the 6 kind of primary polluting elements that we measure when we're doing life cycle assessment. So primary energy from non-renewables, primary energy from renewables, global warming potential, GWP, and that's what everyone's focused on now. Pretty much everyone is now focused on GWP, on global warming potential, the carbon element of it. But eutrophication, which is sort of nitrate leaching into waterways, is still a very significant pollutant, and that has to also form part of the calculation. Acidification, those of us who are old enough to remember when the big fear was all the talk was of acid rain, everyone's forgotten about acid rain now, but there are greater imperatives. And then the photochemical ozone creation, that's kind of low-level ozone. I mean, broadly speaking, you've got to think in ozone, high-level ozone good, low-level ozone bad. So the POC is an important measurement. What we do with that information, and we did this 10 years ago. We started doing this, and we've done it ever since. And more recently, for the last 4 years, we've been producing EPDs. Some of you will be familiar with what an EPD is, an environmental product declaration. We can't produce them, they have to be externally produced. We can provide our data. The data then gets evaluated by a third party verified, and the figures are produced. They're impenetrably dense and boring. I meant to bring one with me, I forgot to. But the beauty of it is that they're publicly accessed. You can see these, all EPDs are a matter of public access. That they can be fed straight into your BIM system. For the non-architects amongst you, a BIM system is a building information modelling system. So if they have that EPD, they can feed it in at design stage, and they can therefore calculate a number of things about the building model of what it will be. But critically at the moment for buildings that are trying to be net zero, they can include that. And that's why we're seeing so many more buildings being built in wood. One of the masters of building wooden buildings has just walked into the room here, Alex DeRiker, and we're seeing a really significant move towards wood because of the demand from developers for carbon neutral buildings. So my second point about why wood is good is this point about carbon sequestration. It's crucial. One of the things we do more and more now is circularity. And everyone kind of talks about circularity. My simple definition of it is keeping anything that exists at the highest possible value for the longest possible time. So in this case, this was a reception desk we made for a building in Bloomsbury about 15 or more years ago. It was taken out, the building changed tenants, they changed the whole lobby. It was going to be thrown away. We repurposed it and we resold it to the Cambridge Institute for Sustainable Leadership. There is no new material in the top right picture. There is no new material. Completely different configuration, no new material. And I think that whole circularity thing is something that wood lends itself very, very well to. There are a lot of things you cannot, that are much harder to reprocess, to remanufacture, or to alter significantly. And this is another example. This was a table. This was the Ace Hotel. I think we did this about 12 years ago in Shoreditch. Changed ownership. I know the new owners, and they said it's a real pity that we don't really like that table in that space. And I said, well, let's modify it. There it is, same table, no new material. So square-ended, D-ended, ebonized, clear, lighting on it, no lighting on it. Other than that, there is no new material. And so I think that circularity thing is another very good reason wood does lend itself really well for circularity. And then wellness, wood and wellness. And the master document, I have a copy of it over there, I'll put it out for those who do. There's Dr. Ed Suttie, who some of you will know from BRE, produced a really excellent document on the role of wood in healthy buildings. And as we focus more and more on the health and well-being of the built environment, and goodness knows the developers, the property developers are really pushing for this now. We have taken this on board in a very big way. And so there are qualities that wood has that are very, very beneficial. And the key one, I think, is its biophilic nature. There's nobody in the world who doesn't love handling wood, whether it's a bit of old driftwood or whether it's a manufactured product in wood. This is a building that we worked on down in Bordeaux. It sits very beautifully in its landscape. And it's kind of a real example of how a predominantly timber building just sits more beautifully, and you get it's a really lovely building to be in. A lot of wood outside, wood inside, wooden furniture. It was a joy, and that's really kind of this biophilic nature, which appeals to our parts of our brain. Obviously, we've got our reptilian brain, our old prehistoric brain. Our limbic brain, which all species have a limbic brain, and then what makes us clever in human beings is our neocortex, our big frontal brain. What we've discovered, and is well documented now, is that this connection to nature, this sort of biophilic element, connects directly with our limbic brain, and it's our limbic brain that controls our emotions. So it's not our neocortex that controls our emotions, it's our limbic brain. And it's that connectivity directly to our limbic brain that gives us this kind of... It's why, instinctively, everyone loves wood. I'll say that boldly. But everyone loves wood. And I'm a big believer in instinct. I think that instinct has become less trusted. We don't doubt that the swallows in my barn fly to Africa and somehow, miraculously, even at 1 year old, manage to come back and nest in the same barn 2,500 miles away. We accept that. It's instinct. We accept that a salmon swims out and travels thousands of miles at sea and returns to the same pool in the same river that it was spawned in. We believe that. That's instinct. But as human beings, I really feel we've lost trust in our instinct. And I regard instinct as just a sort of distillation of 300,000 years of empirical experience. You know, we used to trust our instinct. We survived on our instincts. And then modern science came along and robbed us of any trust in that. But there's a reason why we all love wood. And I would say it's instinctive, and so we should trust it. Go? Okay, I'm going to rattle through. So, another beautiful building. This was in the Newt in Somerset. The adoption of trees into buildings, really big thing now. This is a project I did in Cleveland, Ohio. It was a medical school, and that was the CGI, but okay, here it is. The trees are not as grand as they were in the CGI, but I hope they'll grow bigger. This is bringing wood and nature into buildings. Another one, this is Technology Center, Comcast Technology Center in Philadelphia. Height of sort of scientific technical company. What do? They fill their space with wood. Very good for your attention span, lecture theatre in Oxford. It is proven to help your attention span. Its haptic quality, this is a Maggie's Centre. This sort of haptic quality, the touch quality is very restorative, very reassuring. And heartbeat. If you sleep in a bed, a wooden bed, in proximity to wood, your heartbeat is significantly slower during resting sleep. Nobody can tell you why, just is. Nobody can really say that's better for you either. But we're seeing a lot more wood adopted into healthcare now. One of my biggest clients is a big healthcare company. And we're doing a lot more wood in that now. The acoustic qualities, that's a big concert hall. At that scale, this is a project we did a long time ago. The acoustic quality is fantastic. All concert halls really have to be made of wood. But also at a furniture scale, this is a product of ours where you're encased, cocooned in wood. It has a really good sound quality. And then VOCs. Somebody mentioned VOCs. Was it you, Gabriel? That kind of the volatile organic compounds of the beneficial volatile organic compounds of wood, which mean that we can achieve red list free declare labeling, which is a labeling system, a certification system on air purity with wood in a way that you simply can't with any plastics, metals, paints, or anything else. It's a jungle of certifications. And we work a lot in the sort of Well Building Institute. So we're members of Well Building Institute and Fit Well. And both of are getting a lot more attention from developers and therefore inevitably architects, and so down the supply chain, all the way down to you guys who are growing the wood. So it's pretty much smiles all the way for woodworkers. It's been a very happy life for me. I've loved working in wood, and I love the fact that it is now regarded as the most modern of materials. And if you don't believe me, hear it from this guy. Now, God could have chosen for his son to be anybody. He could have been a tech entrepreneur. He could have been anything, but he didn't, because what God knew was that a life with wood was the best life. So, if you don't believe me, at least believe him. Thank you.
Thank you so much, Sean. We'll move on. We've got two gentlemen from Arup who are going to speak together. Andrew Lawrence, who is the eminent expert in timber. I'm going to put it out there. And Francis Archer, who happily we have the pleasure of having down at Hooke, remotely and in person, regularly to work with the Design and Make students working on the engineering for their structures. So he's got a very kind of intimate knowledge of a lot of projects that have happened at Hooke. I'll pass over to you, Andrew. Oh, yeah. Do you want to ramble on when I do?
Yeah. Right, well, sorry? Introduce myself. Oh, right. I'm Andrew Lawrence, structural engineer at Arup. I've been lucky to have been working in wood for about 20 years, and so it's been an amazing journey as it has become, I think, now a standard construction material. But I wanted to go back to what Sean was saying about environmental product declarations. I think we all know that engineered wood, has a much lower embodied energy than steel or concrete. But of course, even lower than engineered wood is actually to use the wood in its natural form that John was alluding to this morning, without the processing that Sean was talking about, without the glues, without the kiln drying, without the planing and the wastage. So there we are, yes. So that's what I want to think about, is if we're going to use wood in its natural green form, what does that mean for us structurally? So, as structural engineers, obviously the thing we care most about is how strong is our piece of wood. I do actually have a wonderful graph which has got about 200 or 300 different species which have been tested, and it is almost a straight line between the strength and the density. Now, I can't show you the actual graph because I haven't got the copyright, but it is pretty much a straight line. And now you might think that for us as structural engineers, well, we would take the strongest wood, the densest wood for our building structures. But of course, if the wood gets too dense, it can really be quite expensive for us to work, expensive to make connections into, slow to kiln dry. And so actually, all our building structures tend to be built out of, certainly in Europe, spruce, which is actually one of the weakest and lowest density woods, but very easy to work with. Now, the reason that for any species of wood there's this sort of direct correspondence between strength and density is if we look on a microscopic scale at any species, they'll all look pretty similar, a little bit like that. And I think it was John Gordon, the author of Why Don't Things Fall Down, that he said, well, the way to think about the trunk of a tree is to think of it like a bundle of drinking straws. What is the function of a trunk? It is to get water from the ground up to the leaves. And so it is on a microscopic scale, it's a bundle of straws. And if we all know how a bundle of straws behaves. If we take that bundle and if we squash it or we stretch it parallel to the straws, it's really strong. But if we grab it across the width or we try and pull them apart, it's very weak. And so we have this fibrous material, which if we can use it in its strong sense, parallel to the fibers, parallel to the straws, it's incredibly strong and light. Now, the fact is that if we were to take a single tree and cut, shall we say, 100 planks out of that one tree, and if we tested them all, tested their strength, we would find a huge variation of strength, something like a variation of 4 or 5 times. Now, why is that? The reason is that, of course, a real tree isn't just like a perfect bundle of straws. Real trees actually have branches. And branches, as we know, create knots. When we cut that tree into planks, then of course we're left with knots in those planks. And of course, depending where those knots are, will determine how strong it is. So if the knot is a large knot in the bottom of the piece, it's like a hole right at the bottom. That piece is going to be much weaker. Sorry about my terrible drawings, but that's why I was an engineer, not an architect, I have to say. But everything gets drawn with a straight line, as you can see. So you can start to understand why 100 planks cut from a tree, the same tree, have this huge variation of strength. And there's a second reason as well, And that's because those straws, that the tree doesn't grow perfectly straight, and sometimes they twist slightly when they're growing. So when we cut straight planks out of a slightly non-straight tree, obviously those straws aren't going to be perfectly parallel to the piece. And so in a sawn piece of wood, we end up with a slight slope of grain. And so we've got these two natural defects, the slope of grain and the knots, and that's why there's this huge strength variation. And so what we need to do, if we want to use a piece of wood structurally, we need to grade it. Now, the process is called visual grading. I can still remember going into a factory in Finland probably about 15 years ago where the visual grading was still done by eye. These incredibly experienced graders who would they'd have 1 second per piece and they could tell you if it was a strong or a weak piece. The same process is now done by computer eye. But the computer is looking for exactly the same pattern of, are the knots big or small, where are they? But of course, these things, the slope of grain, the knots, these are man-made problems. This is because we're taking the strong natural tree that John was alluding to, and we're cutting it into small pieces. If we could actually use the wood in the way nature intended, large balks, perhaps the poles that have been used at Hooke Park, it is much stronger. There's very little data on it, but it is much stronger because it doesn't have that slope of the grain. All those wood fibres are perfectly parallel to the piece. It hasn't got those big marginal knots. All the knots are nicely radial and don't really affect the strength. So let's think a little bit about if we're going to use wood in sort of poles, should we say, in larger cross sections. Let's think about what that might mean. Now, first of all, the wood is still going to be green. So Alison has alluded to the amount of moisture that comes out of the wood after you chop it down as it starts to dry out. Now, traditionally, the wood would be seasoned, and if it's cut to this sort of cross section, it might take a year or so to dry out. But obviously, if we're going to use the wood, the whole cross section of the tree, perhaps 200 millimeters diameter or something, that's something that might take 5 or 10 years to dry out, depending on its density. So what it means is that we're going to be using that wood in the building while it's still in its green form. It won't have had time to dry out. Now, Alison referred to, very interestingly, she referred to the radial, the rays. And what those rays do is they restrain some of the shrinkage, some of the drying shrinkage as the tree is drying. So if you go back to that model of sort of drinking straws I was describing, imagine that the walls of all those straws are quite wet and swollen. So as they dry, just like a piece of dried fruit, so the wood shrinks on the cross-section, but those radial cells, which transmit all those tannins into the middle of the tree, those radial cells restrain the radial shrinkage, so you get much more shrinkage round the rings than you do radially. And what does the tree do? Well, it wants to relieve those stresses that build up, and so it simply splits. And as you can see here, if you leave it to split naturally, it will split on the shortest path, the lowest energy route, to relieve all those stresses. But there are clever things that we can do to change that pattern. So we can, rather like the sort of the grooves in a chocolate bar, we can put a little saw cut somewhere else, and we can tell it where to split. And so here you can see we've told the wood where to fissure. And another way to relieve those stresses, we can drill a small hole in the middle. And what you'll see on the next 3 images is the larger the hole, the more that's going to relieve those stresses, and the smaller the fissures become. And in fact, this is something which is really quite commonly done in working with green oak, as you see here. This is really quite an old technique. Now, there's something else that we need to think about if we're working with the green timber. this is a piece of green oak, and you can just about see in the paler areas how there's some woodworm attached to it. Woodworm is really a sort of a beetle. And that's because while the wood is still wet, it's a perfect environment for the beetle to survive. And so as it's drying out, it can be attacked by the beetle. And now, there are two very easy ways to deal with that. So, and the clue is almost in this image, because you can see the slightly darker tannin-laden wood in the middle there, the heartwood in the middle, has not been attacked by the beetle. So we can actually select woods like English oak, white oak, like Douglas fir, which have got quite a lot of tannins in them, and those tannins are toxic to the fungus, and also, as you can see here, toxic to fungus, but also they're toxic to the woodworm, and so prevent the tree being attacked as it's drying out. And we can artificially improve other timbers as well. So I think, John, you'll correct me if I'm wrong, but I think when those poles were used at Hooke Park, I think there was some boron treatment, was that? Yes. Yeah, so boron's wonderful because it's an artificial toxin, but it is the only toxin which is toxic to fungus and to insects, but not toxic to humans. So I think we always advocate using it in bamboo, for example, in developing countries. So just my little summary, really. I think wood used in the round in its natural form is a very interesting material. It's actually a stronger way to use the wood. It's got even less embodied energy in it than engineered timber. There's less wastage as well, obviously. It has got these disadvantages. It will shrink. It can be attacked by beetle, but as I've shown you, there are ways of dealing with that. And I was lucky to learn a lot from my predecessor, Peter Ross, and he's written a wonderful book called Green Oak in Construction, which talks about, specifically about green oak, but it does talk about, obviously, the detailing that you can use for any timber if you're going to use it in its green form.
Having grown up in the wilds of the Indian Himalayas, toys for my brothers and I and our rabble of friends were sticks and stones from the forest and junk from the rubbish tips, making things with minimal tools. There's even a word specifically for this in Hindi, jugaad, sort of a frugal innovation. Many years and a couple of careers later, I became a structural engineer and joined Arup and was introduced to Hooke Park by my colleagues at Arup at the time, Charles Walker and Martin Self, here, we'll hear from later, who taught this unit here at the AA, which ended up with these beautiful Bedford Square pavilions. I recall going down there to help make one of them and fell in love with the place at first sight. This truly was a laboratory in the forest, a laboratory to have fun in. So then about 10 years later, or about 10 years ago, that was 20 years ago, we at Arup were invited to help the design and make unit with some structural engineering input, making sure the designs and constructions would stand up and were safe, producing building control calculations, etc. And this naturally led us to getting involved in the review of ideas, and I want to run through a few of the recent structures, some pictures you've already seen before, that resulted from this unit, with emphasis this time on structural system. What's the structural system, which is linked to the material, but also somewhat distinct. So the agenda for the Forester's Lab and Forester's Symbiotic with Construction made me, of course, all of us, I'm sure, think of Louis Kahn's Ask a Brick to Do What a Brick Wants to Do, but it's obviously it's the branch here. So one of the earlier ones back in 2013 you've seen pictures of is the timber seasoning shelter. Again, used beech, which was underused, and there's a lot of it in Hooke Park. And steam bending was the sort of ancient technique that the students had caught on to. But steam bending could only be done in relatively short pieces because of the size of the steamer here. So the structural idea for a spanning enclosure, roof canopy, came from the age-old structural trick of spanning long distances with short beams, the reciprocal frame. A game I play every time I'm in Starbucks or This is what I do at home a lot, in pretense. Or in the back garden with odd bed planks. As an aside, in one of my earlier, before I became a structural engineer, I was a mathematician, and I was doing my PhD. I did lots of diagrams like this. It's called knot theory. Mathematicians call that knot theory. The diagram itself, because it's a two-dimensional representation of a three-dimensional weave, which is what architects or most normal people would think of when they see that. Structural engineers also use this notation as a two-dimensional diagram to represent a simply supported beam. So that's a set of beams. The gap means that there's no moment fixity there. It's simply supported. And that is exactly what we want to do when we're using short sticks to span long distances. We don't want to, we can't get moment, we've cut them all up. We can't join the fibers together again, except by using very inefficient and expensive steel methods. So you just sit it on there like I'm sure you've all done this in Starbucks. If you haven't, do it, then do. Martin and I had, of course, just a few years before this, been involved in the competition with Shigeru Ban for Metz Pompidou. Even Andrew, who was later involved, didn't know this, that this is a competition entry that won the thing. The actual scheme, of course, that ended up being built was different from this, but the weave is this was the weave. The one that was built wasn't really a weave, but it's because the project moved on after we won it to others. But we hadn't forgotten our three-way reciprocal frame, three-way spanning reciprocal frame. So with 400 plus unique curved planks, pairs are held apart by a single steel-threaded rod to give a structural depth at mid-span, and the total assembly becomes a hybrid grillage grid shell. Grillage, engineers mean, is a bending system. They're using bending. A grid shell is an in-plane system. This is a hybrid of the two. And that's a nice picture of how we assembled these big pieces. So our work at Arup involved helping the students with geometry manipulation, which was quite involved in this analysis, which fed back to the design, and also specifying some capacity testing. There's a memorandum, and I just wanted to put that up because Andrew, myself, and Martin are in the room. So obviously, once you get involved at Hooke Park, you stay involved, and you longevity. I mean, it's only 10 years, but that'll probably still be. I'll probably be showing that slide in 20 years' time. Skinned with a simple membrane and canopy has successfully been used for drying sawn timber for nearly 10 years, as anyone down there would know. Now, and just another quick one, the sawmill shelter, which you've probably also all seen pictures of. It was born as a prototype for the larger Wakeford Hall Library, which was to be designed and built with two buildings with a light roof spanning between them, creating a large auditorium. Early on, the students homed in on a cable net-like tension structure. And we encouraged the idea of considering timber in tension. So that little diagram there is just me Googling Tarzan hanging on vines. We all know timber's good in tension because we've all seen Tarzan swinging on vines. We all know from fabric structures that if you want something in pure tension to span as a single surface, then it must be saddle-shaped, anticlastic saddle-shaped curvature like this. And we're all used to seeing such canopies in fabric, and at a larger scale, we see them when you replace the fabric with cables, two ways, cable nets. But here, we wondered whether we could make a cable net structure with the cables were timber, not steel. And so these lathes, they need to be small section, as otherwise the bending stresses that the curvature induces ends up governing, and one ends up back at a bending structure. So the question really was, with small sections, how could we create timber cables? The geometry we homed in on, we required about 2 tons of tension in each 35 by 35 millimeter red cedar sawn green timber, from green timber from site. 2 tons in each of those. Of course, they aren't one long piece. We needed to perfect. This wasn't going to work at all. Great thing, by the way, about working with students in Hooke Park is, which you couldn't possibly do commercially, is that you start by telling the client that this might all fail. You might end up with nothing. It might not work. And that's happened many a time in design and make. You end up down a path and you go back, and it's a failure but we don't get sued, whereas in commercial projects there might be more trouble. So here, finger jointing, which is glue getting maximum surface area contact, of course, is something that the industry glulam makers, have expensive machines. I watched one the other day, 10 seconds, you got full strength, 10 seconds. Took them about these 2 weeks of experimenting or more, many weeks of experimenting with different glues and different techniques and different testing to get to a situation, but they got to it in Hooke Park where they got full strength. In other words, when they pulled that timber apart, it didn't break at the joint, it broke somewhere else. But of course, we also knew that we had 12 meter long. So basically, we used only short segments because you had to get rid of the knots. This is the grading, which was done but all done by students, and therefore we don't rely on the grading. We don't then use codes. In Hooke Park, for these kind of projects, we make sure we test every single member. That's another way of getting around all the grading. Just test every piece. And the rubbish ones throw away and use the good ones. So we tested every single 12 meter arc and basically loaded it near as possible to the actual loading it would see with this loading jig. And there are many other stories, like the steam bent timber at the other end of this, and those who've seen it. But it just had a simple aluminium sheeting, recycled aluminium sheeting put on, and it's now protecting the sawmill. You've all seen the video of this, so I won't play that video movie, but I'll come back to this, which Emmanuel showed earlier on, which is our latest, almost hot off the press. So, planar space frame. A space frame is an array of trusses, really, in two directions. You can think of it like an array of trusses. And the upper and lower members are long. Here, the upper and lower members can be long, continuous sawn lathes. Remember, in timber, we want to avoid connections. Because you want to avoid cutting it, because then you can't put it together again if it's got a lot of tension in it. But the internal members are short from timbers and the round timbers, as you saw earlier, creating hundreds of connections. And if you just created Warren trusses out of that, in other words, members, then half those timbers would be in tension. And how the hell do you connect them at the ends? What stops them? You'd have to have some really complicated, expensive steel connector at the end. We wanted so what we did was, by putting these vertical rods at every single intersection and squeezing the system together, okay, that's a diagram of one module of it. That red is tension and blue is compression, okay? So by squeezing that red guy together, just in that one module, in that one corner, all the diagonals, all the dark purple lines there, go into compression, negative numbers. And with this sort of a cubic form, where the depth and the size of that module are equal, you get these lovely numbers. Everybody likes numbers simple as that. If you pre-stress that one member by 4, it's in equilibrium. That little piece is in equilibrium. And what we want is a control of this is what mathematicians would call a basis of pre-stress. Any pre-stress system in that, in other words, any set of tensions that you choose to put around the system, okay, can be seen as the sum of this basis of tensions. Take every single, because that little unit there is in equilibrium on its own, with everything else unstressed. And then so you can say that some particular sum, in other words, some particular amount of x1, some particular amount of x2, some particular amount of each of them will give you the result. And of course, what we're after is, when you support this, as we did on 3 sticks, the forces in the members are very high near where the sticks are touching, near where the support is, and therefore, if you hadn't pre-stressed it, you'd get very high tension, you'd get ones falling out. But we pre-stressed it according to the pattern of the actual forces by approximately, we used torque wrenches, we calibrated with the students to pre-stress it, so that after it was put up and propped and it's there now, every member is still in compression, and none of the verticals are slack, and we will adjust it once or twice as the timber shrinks a bit. But it's you saw some better pictures earlier of this. It's actually, for those of you around in the 100 years ago, not many of us, aircraft wings. If you go to the British to the Science Museum and look at early aircraft wing construction, they were made by timber space frames. The difference was that their timber space frames in the Science Museum are about that big. You got into an aeroplane and risked your life with timbers that size holding your wings up. It's phenomenal. Okay, this is what I do at home. In the pretense of idea of experimenting with structure and form and create static objects in equilibrium is a pleasure activity. Pastime, although I do this extensively at home under the guise of playing with my boys, in reality the boys soon get bored and leave me, go back to their computers because I'm a bit of a structural dictator. But we do this a lot. A lot of it's about pre-stressing. It's about timbering compression and because it's all demountable. No glue. None of these have any glue in them. It all has to be demountable because I'm not allowed to mess up the toys. Now, I just wanted to end with with a comparison, and this is the same topic that many people have touched on. 2 ways in timber of making similar objects. Grid shells, or big, large domes in timber. This is a recent one. It's great that in China they've started using glue lamp seriously, significantly. This is by the engineers of Fast and Epp in Canada. But it is, that picture on the top right shows you what it is. It's hundreds, if not thousands, of unique curved glue lamp elements, millimeter accurate probably, made in Canada, transported. I mean, firstly, the lathes are glued together through the whole process. All the processing of glue lamp, all the gluing, all the processing of making the curved jigs, curved glue lamps. And it comes together, and it's put together, basically bolted or screwed. It's bolted together. It could have been any material. It could have been steel. You bolt it together. It could have been something else, bolted together. We all know the other way of doing it, which is how early Hooke Park did it, how Mannheim grid shell was done, how wheeled and down grid shell is done, how prehistoric. I've got pictures of villages in India, tribal villages in India, where they do exactly this now, and they've been doing it for thousands of years, not at the same scale, but they take something flat and you deploy it. You take a structure and deploy it. So there's not a single curved timber needed. You come to site with a simple straight members. One of the fantastic ones that they did at the Windsor one was they had timber on pipeline, okay? Because all you need to make these big domes is long lathes. You do need what we needed, which was to finger joint them together, so they do have that grading. But they created the finger jointing factory in a polytunnel across one side of the road, and then they put it in a pipe across the road to the other side, and basically the construction site had a tap for timber. A tap for the lathes. They could pull it as long as they wanted, put it in, cut it, pull it. Whereas in Wheeled and Down, there's lovely pictures of 6 people carrying a 60-meter long, flexible piece of string. Okay, but so just a thought. The problem is, you see, that in today's commercial construction world, control, offsite, all the buzzwords are offsite fabrication, control, factory quality, and yes, all for good reasons. Or usually for good reasons, but we don't want to miss out on in-situ construction because you're missing out on craftsmanship, you're missing out on a lot if we end up having to make all our buildings as road transportable, factory-made bricks. And I think we don't want that to happen, and that's certainly not the model at Hooke Park, because you make it either in situ or very, very close by. But yeah, thanks.
Amazing. Should we have a couple of questions? Do we want to get the speakers from this session back up here at the table, and we'll see if we can throw a couple of questions at them and make our coffee break about 10 minutes instead of half an hour.
Sean, as a fledgling shipwright for wooden yachts, I can very much empathise with your comment about going into a space made of wood. Because if you know boats, wooden ones inside are so much nicer than plastic ones. But I'm wondering if we're missing a trick, because normally with a wooden yacht, you pay a premium price. I was pricing up restoration for a 10-foot clinker dinghy this week, and it was $7,000 just to get the keel and a few planks in place, which normally is prohibitive. So I'm just wondering, actually, when I see the follow-on talk as well from yourself, Francis, that are we missing a trick in that yachting space with wooden structures of using alternative modes of construction that you've just been showing? way. I think you've used castomite at one stage, I think, actually joining up your, which is a type of glue, joining up your finger joints.
Pass. I don't quite see how you could make a boat.
You've got, just to help you, you've got a hull and you've got a keel. It's actually, there's a lot of similarities. You can turn it upside down. That's an upside down boat. Do you see in front of you? There's no keel.
Yeah, no, yeah.
But I'm just wondering if you're missing.
Can I say that the French grew vast tracts of forest, which where they stressed the oak trees, and they grew the trees in the bent form to make the ribs of their sailing ships. And some of those forests still exist, actually. Did we do it as well?
We did, because we beat the French, didn't we?
Well, say the problem here surely is that the alternative is falsely cheap. All our oil product plastic boats are falsely cheap. It's not that timber's too expensive. I mean, that's all relative. But they're cheap because they're not paying for their own pollution.
Yeah.
So it's what we need to change. You can't always win on current economics. We need. Why are they cheap, and why are they allowed to get away with not paying for the pollution they cause?
Well, I think you're using. This is a fair point. Just to finish up, I think you're using glue lam a lot more. From what I've seen, shipbuilding tends to be very traditional. You do the scarf joints and all these things, and not move on. And it's just refreshing to see timber being used in a different format.
You use steam bending quite a lot, don't you?
Oh yeah, not every day, but yeah, you use it very frequently.
You've heard enough from me this morning. But a very quick question to Sean, to thank him for a really clear exposition of carbon sequestration. Thank you. I did do a crazy thing once, and I weighed an entire oak tree, like from twig to big lump, and the roots. And I felt you somewhat dismissed the importance of roots. So about half of all carbon is in the roots, before you take account of the soil carbon.
Right.
So half the weight of a tree, if you like, is in the roots. So every time we talk about carbon sequestration, the tree is not just what you see, it's also what's below.
So the problem with that is when we cut the tree down, then you get decomposition of the roots. So the retained carbon, the carbon store can only be the bit that we can keep, and the rest of it you're going to lose to decomposition and. But it's interesting, I didn't realise that half the way to a tree is in its root structure, is it?
I think we have a vision of roots being little things, and tree, it's an equal thing. It would be to hold it upright as engineers know. The kid is important. Really crucial.
I just have a question for actually anyone. I think it's really interesting, like the lack of glue in a lot of these projects, and I'm wondering whether or not there's like a design for disassembly embedded with that process, or if that's something that you don't really consider at the moment. To like take it apart and then put it back together.
When nowadays, I mean, I would say that 10 years ago, we did not even consider design for disassembly. Nowadays, we absolutely. I go around the workshop and I say, well, you've got to pity the guy who's going to take that apart, as I see some things being, kind of made. We definitely think about disassembly, and that's the whole circularity argument. And presumably with buildings, you're doing the same thing. The thing about glue is Andrew always tells me he doesn't count glue in the strength. I was doing that thing we did in Venice, and you just wouldn't let me count the glue. And I say, but the glue is the strongest bit, and you wouldn't let me count it in the strength calculation. You had to have we had to have mechanical fixings. Is that a thing? I mean, do you allow for glue?
I'm trying to think what you're related to. But I mean,
the Alison Brooks, that big arch we did, that big mirrored arch.
Smile.
No, not the smile, but.
I mean, I don't know. Glues are great. Our aim in gluing it's first of all that the glue should be stronger than the wood, so that by gluing the small bits together you end up with something which has got some strength of wood. And it does mean, that actually on the scale of a massive building, we can create very large pieces that can start to compete with a steel beam or something like that. So I wasn't trying to say that glues didn't have their place. I think I was just saying that Perhaps, yeah. But perhaps there's also a home for smaller section timber used in the round.
But for reuse, I would have guessed that the bigger problem is the one that Alison identified, is ferrous, is screws and nails. So if you don't use glue, I mean, well, just using bolts, maybe you can get them out. But screws are used enormously because they're so easy and cheap. And they are often very difficult to get at. You leave them in, and that's much bigger problem for reuse.
Becomes a problem area in Alison's sculpture when she inherits the wood. But yeah, I mean, I do think it's something that we're all thinking about in a way that we didn't think about 10 years ago.
Yeah, like hypothetically, the space frame at Hooke Park, would you ever take that apart? Yeah.
Yes, but I think we have to take into account the period you expect this building to be up. If you expect a building to be up 100 or 200 years, it's less important to think about disassembly and how it's going to be reused. If it's designed as a temporary short-term structure, why are you concerned with your furniture about being taken apart?
Yes,
the last 200 years in Oxford College.
Well, yes, but no, we still repaired. In 200 years' time, someone's still going to want to repair it, or adaptive reuse. I mean, I do think the whole field of adaptive reuse of furniture as circumstances change is an important one. So I definitely value the ability to disassemble.
Yeah, but I agree with you, Francis. I think we shouldn't focus. Yeah, reuse matters for a short-term temporary structure, but our aim should be that most of what we build is going to be there for 100, 200 years because we've made it durable enough and adaptable enough, like our old Georgian buildings like this one, so that people can keep modifying them slightly like all the pieces you were describing. So what I think we should be careful about is not penalising the initial design because of too much focus on reuse, I think I would say.
And I have another question. One of the things I've appreciated is this distinction between sort of the deterministic approach of building and using fixed components versus the adaptive workflow that Hooke Park has been exploring, both in materials and also in the actual design to production workflow. Francis, I think at the end of your talk, you sort of poked fun at scalability. And so that's my question for any of you, really, is at what parts of the process that you're engaged in, are there any opportunities that you see within those processes? Are any of those parts of the process scalable? Or do they speak to larger, more scaled construction systems that can learn from these explorations?
The first thing about that is that at Hooke Park we are building one-to-one architecture.
Of course.
Really a roof, yes, and so there's no reason why that roof couldn't be much larger. I'm not saying that it could be a stadium roof, but not the same span, but you can use smaller spans or deeper. I think it's some aspects are scalable, but different things come into play when you're doing tall buildings. We shouldn't forget from this room that timber is a combustible material. And so we in Europe would be very hesitant to do these tall.
To be building a 100-metre building.
Why are we building 100-metre buildings in timber instead of making sure that every four-story building is timber? Why are we trying to do something? Why are we jumping to that scale before we've even perfected this scale? I think it's a big mistake.
Yeah. And I think on that point also, I would say that if one is trying to build a skyscraper out of timber, at the very least it will end up with huge amounts of protective finishes to encapsulate the wood to try and get over some of the fire issues, which then hurts its carbon footprint, whereas those four-storey school office building can be completely bare timber frame and actually an amazingly low carbon footprint compared to its competition.
I want to add something to that. We're forgetting that if we want to scale the wood comes from trees, and we don't have the forests and all that previous stock, no? So yeah, they scaled needs to be in time after the first 100 years. I don't know. Just don't forget that.
But at least we can grow trees in a 100-year cycle. I mean, most materials that are being used for construction have taken millions of years or billions of years to evolve on Earth, and so it is any plastic that's tens of millions of years old carbon, and at least with wood it is renewable on a 100-year cycle, or less if we're using thinner material, 30-year cycle, 20-year cycle.
Yeah, I think I was just saying more from the architecture point of view, like, oh yeah, let's make a big building with wood, and I don't have the industry or the resources, maybe in 100 years. Or maybe just start with perfection in the small building before trying to make 100 buildings when we are going to deforest.
It's also understanding the system. We are, in Arab, we're very keen and we're very busy setting up full-scale, real tests, fire tests. Fire is a major issue because it's not understood. And so right now you just say, yeah, protect it all, and then then you lose all your carbon benefit. But that doesn't mean everyone is. No. I mean, there are buildings gone up. And part of the story, I think, just a simplified explanation of this is that, like in Norway, the 17-story timber building, is there's a difference between fire safety, getting everybody out. It has got a char there that means you'll get everybody out. Nobody will die. But, like your log on the fire, you can't put the fire out. The entire building will burn, potentially. You'll have a pile of... Whereas a concrete steel building, that can't happen. Once the fire load's gone, the structure stays up. A timber building, fire load never goes till it's charred, till it's on the ground. And so it's not necessarily a life safety issue, it's more about insurers and does our city want to have a pile of ash on the floor after a big fire.
It's been really interesting to hear you guys talk about the end of life for buildings, and I was really curious what Alison's going to say about this for her work, because your pieces are intentionally cracking, or you're responding to the cracking that they're doing early on in their life. Some of them are outside, and so I was just kind of curious how that conversation goes with clients about like what will happen to them when they get them, and then what will happen to them over their lifetime. Like at some point, how does that discussion go?
Right from the outset, basically, there has to be a conversation about expectations of longevity, expectations of colour of material, cracking, all that has to be talked about at the outset so that the client is engaged, understands, and therefore, they either decide to have the courage to go with me or want something more stable. Yeah, it's an important conversation.
The cracking will reach an equilibrium. I mean, it will...
Well, you say that, it depends on the atmospheric conditions because it will do an enormous amount of moving over the first years. But then if the atmospheric conditions change around it, then it will shift and move, may expand, may contract according to those atmospheric conditions. It will always, the sizes of timber that I'm using, it will always be giving up moisture. It will never completely dry out.
Yeah.
So I'm going to try to formulate a question, Alison. There's a real love affair with the material,
yeah,
and something really tacit about it, this physical engagement with it. And I'm kind of curious. You say you're a furniture maker as well. Does any of those aspirations translate to furniture pieces, or maybe even architectural components?
Yeah, that's how I started making furniture. I trained as furniture designer, and that's exactly what I made when I first was making. I've shifted into the sculpture realm, and perhaps the slideshow neglected to show some of the I still make furniture, but I think I wanted to communicate some of the things to do with the integral features of the timber, regardless of the purpose of the overall piece. But yeah, I do very much still make furniture, benches, seats, tables. Yeah.
I mean, I think what I really like about seeing your work is the kind of the surrender to the movement of the material, right? The surrender to its own wish to move and to change, like you say, with that atmospheric conditions. I think we tend to get very obsessed with stasis, trying to hold things in a moment in time. And I think something that we're very keen on pursuing at Hooke definitely is how we embrace the change over time, how we embrace that movement, how we design structures that respond to that kind of movement and that do a little bit of, maybe not all the way, but a little bit of what you do in terms of, and like you say, there are things which maybe we allow to return, we allow to fall apart, we rebuild, and we have that conversation that actually there's something really inherent about timber that do that.
Well, of course, the ancient timber frame buildings were designed to move with the understanding of timber moving and the stresses and strains within them. The frames are designed accordingly to work with the physics and the movement of the timber. So we have been doing it for centuries. Yeah.
Any other?
I'm trying to combine learning from each of you and realizing that, at the end of our lives, let alone the life of the building, none of us want to be in a concrete coffin. And it's worth saying that to clients, I think, for anyone in the room who has to persuade a client to build in timber. But thinking about Andrew's avoidance of waste and the inherent strength in using material in the round, thinking about Sean's official notification that it's God's own favourite material, and Alison's reminding us that it's alive, and also, I'm sorry, I can't remember your first name.
Francis.
Thank you. Reminding us that working with it is the enjoyable thing, and not relying on necessarily off-site machinery to strip it of its characteristics before we engage with it. I mean, perhaps there's a kind of hidden manifesto for not using other materials because we're inventive enough to not need the glue and not need the steel, and to use it in tension and use it in compression and not rely on anything else. Just look at all the capabilities and flexibilities that the material offers in any case. Like the Japanese, they didn't bother with finger joints. I mean, they had tensile joints. Surely it's within our remit to not need screws or glue or any other material to even surface and protect it. There are trees know how to protect themselves. We can learn from them.
I sympathise with you. I mean, I always find it disappointing when what should be an entirely wooden structure does end up relying at key moments on a piece of steel. And it always feels like a bit of an admission of failure. And I think probably a lot of it is down to kind of cost and process and time. It's a simple way of solving that particular problematic issue. Yeah. I mean, I love Japanese joints, but I wouldn't want to have to do length extending Japanese joints on all my pieces of wood I want to make longer, because it would be a long process. But I mean, I don't know. At Hooke, one of the things I know, I mentioned this to you, John, that I was sort of disappointed by some of the use of steel. It felt in some of the buildings, I think surely that bit could have been completed in wood.
That's not necessarily the agenda. I mean, what do we? Whole life carbon is the agenda, and that is not a 100% timber building. It's not simple. Whole life carbon is complicated and intricate. So we can't uninvent things that are invented. So I think we have to live with. In fact, one of the most fruitful building systems that we are in the middle of developing and testing is actually it's the appropriate mix of materials And in fact, precast concrete, pre-stressed precast concrete, steel, concrete and timber all have a role. And you can create the lowest carbon building with all the right, when you use with a mixture of all three of those materials, if not more as well.
As Ted Happel might say, using materials for their best properties.
Louis Kahn.
I'd agree, but a medieval door only resorts to the steel for the hinge. The rest of it's pegged. There's no.
We can do it if the objective, the artistic objective, is to only use timber. Then of course one can find ways. But
I think you're right, really, that especially with buildings, maybe not with furniture, but especially with buildings, the reality is it's a hybrid construction. It's never ever going to be just timber. I mean, you would not put the timber in the ground to start with.
You can't walk on softwood. My heels will go straight through.
It's a reality. So I agree. It's about the right material in the right place, but the least carbon involved. So therefore, steel automatically puts itself on the rear foot, doesn't it? Because it's
unless a very small amount of it can do a very significant job.
I have a table that tells you compares steel to the. So if you've got tension, I mean, generally, simply in structural engineering, you have tension and you have compression. There are only two types of stress in the material. The lowest carbon tension and lowest cost tension is high strength steel.
Yeah, as a
the
cable.
The lowest cost compression is actually timber is good at both, but and probably will win on compression, on carbon certainly, but and also because it's lighter weight. But you can't get rid of steel tension. But what we should do is less of it and use the highest stress, which are cables basically.
Less steel, but also less timber. Less wastage.
Yeah, and I think actually to try and answer your question, so absolutely you can make a wood-to-wood connection, and as we did in medieval times. But as a mortise and tenon type joint, you're cutting away a lot of the wood, so you're weakening them. So those medieval structures have oversized members, more wood material in the members, precisely because they've got these quite weak wood-to-wood connections. So by having, as Sean says, small amounts of steel at the connection points, little nails or screws or whatever, we can actually make the wooden members smaller, and hence, to answer what Francis was saying, the overall footprint of the overall piece, wood and the connection together, can be lower.
Coffee? Thank you, everyone. Thanks very much. So we'll round off the day with the third session, Architecture and Space. And we've got three people talking here. Guillaume, did I say that right? That's Rezel, from Marks Barfield Architects. Martin Self, long-time director of Hooke Park and talking about Xylotech today. And Kai Strelka, who's come from Bloom & Lehman. And we're going to talk about how the materiality from the last session informs the kind of architecture that we might make out of timber and what the future of architecture might be in timber. That's not a difficult brief at all, is it? I'm going to hand over. Do you want to use this one? Or
Can you hear me? Everybody?
Yeah.
Does that work?
Yes.
Okay, my name is Guilherme Wessel. I'm an associate computational designer at Marks Barfield. And I had the pleasure of working on the Cambridge Mosque alongside David Marks and Keith Critchlow from the beginning of the project over 10 years ago. A little bit about Marks Barfield. We do not have a style. We work on a wide array of projects. The most famous, I think, is the London White. That's what we are mainly known for. But you can see that there is no style. It's basically following a brief. But that being said, with the current climate, and even then, when we were originally producing the Cambridge Mosque, we have identified that there's a trend that the office tends to follow, or tends to move towards a principle, just like the modernists used to say that form follows function, we believe that design should follow efficiency, and not just efficiency but sufficiency, just using the sufficient material to perform a task. So, end of 2008, beginning of 2009, we won a competition to design a mosque for Cambridge. And it's quite, traditional place, hard to get some planning permission, but basically I just love this image. It shows how much needed was a mosque there. This is the original mosque there, and people used to come and pray just needing on the tarmac outside. It would not be able to accommodate, and it was a large brief that we had to obey, able to accommodate 1,000 prayers. So this is the brief that we had to follow, universal principles to design a mosque. It had to incorporate social, communal activities, and it should also be sustainable. And in Cambridge. So this is the location of the site. It's close to the train station and the airport. So as you can see, is the red one there, and the yellow one is showing the location of the little mosque that we just showed before, where people were praying outside. This is the site. The site's roughly 45 meters by 100 meters. The site is able to accommodate King's College Chapel, and this is the surrounding buildings. Basically, in the context, average 2 stories building, mainly made of bricks, residential. And moving forward, before we begin to design it, we did some research in terms of mosques around the world, and we have noticed that mainly they follow a universal principle in terms of Islamic geometry, but also they use vernacular methodology of construction. And you can clearly say if a mosque is coming either from China, as you can see in the last one, or from somewhere else. Then we started to question what would make this mosque a British mosque with British architecture, and the analysis of religious building. One element that's present is the fan vaulting, which is basically a series of arches, whether you're running perpendicular or parallel to yourself. So you have arches in both directions. And the other thing that we notice on many of the other projects that we have seen is the array of columns to accommodate, a vast and wide and massive prayer hall. So David came with the concept of the Garden of Paradise. David came with the concept of the Garden of Paradise, which is an array of trees surrounding a body of water. And that has guided the design. So this is the concept sequence. You see an array of trees, a glade of trees, and the glade of trees became the structural grid that supported the roof, and in order to be able to support itself, surrounded by brick walls, external brick walls that would actually assist the project to fit in with the context around it. Not to stand out, but fitting. We didn't want to shout, we are here. We worked right from the beginning on the competition with Keith Critchlow. Both David was a student here at AAA, and Keith was a professor here at AAA at some point. He was an expert on Islamic geometry. And Keith came up with one of the universal principles to design the mosque. He brought in the compassionate pattern. The compassionate pattern is composed by octagons. You don't see the octagons there on your first glance, but you have them there. You have the convex 8-pointed stars and the concave ones, which is basically the pattern of life. Inhaling and exhaling, breathing. And for that, we have developed, we try to, use as much as possible throughout the mosque. So that was, we carried some design exercises on the brick patterning, where you would fit with the surroundings, and as well on the tree structures that we had inside the mosque. So a lot was developed to come to a situation, a solution that would satisfy all the constraints. We had constraints from structure, we had constraints from the brief, the rigid Islamic geometry, marrying the flexibility of the material, the timber, laminated material. So if we were to obey basically the geometry of that Keith wanted us to use, we would have something like one of the views of the dome there, where you have a pointy bit, but that wouldn't work with timber that well. So we had to, play around in order to satisfy the geometry of the Islamic geometry and the capacities of the laminated timber. It's a marriage between the plan with the compassionate pattern and the section as well. And also, we brought Bloom and Lehman in the early stages, and we have worked with them on certain constraints. So there was a parametric model for this, but mainly the main constraint that we had to obey was to limit the radius to a certain minimum. Otherwise, we would have to carve a piece of wood and use it instead of using laminated timber. So here you can see a better diagram explaining it. You have the compassionate pattern there, and how we derived that to achieve this symbolic mesh that's not fully structural, but also works as well, but also represents the 8-pointed stars, which had lots of symbolism throughout the concept development. Keith used to mention the 4 directions, the 4 elements, the 4 prophets, everything expressed with the number 4, duplicating the number 8, and then ended up with 16 members coming from the columns on the ground. This is the tree model that was done with timber, actually, very small one, laminated. And we wanted to express the material on the models, the physical models that we've made. So the program was supposed to accommodate a parking lot, which we placed on the underground, on the basement. And there was a complex program in terms of offering a communal area and the prayer hall, and also some housing for people that live there, and mortuary and everything else. We came with an arrangement of plan that's basically a series of veils, just like you have in the Middle East with vernacular architecture, where you have those trusses, those trellises of permeability on the facade. And we have that expressed here on the procession of spaces in the mosque. So at the front we have a community garden, which is public, and it was already there. It had to be respected, with a bus stop right in the middle, which is not clearly visible here. After you pass the first veil of the entrance gate and the wall, you have the Islamic garden. Then you have a portico, which is basically a shelter for people to congregate. And then you have the communal area of the atrium with the cafe and teaching, which also provides some space for exhibition. After you do that, the grid through the ablutions, where people wash themselves before they pray, has a kink. And that kink is basically turning the grid to face Mecca, where people are going to pray towards too. And then you have here at the bottom, with on the thicker wall here at the bottom, where you have the mihrab. And we also try to push to be a more social gender equality type of space, but some things, well, I'll show some images and talk about that later, but basically at the end we had to provide another Qibla wall for women and children. And at the back you have another portico with the mortuary. So here's a model, 3D model, the beam model that we have developed with Revit. It shows the entrance to the parking lot at the basement, and it shows the whole stepping of the mosque. One of the things that we didn't want to do was to make the dome very prominent on the street level, so it would stand out. We wanted it to blend in. The section here you can see better. When on the right there you see the bus stop. So if you're looking at the mosque, the dome is there, it's barely visible, but it's not dominating the neighborhood. Also, one of the things that happens is that it's a very classical plant, very rational, but the inside also represents a little bit of the inconscient, being organic and all. The other thing that this section diagram shows is that sustainable is not just in terms of reusing materials and the energy footprint that you have there, but it's also on operating the building itself. So we have brought an abundance of daylight inside the building and natural ventilation coming from underneath and flowing all the way to the top. I'll get to that there because we have some measurements that I'll share. But basically we have used those principles. The use of materials in terms of timber, most of the project is timber. It was supposed to be bricks on the external walls, but if you take into consideration carbon footprint, the energy footprint of it, and the time that it would take to produce that required amount of bricks, we have shifted from that. I'll show in future slides. You have the natural ventilation, you have biophilic design throughout the project, and the use of timber. Even the walls, the external walls are timber. So here are the principles. In terms of, we carried several analyses in terms of the light, how the light would behave inside of the space. You barely have to turn on the lights if it is summer. Over winter, you have to turn on the lights on the inside. The aim was to achieve a zero emissions on site. Well, we worked with Bloomer Lehman from the beginning. I think I'm going to go through these slides a little faster just to avoid duplication. But basically here's showing the structure. It's not a 100% pure structural timber. We have used steel, we have used screws, but we had to respect the universal principles of having this symbolism expressed on the pattern on the mosque. So here you have the main beams, which are mainly structural, and then you have some secondary beams that are not that structural. But anyways, we have passed, I think, satisfied the constraints that we had from the brief. It's a religious building at the end, and it needs to offer this type of symbolism. So Bloomer and Lehman diagram as well, with all the different elements. And then this is a steel crown that we had to use. So it's not a proper structural mesh, but we have used that. And in terms of having a British architecture, we have kind of accepted using steel on that to reinforce the structure and express the symbolism. Just like the longhouses from the Vikings used nails and everything, we have accepted to use some steel to satisfy the different parties. Here, Andrew have talked about this, but basically there is a direction for the beams in terms of a holding compression. The veins, I'm not going to extend, but here's showing how the beams were connected, how the laminated timber would attach to each other, and every single nail that we have placed on it is coming from the top, so it's barely visible. Here's a connection, one of the steel connections that we have there. It's also on the top. It's not visible from below. Here's the 16-pointed star that is in the middle of, on the top of the part that we call the trunk, which is basically the column. That also helped us to place the crown on top of it, so you could potentially slide it on top and it would guide how to assemble on site. So it was not just helping the structure to work, it was also helping the assembly of the parts, different parts. So the construction process, I'm sure that Kai may go through this, so I'm going to be brief. Basically, we had a series of blanks, and those blanks, they had to be milled, and these are the numbers of beams that we got in the end. So here you can see the blanks. Okay, they have been milled to accommodate the shape that would allow them to be assembled. And here are the milled pieces that we had at the end. And again, I'm not going to extend on this, but basically each one of them was checked to check humidity and the different strength of each one of the elements so that they would be sufficient when used on the building. It's a religious building, it's supposed to stay there for quite a long time. These are the members being transported to site. And here are the parts, how it was broken down. You have the crown at the top, which is the fan vaulting element, and then you have the trunks, which are the columns, and then the other ones are just for the edge conditions that we have when we meet the walls. Here you can see the trunk with the 16 star placed on top, which would assist as well when placing the crown on top, as you can see here. So that actually helped with construction, having that steel member as a help with the construction site. Walls. Initially, the original concept was supposed to have brick walls, and the brick walls was supposed as well to express the symbolism of the compassionate pattern. Evolution of the design goes on, and we realize that bricks may not be the best choice of materials for this. It requires energy to burn the bricks, and there was a delay on the delivery of the bricks. Bloomer Lehman did a fantastic job, so we got Bloomer Lehman to do the walls as well. The dome that was done by Bloomer Lehman, and this is the dome installation, the topping ceremony day. So for the walls, we have replaced the bricks by gaunt bricks, lighter, uses less energy to be produced, and we have replaced the compassionate pattern by this calligraphy, which is basically saying that God is the one, and the calligraphy flips around, and the pattern is repeated throughout the external walls. You can see basically the semi-mathematical tiles that we have used, which is basically gaunt brick. And one of the construction drawings, which one of my colleagues had to go around the mosque checking to see if everything was there and nothing was misspelled. And here's the final aspect of it. We have the walls, we have the octagons on the top windows around the prayer hall, and we have that castellation at the top. So the geometric pattern as well was used on the marquetry of the walls. Like I said, you can, if you are a specialist, if you know mosques, you can really tell where the mosque came from by the type of woodwork or the type of pattern that's being used there. On one of the conceptual images, I just grabbed something from the internet, I slapped on the door as a texture, and Keith came and looked at it. The mosque is not from Africa. This one is from Africa. You know, you can really tell. And here's what was used in the marquetry. Everything is veneer. And then you get to the dome. The dome was quite complex. It followed the same type of section that we had there. We have looked into different proportions for the section, something that would satisfy without having that pointy bit, which would not work properly with laminated timber, but would also obey to the type of proportion on the vaults that we were trying to achieve with Keith's guidance. The inside of the dome, the skin, is supposed to be GRC, and it's a sphere. On the outside is the same proportion that we have on the front vaulting. This is the beam model that we have developed, and here's how we broke up the geometry of the dome in order to provide a certain amount of repetition. The difference between colors is just basically because there's a weaving pattern on the geometry inside, and that weaving pattern changes from one panel to the other. So that's how it was broken down. A lot of work has been put down on this model. Everything was ready to be cast into a mold, to have all the pieces cast, and just use 2 molds. But in the end, reality kicks the door, and we had someone that won the tendering that did a fantastic job. Don't take me wrong, but it's just mentioning one of the examples of something that a real project takes you to. He wouldn't operate a CAD software. So everything was drawn by a pendulum on the top of the floor there and carved on the plaster, on the GRC that we had on the dome. So lots of work to produce something digitally, and in the end, it's the craftsman that guides the process. Final product is not, we are quite satisfied with the final product. There were some ideas of adding colors, but it's just the texture, the light and shadows that we needed to express the geometry in the dome of the mosque. Some other images of the garden. This is the portico. Portico again, the fountain, surrounded by a glade of trees. The trees have changed. Here's a portico again. That's from this side, the atrium, on the opening day. Lots of people using it, they love it. They are very welcoming. If you would like to visit, they are very welcoming to the picture, to the people that come. If you want to take a picture, someone will come and offer to take the picture for you. Here, showing all the hacks for shoes before you enter the ablution around the atrium. Here's one vision through the veils. So you have the ablutions there, you have the atrium, and then you have the, you can even see throughout the building if you have all the doors open. And skylights everywhere, even the ablutions. This is a view from the prayer hall. Here's what I was mentioning on something that we tried to push for. We didn't want to segregate completely both genders, so we have designed the mashrabias to work with different levels of privacy. On the edges you have tallest ones, on the middle you have smaller ones. So if you feel more comfortable, you can participate on the prayer hall. If you feel less comfortable and in need of more privacy, you can hide behind one of these tallest mashrabias, or you can use the prayer hall at the back here that you can see. Here's the prayer hall being used. We have designed a mirad for it, but in the end, for funding reasons, it was designed, built in Turkey, so that's not the ones that we have designed, but they actually follow the type of materiality that we wanted to use, which was basically timber and some goldish elements. Another view, this is how you perceive the dome, if you're really looking for it on the outside. And we come to a calculation that we are producing in the office. We have measured everything on the digital world in terms of energy use. There is the operational emissions as well. So it's something that we are currently actively measuring in the building to see if all those calculations from the several BIM software packages that work with Revit or not, if they are real. So in the digital, it does work. Here's Hopkins Brown Excel sheet. They have this. People can use their calculation for the embodied carbon and energy use, but we are throughout, we keep measuring the building to see if that is really reflecting what we have there in reality. Here's an assessment of the embodied carbon. So this one is not taking into consideration carbon sequestration. Let me just double check here. Yeah. This one is not taking into consideration the carbon sequestration of the timber. There's a whole debate if you can consider the carbon sequestration of the timber or not. Anyhow, we have measured both with the carbon sequestration and without the carbon sequestration. Another thing that we are doing in the office is a materials passport. So we are measuring every single material and we are creating our own library of materials and the embodied energy that each one uses. So that's the difference, taking into consideration sequestration. And the impact of it. You can see that with the data that we have, that concrete is not that bad, but if you add into consideration the rebar, it becomes a massive villain. And also something that we have been educating ourselves and developing is the circular economy, the donut economy, in terms of each one of the steps of a project, how we can approach them in a way that it can educate us to, in the future, design better buildings and more efficient. I'm going to jump this one because I'm not really sure if I can use, but at the moment we are developing also in-house. We are measuring the amount of timber that we have in the building, and we are cross-referencing this with economical values, carbon values, and like Sean was mentioning, the wellness factor of the building. And we have evolved, just like you said, 350,000 years ago, Homo sapiens, maybe even more because of all the other species, Homo species. But it is clear to us that with this research that we are moving forward with, is basically that timber also helps with more healthier buildings, not just timber, but natural elements like pure stone, without the plasticity of something that is quite recent, like plastic and other materials that we have been using. So this is something that we are still ongoing, or research that we're still doing in-house. Thank you.
Thanks so much.
It's hard to follow such a perfect project. So I've stood here several times, many times probably, presenting to new students and groups like that about Hooke Park. So it's been a pleasure and a bit odd to see other people presenting the Hooke Park projects today, but I'm really happy to be here and to be presenting mainly the work of a practice that I'm part of called Xylotech. It's a practice that was really born from Hooke Park and tries to embody a lot of the agendas that John originally set up there. It's a sort of design and delivery timber practice. I'll sort of introduce that a bit more in due course. I guess probably by reflecting on some of the projects we've been doing, maybe it can connect a little bit some of the morning's discussion about how we use wood, the kind of microcosm at Hooke Park and the thinking that's going on there, and sort of how that relates to the reality of the kind of commercial industrial context, trying to bring some of that thinking into actually doing projects in a kind of commercial way, and hopefully sort of feed into the discussions later. I did check with Francis that we weren't going to cover any of the same ground, and this, I think, was the one slide that slipped through. So a bit of sort of family history stuff again. So I was working at Arup, sitting next to Francis. There was a unit that came actually shadowing the Serpentine Pavilion projects initially, and then actually following this project, which anecdotally I was the engineer on, and Andrew checked my calculations and probably made some corrections. So I guess this was quite seminal. This was 2005. I think it probably has a sort of place as a sort of an early kind of digitally scripted, everything being different, robot cut structure. Actually, this talk, it was formative because I had to find someone who was able to work with students to build this kind of thing. And his name, Charlie Brentnell, kept appearing. He's kind of a magician with wood. He was really important in the sort of renaissance of oak timber framing in the 1980s in the UK, has an incredible intimate knowledge of wood, and had also worked a lot with sort of school kids, even building like timber frame barns and things like that. So he seemed a good fit. He then brought in this guy who he didn't actually know at the time, this guy called Oscar, who apparently was a really good guy at sort of getting stuff to happen, a really good project manager. So this was designed by a group of 6 students with some support from Piers Taylor as their sort of architect tutor. Amazing exercise of getting a large building together within an academic cycle. It was the first cycle of design and make. Those names I was mentioning, so Oscar and Charlie and myself, then sort of stayed in touch. Charlie kept teaching a fair bit over the years within the programme. And then the ideas emerged to form a practice that was sort of, together. Charlie had been doing his thing, Oscar his, myself mine, but they were cooking up some kind of practice, and I was like, I need to be part of that. So sort of been stepping away from doing so much at Hooke, still a bit in the mix, which is fantastic. Formulated this practice. The aim was to do non-standard timber. I mean, a word that's been sort of familiar at Hooke, trying to work with the sort of diversity of projects, diversity of material, not do everything in spruce and everything in kind of standard orthogonal ways. Trying to do projects where maybe others wouldn't want to do them, trying to enable architects to build what they'd like to do in wood, but then maybe somewhere along the line they get persuaded that they shouldn't be, trying to find the answers to the problems. So it's a 4-year-old little practice. We're based in Bristol, but always been sort of distributed, remote working kind of practice. We have a small workshop in Bristol that's really used for the R&D activities, and the model as we're growing is really to work with toning out, that the way to deliver larger scale projects is to work with the Central European fabricators as suppliers to us. So we're sort of designing the pieces, working out the geometries, working with engineers, sometimes engineering ourselves, and then finding the right people somewhere in the world to make the elements, possibly taking them through the workshop to finish them off, or that kind of thing, and then being involved all the way through to the installation and completion. So it's trying to be sort of taking that all the way through. The workshop itself does have immense value, though, for sort of R&D activities, for testing processes that maybe others aren't yet doing in a kind of larger industrial context. Doing the kind of experiment and fun that is possible at Hooke Park, finding a reason to keep doing it, in a more commercial way. I won't go through all that, but at its core, there's a mix of activities. So being consultants and having a kind of consultancy activity, complementing architects and engineers within projects, seeking to be involved really early to help formulate projects in a way that enables the wood to be used as well as possible, and then carrying projects all the way through the delivery stages and the project management exercises of that. There's been a set of projects. I'll show a couple of them. I think we've sort of been growing in the scale of what we're doing. I guess sort of to revisit a map a bit like the one I showed for the pavilions. Like it's hard to draw this map, even though we're quite conscious of wanting to know where our wood is coming from. Like the supply chain, the flow of wood around Europe is complicated, and it is hard to track. It's surprising. Like we want to use, as I was sort of saying, we want to use the right species, not just go for the easy choices. We want to find the right places to sort that material. We want to build with local timber where we can. Those challenges are present every day in what we're doing. And I think to it's interesting to hear the way Jez is talking about, I don't know, the English context, and now my awareness of seeing how the actual kind of reality of the timber industry is, how we reconcile those things is really interesting. So yes, I guess that's what I'm sort of capturing in this slide, which I wrote this morning as people were talking, so it's trying to kind of anticipate a discussion later maybe. But there's a microcosm of ideas at Hooke Park, amazing sets of impetuses and potentials that are being explored. There's a microcosm that kind of reflects a much, a wider reality of the world. And then there's kind of a macrocosm, isn't there? There's this European-wide context, which is, I guess, the reality really of our timber industry, with connections to other continents. And we're, the actual ultimate macrocosm is the planet, isn't it? Is the Earth. So it feels like we should be having a discussion from both perspectives. So there's a set of the global impetuses, the carbon impetus that we all know, our ambition for where we get to in 2050, like the incredible challenge that presents, and the role that architects play in that, and the role that timber plays within what architects can do, why we're here, I suppose. And what put the infrastructure impetus, but generally the building impetus, we know we're going to house 2 billion more people. There's a massive shift to urbanization. We have to build a lot more stuff, before 2050. So how those things get reconciled, so there's I can kind of see there's extremes, isn't there? There's a solution to that stuff where we're on a trajectory towards this sort of international, centralized industrial reality, which I think is the opposite in a way of what Hooke's arguing for, which is much more something that's localized, distributed, minimizing transport, using the local particularities, working with the diversity that you have there. So I don't know how we navigate those extremes. I think is sort of, to me, it feels like it's the challenge for the people in this room. Yes, Design Tech's projects sort of sit somewhere between the two, probably. And generally, I'll try and remember to talk about where the trees have come from, and sort of where the diversity comes into these. So jumping to sort of the extreme, the biggest project we've done. So a sort of set of circumstances led us to actually being the company that became a big, like a £3 million job for us to do the rain screen, and then there's a CLT, so cross-laminated timber auditorium inside that. Yes, we took on, initially we were involved just from a sort of design, geometry, definition, technical definition perspective. It grew to being a full appointment to deliver this. So it's a 1,600 seat, 1,500 seated auditorium. You probably know this for the ABBA cinema, effectively, but the amazing, incredibly technically amazing sort of virtual ABBA concert. So there's quite a complexity in the geometry. It's not a sort of orthogonal structure. It incorporates the seating. Yes, well, it says there, doesn't it? About 1,600 separate panels, all unique geometries. It's a 4-story high, I think about 45-meter wide structure. So it's a significant structure. A key bit of the brief was that this building is going to demount and probably move other places in the world. So without sort of deliberately being about the kind of reuse agenda that we were discussing earlier, that was explicitly in the brief. So it did take a fair bit of thinking about what that means for a CLT structure, which is normally put together with big long screws that are very difficult to get out. So a bunch of things were kind of worked through using sort of ledger details. It meant that things could be bolted rather than screwed, as Francis was saying, using products that could come back out of the structure to enable it to be dismantled. And probably worth noting as well, so originally the idea was to do a steel frame structure with wood panel infill, and shifting it to a full CLT structure. There was a big, I don't know the stats off the top of my head, but I think it was like a 300 ton of steel saving, so big carbon benefit in that. It's kind of interesting as well. It sits on a existing car park with no foundations, just lots of these jack pad footings. So I don't know, it's a sort of example of a low impact, reusable building. Potentially, it's an interesting one. So this was the Austrian supplier. So Haslacker was a supplier to us. They were the people with the big machines that were producing the glulam, cutting the pieces, spruce from Austria. The main screen we produced as well, we did assemble in Bristol in workshop space there. So I think it was 204 of these panels pre-assembled on a jig that allowed different geometries, angle geometries to be taken up. This is larch from France, finger jointed in France, and then sent to Yorkshire, I think, to be stained and fire treated, and then to Bristol, and then to London. The staircase, our colleagues will know. So this is in Douglas fir, CLT, from France. Have I got that right? With oak around it. I think Spanish, actually, isn't it? It's a Spanish Douglas fir, Andrew might know. So again, another nationality, not the UK. The right place to get this material from for this project. This sits within the Balliol College complex that was presented earlier by Sean. So in amongst the CLT buildings, there was a smaller sports pavilion building. Niall McLaughlin, architect as well. We picked this project up sort of at a late stage. So the main thing we were doing was the installation, but also quite a lot of work around in the end, sort of around the detailing and some of the relationship with the envelope for this. So it's a sort of nice, refined, sweet chestnut project. Stacked laths, sort of erection sequence that demanded fixing from above to keep the screws out of sight. What's that one? So this one, I guess, takes the grid shell typology, takes the route. This ends up being a glazed grid shell. Demanded a sort of precision in its geometry, and the decision was made to glue laminate laths, each one different, out of oak, finger jointed oak strips. I think Latvian, certainly Eastern European oak. So there's a process in the Bristol workshop of gluing these up on CNC cut jigs, a full pre-assembly. Maybe one thing to note a little bit in response about maybe what Francis was saying about this sits somewhere between the sort of big subtractively carved pieces of glulam that become grid shell geometries and the kind of pure Fayotto type one. So there's a geodesic geometry to each element, which means they can be made from straight pieces of wood. So the wood twists and bends to follow the surface, but it doesn't have to bend sort of side to side. So it means there's relatively little waste in the process. It's pure straight planks producing these curved elements in the freeform surface. So there's pre-assembly in the workshop, a 3D mapping of those nodes, the glass then cut to that geometry, and then a quick couple of days reassembly on site, and then with the glazing on. So the bolts that clamp the layers together became the sort of mushroom fixings for the glass by IPIG, the company there. On a smaller scale, working with Arthur Mamimani, graduate of this school, doing some pavilions for sort of interior breakout spaces for Orange Telecom. An exercise in steam bending, really, and an interesting exercise early on in a sort of iteration with a digital simulation, working between architect, engineer, and ourselves, and the physical reality of steam bending, a very sort of unpredictable art in a way, what actually happens to a piece of wood. We actually brought in a graduate of the Lyme Regis boat building school who had a great bit of steam bending experience. He went, so this was made from ash. This is actually English wood. So he went to Vastons, the sawmill, and was selecting plank by plank as it came off the sawmill, which ones he could judge from his intuition would be suitable for steam bending. So there's something in that. I mean, it's present in the Hooke Park work for sure, where you kind of build an intuitive understanding. Yeah, something in that in this project. That's that one. Technically a grass and not a tree, so working with bamboo. This is from China. Again, moving material around the world. So thin strips of laminated bamboo, and then parts which are sort of laminated up ourselves into these geometries. It's kind of interesting working with something. I think bamboo's less forgiving than wood somehow. If you bend wood to a shape and sort of leave it, somehow it relaxes, it creeps a bit. It's unlikely to break on its own later. Bamboo doesn't do that. We found, you could sort of push it to an extreme, think that everything was happy, and then you'd come back the next day and something had gone. Something different in the, I guess, in the anatomy and the sort of the microscopic behaviour of the grass rather than the tree. So that was a bit of fun for that. I think I've only got one side of that, but this is probably the most Hooke Parky of the set of these projects. So this is at the Western Burt Centre, the National Arboretum. So it's using big mature oak trees that they had to fell for safety, I think, in a community group sort of engaged project. So it was designed with the community and built with them, with sort of special needs groups that came in for educational needs and that kind of thing. So none of this wood left the site, a bit like a Hooke Park project. So the oak felled, sawn with a mobile sawmill, steam bending on the actual site here, away from any services, bit of glue lamination, maybe not glue lamination, a bit of sort of screw lamination in some of these curvy edge members. This fun one. I think this is the last of this little sequence. So this is about half a mile from here. So in Regent's Place, just through the summer, we built this series of just these open lattice oak pavilions. So similar technology to the glazed grid shell I was showing. So gluing up straight lamellas into curved shapes. In this one, there was a trick of using kind of rotational symmetry within the pavilions and sort of cutting them to different lengths. So not needing to have so many different jigs to make it. I think a set of 12 different geometries made all the pieces, some pre-assembly in the workshop, and then those pieces, brought together on site. That's with Next, Alan Dempsey, a graduate of DOL here. Okay, that was to sort of run through some projects. This is sort of probably half-formed thinking, but maybe trying to provoke some reaction from Alex and I don't know, just to sort of see like where some thoughts go. But feels like there's two extremes to me. There's the sort of an approach to material which is to minimize what we're using, to use it in its lightweight sense. I guess it comes from, it's Foster's, like how much does your building weigh? It's Fiotto's, all of his work, isn't it? Trying to get the most out of material. I guess it's born out of the 70s energy crisis and things like that. There's that kind of minimize what we're using. And then somehow there's something in mass timber which is, it's not as extreme as this, but there's something in that which is celebrating as much wood as possible. Locking up the carbon, trying to almost find reasons to put as much wood in there as possible. So there's those kind of extremes, isn't there? The optimal use of resource and the max CO2 sequestered. So I guess if we're using less resources, well, there's less embodied carbon in the sense that, we're doing less transportation, there's less weight to move around, we have to lift less things. There's a general efficiency, isn't there, in that sense? There's less sort of carbon, obviously, in the actual wood, but the embodied carbon from the other activities is lower. We're using less wood per building, so maybe it becomes cheaper because there's less demand, and there's just more wood available. So if we're building for 2 billion people, there's more wood, there's going to be more buildings that can be built out of wood, I suppose. There'll be fewer steel and concrete buildings, which I guess is the ultimate aim. If there's wood left over, are there other ways to sequester it, I suppose, is then a question, isn't there? If we are able to maximize land use to grow as much trees as possible, if the stuff that's not being used in, I suppose the question is buildings the best way of locking up carbon in wood, I suppose. If we go for maximum material use here, you're maximizing the carbon you've sequestered. You know, you're using the buildings best as a carbon sink. You know, there's then this whole life cycle question, isn't it? Like, it's only a net sink if your building life is significantly more than the forestry cycle. You know, I guess if it matched the forestry cycle, then all the sort of extra energy we're using, transportation would be negative, wouldn't it? You know, so you probably want to sort of at least be 1.5, 2 times the forestry cycle to keep locking up carbon. You know, or there's the questions then of reuse, or I guess again sequestration of your wood in some other way. This is Stolen diagram that you do, Mamtel, amazing sort of graphic of Europeans' flow of wood into pulp and paper and things like that. You know, where it all goes. Some of it gets recycled, bits and pieces. You know, the carbon products sequestered bit is that little bit there. So I suppose it's sort of then, yeah. Back to the forestry kind of questions, I suppose. You know, forest is going to building. What then do we do with that wood? Do we just dispose of it, let it decay? It goes back into the atmosphere. Do we burn it? Do we burn it for fuel, recycle, reuse, or do we do something which basically turns it back ultimately into fossil fuel? You know, that we bury it anaerobically, or we biochar it. We do something to then sort of preserve it in its locked up state. So I guess this reflects then back on what the forestry is for, isn't it? Are we growing trees for performance, you know, for optimal structural characteristics, optimal durability? You know, is that why we're growing our trees? You know, is it so that we can, you know, build the most efficient buildings possible with the absolutely lowest weight? Do you know, is that the extreme? Or is it the other extreme? Are we growing for bulk? Are we growing to lock up carbon as much as possible? It's almost like we don't want very good wood because we want to grow as much of it as possible and get it locked up in buildings. So I don't know, to me, it's confusing to me, you know, how we navigate this. It feels like they're questions that should be being asked and answered. You know, I think there's something in, you know, if you take it to the extreme of growing trees just to lock up carbon, then you end up doing something crazy like growing trees and then filling big holes in the ground with them or something. You know, that you literally are growing vast bits of land and filling the holes that we've mined things out of or something. So I don't know, I'm going to end with that one. It's a slightly weird provocation, but yeah, thanks.
So our last speaker of the day to round off. Very, very excited to have Kai here, so it's fantastic to have you there. Do you want to stand up?
Yeah.
Yeah, or sit down? Okay.
Perfect. Thank you very much for inviting me, and I hope you still have a little bit of energy for the last talk. So I will talk about freeform timber projects in architecture, and I will show 5 different approaches, technological approaches, on 5 different projects we've done in the company. You have seen this picture before. This is a place where I'm coming from, where I'm working. There's one thing which I find absolutely amazing. There's a very little creek there, and in this creek there's absolutely no water. And 147 years ago, Mr. Lehmann had the idea to make a sawmill there and start his company there. And I find it, first of all, totally amazing to make a sawmill with a creek where there's no water, and then to see what happened in 147 years at this place. We are trying to close the value chain of the wood. So we have the sawmill, we have the products, we cut our wood, we sell the wood, and then we have different companies selling all the wood, or we do constructions. So we had this idea from cradle to grave. This is a little bit what we are doing at Bluma Lehmann. This is one extreme, and this is the other extreme. And I'm not showing these projects, but what I want to show on these projects is very often we have, these are not the same structures, but they look a little bit alike. And it's super important to make experiments on these structures before you build them. And if you look how things work in architecture, very often the constructor comes after the submission. And I think this is the biggest mistake in complex architecture. And what we do, we always do a pilot. We always, what Sean was saying, we always experiment before we are really getting the submission of the building. And I think this is why, until now, we are quite successful with our projects. This is a project very similar to what we've seen just before. It's a pavilion in Ohio. And the idea was to take Accoya, because it's on the outside, and glue the Accoya together and create this kind of freeform shape. And again, we did this in the workshop in the company, glued it together, sanded it, and then we left it outside for half a year. We left it in the rain and looked what happened and how the wood reacted. And with this knowledge, then we worked on the project. So we have a digital data. We don't have one jig, and we are not reproducing the same things. All of these things are unique. So we have a super complex jig below, not very efficient. And this is the substructure. We are gluing these Accoya sticks together, and then they come a little bit like spaghettis, like we fold them around, and we put them on the jig like spaghettis. We completely fill the structure, and afterwards we have to wait until they're dry, take them down, sand them. They all have a number. They're shipped to the US, to Ohio, and then they are reassembled on site. So this was like one project I wanted to show. It's one technique, not very digital, very handmade. But I think this is also what happens in our company. It has a tradition of 147 years, and we're really trying to work in both directions and look in both directions. What could have been done in the past, and what is the potential of wood, what can be done in the future with the wood. So this is another project. I didn't want to show the Cambridge moss because I was sure that all the slides would have been repeated. So I'm showing a different project with a glue lamp technology. So this is a casino in Venlo. And inside of the casino, you have this kind of tulip, which you can see. And then you have this, it's like a sunflower. And the dimension, this is how you see it from the top. And the dimension, it's like one sunflower, 53 meters by 42 meters and 24 meters high. And what happens very often, this is why we also go very early into the projects, that we get a design and then we work together with the architect on the design. For example, in the Cambridge Mosque, Guillaume was talking about the radiuses. The radiuses have a super big impact on the cost of the wood. And by optimizing this, you can really optimize a project a lot without necessarily changing the architecture. Here, the design came with a cross-section of 20 centimeters by 1 meter 20 and beams of 17 meters length. So this is for us really complicated, because if you have a machine and you have a beam of 20 centimeters by 120, you have so many vibrations, it's very, very difficult to process. So we took the design idea, which was this one, and we changed it into this one. It's not such a big change, but you see, we worked on the curvature, we worked on the structure, and the biggest change we've done is when you look from the top. This was the initial structure, and our structure is like completely vertical. So we have the possibility to vertical extrude all the beams and place the beams in the structure. The Cambridge Mosque is when I show projects like this in the company, I always say we have the the regional football team and then the Champions League. And Cambridge Mosque for us was absolutely Champions League because you have everything is complicated. Like the wood is complicated, placing it on the machine is complicated, the assembly is complicated, the knots are very difficult to produce, and here we try to reduce it a lot. And this was the initial structure with a beam of 20 by 1 meter 20. And then we reduced it to 4 layers, 1 layer A, B, C, and D. You have a lot of screws inside. It's not a wood-wood connection. Here you can see how it's engineered. And then Guillaume was also talking about the wood price. The wood, you have to take like singly curved, a straight wood, singly curved or doubly curved wood. And this has a super big impact. Here we have 24 straight blanks, 230 blanks which are singly curved, which are much cheaper than the ones from the Cambridge Mosque, which were like doubly curved. Here you see the difference of a doubly curved blank, a single curved blank, and straight blank. These are blanks from the Cambridge Mosque, by the way. And when you bend wood too much, you break it at a certain point. And there's a ratio of the radius of the thickness of the lamella to the radius divided by 200. So if I have a radius of 2 meters, I have to take a lamella of 1 centimeter. And industrial wood comes with 40 millimeter lamellas. So it's a radius of 8 meters. The trunks at the Cambridge Mosque, they had 8 meters of radiuses. And the trunks were much cheaper than the crown. And here you can see the production process. This is of a singly curved wood with completely with lamellas. And if you want to doubly curve this wood, there are different techniques. One technique is to slice this piece, and then you create out of this piece a kind of salami structure. And this salami, you build a jig, and then you glue it again into the jig. And this, of course, makes it much, much more expensive rather than having a straight beam or even a singly curved beam. So this is a little bit the idea. If you have price X, singly curved is 2 to 5 times more expensive, and doubly curved is 3 to 15 times more expensive. And this depends on the curvature. Like 15 times, it's more expensive when it becomes very thin, the wood. And yeah, very often when you offer something, they ask you for 2% sconto. Here we talk about 1,500% more expensive. And this is super important to really understand where the cost is and what you really need in the design and how you can optimize it. So why don't we take a big piece of wood and just cut out whatever we want? This we cannot do it because we have to follow the fiber direction. We saw this in the presentation of Arup. So here, this is the strength in compression and tension you have depending on the angle of the fiber. So if I take 90 degrees, I can really tear wood apart. If I turn it along the fiber, I have a good compression and tension situation. And for the building, like for the swatch building we've done for Shigeru-ban in Biel, the engineers gave us 5% of deviation from the line of strengths from the calculation. So we really have to bend the wood exactly how the forces are expected to follow inside. So then we get the wood in the company. These are my colleagues, and like my main work is to get geometric data, get the wood, and bring the data on the machine. So we are in traditional, like sticks and slabs and panels. You have a catwork system software, and you have a machining software behind, and you can create a complete roof structure in a day, create the production data, put it on the machine, and assemble everything together. This is extremely industrialized. When you go into the freeform structures, you don't have these processes so optimized. So we have produced our own thing with Rhino, and we're producing the G-code which goes directly on the machine. I worked before for an architectural company. We had a 3-axis machine. There's a huge difference between 3 and 5-axis. It's collisions. Like in 5-axis, you get so many collisions and so many difficult situations to solve, especially when you have buildings with lots of different parts and unique parts. So for the Venlo project, we had quite thick wood, but it was only singly curved, not doubly curved, and we had to mill it in 2 phases, like turn the wood and mill it from 2 sides. This is the machine which we are using. And here you see, normally you have doubly curved wood with planks of up to 28 millimeters. If you have thicker, you have to glue them together in blocks and generate a kind of block lamination. And this is what happens. For example, we cannot use a thicker tool because it's too heavy for the machine. And the same thing, we have to control really the movement of the tool not to get collisions in the top. And this makes these 5 freeform projects so difficult. We have a machine with 2 aggregates. You can see one here and one on the top. This allows us to work in copy mode. So very often you have objects copied. We just put one on the machine and the other one is for free. And then we have one aggregate from below, and we can use it to create some pockets. And with this aggregate from below and the one from the top, we have the possibility to create extreme precision on the project. And we simulate everything, because also here the aggregate from the bottom, you have a lot of collisions with the carriers. And then afterwards, we do as much as possible in the workshop. Like for us, we had this discussion of in situ and fabrication. We believe that the fabrication or prefabrication in the company helps us a lot to keep the building sites clean and short and save money there. And then you see there is a lap joint I could not cut out completely because the building has this kind of slope and the direction of insertion is vertical from the top. But the engineers came only with knots where everything was orthogonal. And we were not aware of the situation that I could finally not mill the last pocket, because here I have this, and otherwise I would run into the corner. And this is expensive. If we have thousands of joints, these are thousands of joints we have to, in the end, do by hand. And this is why we want to do experiments and see pieces before we put them on the machine. We have not done this in this project. Here we have the situation of the trunk to the flower. There we have bending forces to deploy the forces into the wood. We are gluing in steel rods and putting a steel connection into it. So we are putting in the steel rods and then we are gluing them on like 1/2 meter into the wood. And here I'm showing you a few problems. Here we have a piece which is absolutely not to our satisfaction because we have spring-back forces in the wood. And this was a big issue. We had spring-back forces of this was not the final milling path, but on one side we had 1 millimeter, on the other side a centimeter. And the situation is we have a thick piece of wood, and then we are cutting it in a diagonal out. So we are cutting through the fibers, and the fibers are still active in the wood. So by cutting through all these fibers, the whole part is still a living part which is reacting and changing, and you cannot predict it. So the strategy was then to change it a little bit and cut the wood as much as possible wherever we could. We tried to relax the part before finally milling it on the machine. So these are the parts. Then another problem we had when you use glulam and you use this dark brown. We don't like the color so much, but the problem is that the color does not stick on the glulam. And when you cut in an angle, you have these white stripes. This is the glue of the glulam you have. And things like this appear then on the production, and this happens if you don't do enough experiments. So these are the parts which made it difficult. These are a few images of the tulip. And everything is packed. We saw before this image with the moisture of 12% of the wood. So we dry the wood down to 12%. In the company, we keep it at 12%. We have a regulation system in the roof. Then we pack it like this, which is not very sustainable, but we bring it in this situation, in this moisture situation, to the to the site for assembly, and then we have very little shrinkages and differences on the size on the wood. And these are the assembly of the tulip, the beams. We work very often in all the sites with our own workers. Also, Cambridge Mosque was done with a team from Zurich, from Gosau. And this is a final image. So that was the second project with glulam. Now I want to show a different project, which is super interesting. I don't know if you know it. It's done together with the University of Stuttgart and the EMPA, which is a research institute in Zurich, and the ETH. So rather than gluing rather than bending the wood, we asked the wood to bend itself. You know what a B-layer system is on wood? No? So for example, when you have wood which is very wet, it has the tendency to shrink. And what we do, we take a piece of wood and make it extremely wet, and we glue it together in a cross-laminated with another level, which is super dry. And then when the moisture gets the same percentage, then the whole thing starts to bend. Naturally, you can see it here on the right side. And this was calculated together with the EMPA, so you have no milling process, you have no loss of wood. It's quite, and it's extremely predictable. So we built a jig, and you can see here on the top the initial parts. And we glued two of these parts, one on top of each other. And then in the end, we did not have to mill anything from this side. We just had to format the pieces, and put them together. Again, as much as possible on the side. Then the EMPA came and they said they wanted to make a bigger prototype of a meter 20. And Katharina Lehmann, who is the owner of the company, she said, why don't we use a truck and make it 11 meters high? And now it's sitting in Germany, in southern Germany, completely full with electronics, and they just want to see how the structure is going to behave in the next 5-10 years, and if it's reacting or not. So then we put it together. And so this was the third technology. The fourth one is with steamed wood. I was showing you the Venlo part, and I was showing you what happens if you mill through the lamellas, that it's not really beautiful. So this is the working site. We created also a small sunflower inside, and we had very small radiuses of 800 millimeters. which turns back in 4mm wood. And if you have 4mm wood and you bend it, it's impossible to stay in the lamella. So if you imagine one lamella being white wood and one dark wood, you're constantly changing the lamellas and it becomes extremely ugly. So we had only 12 different radius. There could be a little bit of sound. So this is the autoclave. In this situation, you're not putting tension to the wood, but you're putting compression to the fiber. You're changing the fiber. You don't have the same strengths and structural possibilities with the fiber when you work like this. And the other thing is you only have 15 seconds to bend the wood. You have these steel plates which are keeping the wood in place for 2 weeks, and afterwards you have very little spring-back forces. And the bending process works much better if you have thick wood. So they don't do this with thin wood, but rather with thick one. So then we have these different layers. And this is basically the normal process of doing a singly curved wood. So this is how they come to us before milling. And for structural reasons, we had a few thinner lamellas in spruce. And the other lamellas were in ash. Ash is not certified for structural wood but it's a building in India, so certification was not the main topic. And this is how it looks. It was quite, we are quite happy with the result because ash is an extremely wild wood and it's very difficult to really get a continuity. And we did not know if the client would be happy in the end with this extremely wild pattern. But it works well. So this is technology number 4. And the last one is a project we're just doing now. It's a project where we are doing an active bending of wood. And we work together. So we did both the dome inside. It's a museum, a Vis Dome, a museum in Stockholm, and the roof structure and the dome. So the dome is CLT. It was quite simple. And in this case, we are not bending wood, but we are using flat wood from Stora Enso, LVL, and then we are bending it actively into the structure. So these are the very first experiments. This is Hermann Blumer. This is the Pope of Wood in Switzerland. He gave his name to the company, but he's like only starting projects. And so what we've done a first jig, and we tried to understand what happens if we do not only bend the wood, but if we also have torque inside the wood because of the project. And then we thought, okay, we make one mock-up where we have the most bending moment inside the structure. And the idea of Hermann Blumer was if you just put dowels inside, and these dowels are really firm inside, you can bend it, mill the dowels, put the dowels inside, and afterwards the structure would stay in this bending moment. So we've done it. We created jigs, banged the wood inside, and then we milled everything. We put the dowels inside, and then we released it. And in the Venlo project, we were already like freaking out of 1 centimeter. And here the wood was completely straight again. So complete failure. And we put the whole thing together. It looks a little bit like this part of the dome, but it has not the bending of it. It's anything. It's like you can forget it. But Hermann Blumer said, yeah, looks like it works. And everybody was looking at him and like, wow, it doesn't look like it works. Then we said, okay, we make a second mock-up. The second mock-up, we make a long part where we have a lot of torque. And we try to make the torque with a part of 16 meters. So we put it on the machine and milled it. Then we hammered all the dowels inside, which our machine didn't like at all. because it's like constantly reacting to each hammer hit you put on the machine. And then we released it, and it went like 1.2 meters back. So again, a complete failure. And then we said, okay, if we do the project, we have to change things. We have to put an extra layer. Instead of like 4 layers, we put 5 layers. And we are not only bending the wood with these dowels, but the first layer, the layer R, we are going to glue it in the company. So it gives us a certain stiffness, a certain shape, which we can rely on afterwards on the project. And then the B to E are all bent and fixed on site. So we developed the dowels much more. And then we had like these rectangular dowels are always between layers going in the same direction, and these conical dowels, all dowels between these 2 directions. And the conical dowels are calculated in a way that you can like use this bent straight wood and place it into the system. Then we faced one big problem. The whole thing was sponsored by Stora Enso, and they wanted to already calculate the logistic and the shipment and the nesting of all the segmentation. And we said, we have no fabrication data. We are still not with a final mock-up, which we are proving, but they forced us to calculate or design to production to create a nesting. So we've done all the nesting for all the parts, but all the machining, all these things were not done in this moment. So they did this segmentation first. They segmented everything so we could order the whole wood and be in time and calculate all the logistics. The very big advantage of this project is that you can flat, like all the containers are flat, except of level layer R, A. And the fabrication data came only later on and was incorporated digitally in the whole thing afterwards. And when all this was done, we decided to make a last mock-up to be sure that with the fabrication data and with all this, that we would be able to produce it. So this is an image of the fabrication data. And this is a short animation, if it works. So with this, we were quite confident, and we went on site, and I think this is my last. It's a short movie which gives a little bit the impression of the work and the process on this project. It's not so quiet in the company. That's it. Thank you very much.
So much, Kai. Thank you. It's a bit like looking up in awe at your big brother, you know, when you think about Hooke. I thought we could get this panel just maybe back at the table quickly, but actually open up the conversation perhaps beyond and to questions that might be directed at these three
but also might be directed at the different conversations we've had throughout the day. So conversations that might be about forestry, directed at Jez and Kat and Gabriel and Chris, if he's still around. Conversations that might be about materiality, directed at Alison and Sean and Francis and Andrew from the middle section, and questions that might relate to the stuff we've just seen, which was kind of loosely, and there is crossover and there is blurriness between the three sections we have, but about architecture and space. I had a first question for Kai, which is if Bloomer Lehman had a forest surrounding it, what would that forest be? How would that change the way that you work, and what would you want that forest to supply for the future of the building industry?
We have a forest. And the opinion of Katharina Lehmann for the forest is that our forest in Switzerland, they need to face a lot of needs, which are, the society is going inside to walk on the weekend. You go with mountain bikes inside. You have the issue of diversity, but you also have the issue of producing timber. So she sees this as a kind of situation where you actively take wood out of the forests, you replace it, you look that you have parts with biodiversity, but that you try to, I think this approach of diversity in architecture as well as in forestation, I think is the best reaction to it. So she's not for monocultures, which does not work in Switzerland. And a lot of these forests we have are super complicated to harvest. Some of them are harvested with helicopters, and it's like, but yeah, she sees that the forest, it's the same like in agriculture. You cannot feed the world if everybody is having a few chickens in his garden. It's impossible to feed the whole world. So you need also an industrial approach on the forest. But you also need all these other demands from the society, and you have to fulfill them. And biodiversity is one, and the other one is also for people just walk in forest and relax in forests.
Should we throw it open to the floor? Yes, Gabriel.
Yeah. Can I ask a question to Martin? It's like, that's a fantastic talk. It's been such a stimulating afternoon. I've been burning with a feeling, a question. So you said something really powerful about the little project. The project you did in Westonbirt, where you never went off site, you got all the timber you needed, you made it on site with local material. And in your other examples, you talked about using Douglas fir from Spain, and other materials from around the world. It just struck me how, in one sense, you were proud of the fact you'd used local materials on a local site, and were very happy to talk about, it's not personal criticism, very happy to talk about sourcing timber from around the world. There's a terrible split, isn't there? And that captured the whole problem we've got. We can grow timber in Britain, we could grow more timber in Britain, that you shouldn't have to go necessarily all around the world to get our timber. We have the skills, we have the resources. Yes, we can't meet all of it, but we could do some of it. And that little vignette to me captured the promise as much as I hate saying, I'm talking to a forester, the embarrassment that we haven't fixed it. I mean, what a mess. Can you respond to that thought?
Yes. Is this mic working here? No, I mean, I think that is the crux, isn't it, of the question, of today, as it was sort of formulated this morning. I think I was deliberately kind of presenting that sort of paradox, or that scenario that we've got, that we're motivated to use wood, in its full kind of variant, particular ways, and to work with the stuff that's around us. I mean, there's, trees grow everywhere, and they all have their qualities, and that all of those trees are usable in various ways. So why we're locked into this scenario where this situation where we're both kind of wanting that and then having to transport things all around the place. Yeah, it is paradoxical. I think I don't think I said, but the maps I was drawing the lines on were the tree sort of density maps. You can kind of see the patterns, can't you, of where the trees are, and there's a reason why the yellow dots are kind of where they are. I suppose it is where the densest forestry is. I suppose where the large industrial centres. I guess Blue Malaman being an example. Where those companies have generated, and most of them have come over centuries, haven't they? They've developed from relatively small scale sawmills and carpentry companies, and they've grown, the Haslackers and the Blue Malamans and Simlins. They are like family companies that have grown in that way because there's a density, there's a critical mass of trees around them, and somehow this country has sort of had it to a point, and then it's fallen away. I suppose. I mean, you know better than me, but there's something, isn't there, in this country, in its history,
The question to me then is so what about Hooke Park then? Because if we're looking at the potential for Hooke Park to have insightful impact, visionary impact, and make a difference, it's about being exemplary, which it already is, but I think it's that broader context about what could Hooke Park do better to not only sort of continue this conversation, because this is too rare, isn't it? The fact that we are, using my title, straddling the forest gate, but it's also straddling the architectural to the, we need to carry on bringing this together, but Hooke Park particularly has a role in this amazing opportunity of having forest and architects in one place. And so it'd be really nice to think and discuss that a bit more, I think, together.
Can I just try to answer? When I studied architecture at ETH 30 years ago, I could make a design of a family house or a two-story house in wood. It was unbelievable to think about using wood in an urban context after having all these cities burned in the 17th and 18th century. And it was unbelievable to do a stadium or a mosque or airport or high-rise. And I think what happens nowadays to the wood, and there Hooke Park plays a role, is just to open the fascination of wood. And of course, it does not make sense to make a high-rise. But as an iconic building, as to show what the material can do as a possibility, maybe it has a reason. And I think for me as an architect, it's a little bit the atmosphere which I think Mies van der Rohe had in the early 20s last century when they started to work with concrete and glass, and when he did a drawing of the Friedrichstraße where you could see a high-rise building with glass and nobody could understand how can you make a building with glass. A wall is a wall and a window is a hole in the wall and you make a window. And suddenly somebody is designing a complete building in glass. And I think we are facing a similar situation with wood nowadays. And Hooke Park and Blue Malaman and these iconic buildings are not going to save the world, but they're going to present what wood can do and trigger the imagination of maybe a lot of contractors, house builders, and architects.
I wanted to come back to Gabriel. Just one of the things that comes up is whether or not it's okay to take timber from Scandinavia in terms of its carbon. And it's an important distinction that the actual transport emissions are like 4% of whole life carbon assessment. The actual material itself is 50%. So actually, I would rather be getting timber from Scandinavia than using concrete from the UK in that kind of situation. On the other side of that, your discussion about whether or not we have enough timber would have enough forest in the UK, I think is a separate one. But I just wanted to make sure that it's kind of clear that actually, in some ways, bringing material from elsewhere is better.
From the carbon perspective.
From a carbon.
What about jobs and being wood isn't in good condition?
Yeah, I know completely. The other arguments. Yeah, I completely agree that we definitely need to have more managed woods. No, because it's not exporting our footprint because it still counts as our emissions when we take timber from over there.
No, so I mean the whole, it's not just about carbon.
Yeah, it has a larger impact. So we should be doing it. But this comes back to your point that you were saying before, that But we need to be thinking about what do we need in 100 years, because we can't just suddenly have a forest in the UK. So we have to think, we don't have enough forest now, so we need to be ready for in 100 years' time when they want to look back and say, well, they did a good job. They got planted lots of trees and got ready for us. So that's what works around that.
Thank you. Whilst I completely agree that Hooke and experimental timber work being carried out anywhere in such an impressive way is inspirational, from the architecture and practice industry, the enthusiasm for timber, which is finally happening, has a simultaneous fear of not enough timber being available. And I don't really think it's about the UK. You know, it's a global thing. I think it's a societal thing. I think, you know, this country used up all of its timber making a navy and fueling the Industrial Revolution. You know, we had timber and now we don't. We have maybe 10% of the land area, whereas, say, Switzerland probably has 50% timber. So I think it's a societal issue, it's a cultural one, it's about land ownership. This country, you know, most of it is owned by a very small percentage of the population, and that's the reason why forestry is stifled in the UK. So I think we have to look beyond this little island and think about it in global terms.
But this is like in Switzerland, you have 10 million cubic meters of wood growing every year in the country. We're using 5 million cubic meters. We could harvest the double. We are only working, I think, 8% in the building industry is using wood. So if you would go to 16%, we would already take all the wood we have. But I think, yeah, I think also the discussion, what Martin showed with the mass timber, the CLT, it's an incredible use of wood. And the moment more people will need wood or are going to work with wood, the more you will go back to these solutions where you combine materials, where you take the efficiency of each material and you really try to minimize the amount of wood. So I think I cannot talk for the UK, but I can maybe also not talk for Switzerland, but a little bit. I think we should not be afraid in jumping into this timber world. And if we're getting less timber, if we're using 16% of the building industry in timber, I think this is a good step. And we are going to innovate. We're going to create new structures which are using less timber. So I'm quite confident that it's good to have this momentum at the moment and use it also for the near future.
I'm personally struggling with this idea of how sustainable is it, like, to develop prototypes and the kind of wastage that eventually you're kind of leaving from kind of testing stuff. Because especially like the scale of the projects and the number of failed prototypes. So is it sustainable eventually to like...
It's absolutely sustainable. I worked for Herzog & de Meuron earlier for 10 years, and I worked on the Elbphilharmonie in Hamburg. And the city of Hamburg was commissioning the building before the design was finished. The first estimate of the building was 42 million euros. And in the end, the building cost 697 euros. I'm sure with a few prototypes and mock-ups in early stages, you could have saved a lot of money, and this would make it also more sustainable. When I studied architecture at ETH, it was the time when Peter Cook did the Bobble in Graz, and Mercedes-Benz did the blob architecture, and BMW did the Korb Himmelblau architecture. There was one thing which is super sad. A lot of companies thought, if I'm building for Peter Cook the Bobble in Graz, I'm going to be the king on the market. And you had a lot of companies, family companies with 50, 60, 70 people with a tradition of 50 years, 100 years, which went bankrupt. So I think when we talk about these special architecture, we absolutely need these prototypes. And the question of sustainability is not the right question, because if you destroy a whole company behind, I think you leave much more damage than creating these prototypes.
Just a quick one. Fantastic presentations, and it's great. I love the way you showed Kai. Is it Kai? Yeah. Showed 5 methods, because it's very interesting to compare them, isn't it? And the first few methods, I was tempted to sacrilege in an architecture school and say, why are we doing curved timber? It completely fails what Louis Kahn says. Do with the brick what the brick wants to do. There's no way a branch wants to go through all that processing to create double curved glulam. But then you gave the answer later on in your other methods, in the newer developed methods, which sort of hark back to the other method, the old Mannheim grid shell methods. You sort of, if you're taking timber straight to site and you're curving it, you are beginning to do again with a branch what a branch wants to do. But what I suppose what I want to do without sacrilege to architects is, why aren't we making? We don't want to encourage architects to do curved timber. Timber grows in straight segments. Why aren't we doing straight? What's wrong with straight trusses? What's wrong with? We have to be careful when you're speaking in an architecture school, engineering knowledge. They suddenly think this is a sensible thing to do.
I agree. I totally agree. But I think the thing is the diversity, you know? You can do it. And you show the whole potential, the possibilities of timber. And I do not believe, I think that the freeform timber is a niche and will be a niche. So I think we are filling up a niche. And the main, that's what I said in the beginning, when we're working on a Hundecker machine, we have processes, they are so incredible, working well, it's unbelievable. Like I gave a course on a university, or I've done this at different universities, which last 5 days. Students in St. Gallen, it was students of the first year, their first day of architecture. They came, they got very small sticks of wood, and they had to do a very small building for 2 people within 5 hours. The next day, together with some older students, they had to translate these designs in a Rhino model. Day 3, we did CAD work, the production data. Day 4, we went on the Hundecker. Day 5, we produced them, and then we had lots of beers afterwards. So this is, and this is something where you use industrial processes. You use wood as wood is on the market. You use machinery which is on the market, and you can create fantastic structures, because you're completely free to do whatever you want with straight sticks. And so I'm totally with you. But I think wood allows us to do a lot of things. And it's amazing just to do it.
We have a question, I had a question over here, and then I'll have to go to you, Nick.
Hello, another question about freeform timber. So I'm a student from Hooke Park, and I was doing a freeform timber, but using green wood. So I have a question about the rate of waste. I know how challenging it is, like from the freeform design to the manufacture, and from experiment stage to actual production. And there's always like scrap pieces, like at different process, like no matter it's steaming or gluing or like bounce back. And I saw like you showing that you have really big machines, and then you have different methods to make it controllable. And I would like to ask, like, when you're doing this, what's your expectation of the waste pieces, like the proportion of it, like especially in such big project, and how you control them at different stages, at experiment stage or production stage. Like for example, in these 5 cases, and you at the end you mentioned you have a forest. Does it help a little bit for the materials supply? Yeah.
That's a harder question because we are wasting a lot. Like Freeform, glulam is wasting a lot, and you cannot deny it. The only thing which we can say is we have our own wood, our own sawmill, and whatever we waste, we burn it, and we create the energy for the whole plant and for the killing chambers, the heat and everything. So we are closing the cycle, but of course it's a huge amount of percentage of the initial tree you are losing by doing the lamellas, by gluing them together, by in all these processes you lose wood. So you cannot compare it to a Hooke Park project where you really work with round wood. This is a hard question to say a positive answer.
Yeah. So I think at Hooke Park and in school in general, it's sort of like this incubation period, and we have 12 months, 18 months, whatever it is, to work on projects. You're talking about leaving a glue lamp piece out for 6 months is like a testing period. The question of time and duration of projects, lead times and things like that kind of comes to mind, and we sort of lose track of that, right? Could you give an example of like what a time frame, like a reasonable time frame for lead times? Anybody up there? How do you work through that? How do you have that conversation with the client where you say, it's going to take me 6 months of testing, 6 more months to do a fit up, and proof of concept?
So the first project we used Accoya. We have a guarantee from the supplier of 50 years with Accoya. And the mosque, I was shocked by one slide of Guillaume when he said the ending time is 60 years, because I think the mosque can stay alive for 700 years at least. So when you have wood inside and you have a controlled environment, you have structures which I think more than 1,000 years old. If you have wood under the water, constantly under the water, like Venice is on oak poles, and the city these poles were carrying the city for centuries. It's only now with the climate change where the water is going lower and they start to rotten, and the whole city of Venice has a problem of sinking. So I think there are reasons to use wood as a structure, and it works extremely good, but there are things where wood is not such a big advantage, is when you use it as a cladding material on the outside and you always have rain and wind and water and sun. Then you have an aging process which is very difficult to control and which is very difficult to satisfy clients, because very often a client wants to get a building and he doesn't want the building to get any patina. So he wants the building to look the same year after year. This is in our society like this. So I think there are ways of using wood in a very intelligent way, and there are ways of using wood in a very stupid way. In front of my building there was a chalet, a wooden chalet, and they wrote they want to create a new building in wood in the memories of the old chalet. So instead of this small chalet, they put a 5-story high building, completely of concrete, and now they're cladding the building with wood on the concrete for nothing, and they're painting the wood in gray. It looks like a concrete building, and I don't understand the argumentation when looking at this building. I don't understand why they say it's in memories of an old chalet in wood. So I think wood, you have to know where you use wood and how intelligent you use wood. And I think on the outside, it's difficult. You can do it, but it's difficult.
There is huge enthusiasm and hope in the architecture profession, which is vested in wood and timber. And we hear about practices who, from one day to the next, thoughtfully or not, are planning to convert their design from whatever it is, concrete and steel, to timber. And I'm bearing in mind a slide which was shown by Martin with a microcosm on the right-hand side at the date of 2050 and the much discussed climate emergency. How confident are you that the timber industry will be able to respond to this situation?
Do you want to take that one?
Yeah, I suppose firstly I am confident, but that confidence is only based on the fact that it can't just be the timber industry or the forestry industry. I think to see a good, optimistic future in 50 years' time requires this kind of conversation, because it's not just forestry and timber industry that has to move, it is the design and architecture and engineering industry that has to move as well. And Martin's right, there is this huge gap between the sort of idealistic kind of things that we quite honestly tend to do and the sort of industrial complex that's out there. But even that industrial complex is going to have to move to a situation where there's more diversity of species and types of timber. That same availability that allows CLT to be made from just the same material, I honestly don't think is going to be there. And that to me is quite exciting because it means better managed forests, but we are all going to have to work together to do it, I think.
Can I just follow up on that? Because obviously Hooke Park, it was discussed earlier, is relatively tiny compared to other countries in terms of its scale. I'm interested, the title of the symposium, A Forest Laboratory, right? How do you see that forest being more than a well-managed forest that provides timber for the future, but that could be an experiment? Like, how do you make a forest into an experiment that has a reach beyond it itself, right? Beyond being well-managed within its own boundary, but to be the laboratory, to be in a way the kind of the pilots, the prototype that Kai might be talking about with architecture.
Well, I guess to look at what I think the Hooke Park forest might be, to start with is to look at what the buildings are, and I perhaps look at them in a slightly different way than others in that, a lot of the buildings at Hooke Park are deeply innovative, globally exciting. No one's likely to build buildings like that commercially, but all of them offer something that I think can be taken to a much wider industrial use. So for instance, the use of beech in the timber seasoning shelter. We have tens, if not hundreds of thousands of hectares of beech that are a problem. And in some small way, we can demonstrate that using beech in a structural setting that is semi-outdoors, that is semi-exposed, when beech is traditionally not a durable material, we can take away from that. Similarly, the big shed, I think, provides a potential model for agricultural or industrial buildings in the future that can be adapted. And I think the forest is similar in a way. It's not a case of taking the forest and making it into one huge, crazy experiment where half the forest might fail. It's about scales of innovation, and it's about saying what's the long-term best resilient nature of the forest. And most of the forest being a very slow innovation and experiment. I suppose it's a bit like investing in pharmaceuticals, where your investment's just going to grow slowly and it can just sit there. But in the case of Hooke's forest, in an interesting way that can be modelled. And then within that, there can be some parts that are extreme innovation, where we can test species that we might think is suitable, but we don't know. we can go, the advantage of the AA and of Hooke is that we can go to places where other people don't go and do it in a small way at Hooke. And I see that as the future of the forest, showing some small examples that might fail or might be enormously successful. That's kind of where I imagine it.
I had it, hang on, I'm going to go. Yeah, okay, build on that.
Sorry.
And then there's a chap over here.
Sorry, I was closest, so I nicked the microphone. I just struck with something you said, Kate. I would appeal for you to think beyond the boundaries of your own, not architecture, I'm talking about the forest resource again. Because I suspect you might be surprised about the excitement out there in the private sector to be involved. So if you're doing good experimentation, you wouldn't want to do it on one site anyway, because you won't be doing good science. You need multiple sites, in which case science is asking you to go for collaboration. But I'm telling you, there will be people out there who will be excited to be involved. So I'd like to see Hooke Park being maybe the nexus, if you like, to use a word, of such a network of research stations who would be inspired and want to take part in trying to produce better quality, faster growing, but also sustainably produced timber. So I would appeal to you to have that in your mindsets and not just to be focused on, albeit relatively small but special place.
Is this working? Yeah. So my question is about how today, having seen so many inspiring projects, how this meshes with architectural education. And I think, having come here to see this talk, that we need to be aware that this is kind of everyone here are outliers in that they have an interest in this. And Hooke Park is an outlier. But I want to open it up to both foresters, furniture makers, and fabricators on whether you think that this kind of way of thinking should be more closely integrated into broader methods of architectural education and broader kind of syllabuses, if you like. And whether you guys as kind of leaders in your field are kind of making those moves towards not outliers in architectural education, kind of moving towards this, but actually having that as a kind of base standard for all architects moving through education.
I totally believe that it's needed to integrate this more into the architecture. I was teaching at the University of Bern, and there were a lot of people who were working in offices and were students of architecture at the same time. And Bern has at the same time a school of wood. And so you have a lot of projects in Switzerland which are lost to the concrete world. So they start and want to start with a wooden building, and they're not changing it from concrete to wood, but it's rather the other way around. They are starting and want a wood building, and then in the process suddenly they're losing it and it becomes a concrete building. And I believe, I don't know what the solution is, but I think companies like Blumer Lehmann have a lot of expertise. And I think in the world of architecture, it should be that an architect cannot have all this expertise by himself, but he should know at what moment in the design, in the process of the project, he should go and contact a fabricator just to know what are the key issues he has to follow, not to lose his project to the concrete world. And I also totally agree that these freeform architecture is fancy, but this is not going to be the big market of wood architecture. And this also has to be taught in schools, and people should be aware of this. If I would study again at ETH, I would have done my traineeship at a company like Blumer Lehmann, rather than going into an architecture company which is doing a little bit the same competition things like this I've done at the school. So I think if I would study again, I would do my traineeship in a company of a fabricator. I would learn a lot.
Well, I was interested why, slightly off topic, but why those projects are going from being timber and reverting to concrete. Like, do you know what the I mean, we see it. I think we see it a lot. Alex, anecdotally, is always saying that it's very difficult to actually convert an ambition. I mean, in Switzerland, why is that happening?
One thing very often is because of dimensions. Very often, if you have a structure in timber, it's a little bit thicker than in concrete. And if you already start your design with super minimal spaces, super minimal dimensions, and you optimize everything, like I've done the high-rise of Roche, the pharmaceutical building in Basel, we were optimizing in a concept design on millimeters, which is like so stupid. It's like you have no way to react later on in the project. And I think this is something when you have the possibility to inform the architect, the student, whoever, to say, no, take some extra space to put your structure inside. This, for example, is one reason.
I mean, is it a sort of inertia of the steel and concrete industries? I don't know. The sort of mindset, like there's a lot of embedded things, aren't there? The way engineers work, the way code, the kind of the expected tolerances, I guess, is what you're talking about, isn't it? The way that things are codified. Like we kind of work, it feels like timber is being forced a bit into the paradigm of steel design or something, just because that's what the industry's familiar with. And I suppose a bit what Hooke Park demonstrates is a sort of, it's a variant material. We shouldn't be trying to standardize it. We are, there's other ways of thinking about how we're building and what the material is. And I suppose that's why this kind of education, why the education of architects is so important, isn't it? That it means that, we're starting then to shift away from the, I don't know, we're not even conscious of it, but we've grown up in our educations in the world which has been driven by steel and concrete as the default materials, and we kind of expect that that's the precise line, the way that we do things is from that.
I also add to that what happens in this conversion of a timber project to a concrete one is nothing to do with the availability of the expertise or even the cost of the material if you crudely compare it to concrete. Because you can argue holistically it will be affordable. What kills it often is the finance and the insurance industries. So nothing to do with our expertise. It's entirely outside of our control. It's just a perceived view that there's too much risk and not enough familiar collateral.
There's one very simple thing that for regular commercial buildings in London, which I've worked on for 25 years. In the 1990s in London, in West London, I was building buildings in composite steel and concrete with 18-meter span floor plates. These people wanted, because they could do it, they do it, because it's for the cost of buildings in London, structure is peanuts. The value and so people were doing that. Now we have commercial developers. I'm doing a new commercial development with one of the London's big commercial developers. We're considering 6 by 7.5 grids for the same spec of office, and that suddenly means that we can be more sustainable. We can open up to timber and to concrete. So I would have thought, Kai described it by saying that the member was too big. I'd describe it as the grid was too big. Why are we were obsessed with column-free spaces. I mean, that's bananas. Architects should love columns. I don't know why we hate columns. So the grids coming down. Don't ever be forced by someone to make enormous grids when they're not necessary. Obviously, sometimes they are.
I'm going to get Kieran's question in here.
No, it's fine. I don't think my mic's working. That's fine. It is? Okay. So on that, it's been shown that smaller grids are one of the largest ways to reduce the carbon in buildings, even for concrete, steel, or timber. So that's why I think that fashion of smaller grids is coming back, as you're kind of saying. But the thing that's also quite fashionable, and it's kind of been touched on a couple of times, is this idea in steel and concrete. They're trying to show that their materials are reusable, and that's come up a couple of the end of life, how long the lifespans of these buildings are. Is coming up, has been touched on. I was kind of curious what you guys think about it. Because, for example, Hooke Park is a place of experiments, build buildings that will have a shorter lifespan and will be deconstructed. And they had a time when we knew how strong, how good they were, so we can see how that's changed and we can plan something for the future, or we can use those, we can adapt those materials. And I was kind of curious what you guys think, particularly Martin, because you managed to avoid saying anything so far, about what you think about the idea of taking someone else's building and deconstructing it and forming it into something new, and how that might affect you and how that might affect your kind of workflows, and is that something you're already starting to explore?
Yeah, there's a few things to unpack there, isn't there? I mean, each material has its own, I don't know, its own sort of nature, doesn't it? I mean, like concrete isn't, concrete needs smashing up, doesn't it, to reuse it, unless it's in panels that you can kind of move around, you can extract the rebar and the aggregate and reuse it, I suppose, but it's not in itself sort of sympathetic to reuse, I don't think, is it? The concrete industry would probably be arguing otherwise, I guess. Steel's different, isn't it? It's a kind of kit of parts, it's meccano, it's more about how much you want to systematize, I suppose, isn't it? There's been sort of attempts of that, haven't there, over the decades, and, it hasn't really happened, I suppose. Like architectural is sort of individuality of projects has won out, I suppose, against a kind of a totally systematic process. So there's maybe something to debate there, isn't there? The sort of, is the architect's desire to always be kind of creating something that's individual and special actually kind of counter to the potential for reuse or that kind of systematic logic? I don't know, wood sits somewhere between the two, I suppose, doesn't it? Like it's sort of, I don't know, you can imagine the kind of kit of parts version, but it's then also, I mean, in the way that Sean was describing, it's a more sort of, it's an easier material to sort of quickly, to relatively easily reshape, isn't it? You don't need to melt it back down to reform it. You don't need to smash it up. Yeah, you can shave it down, you can reshape it, you can add some new details to reconnect it. So I think there's something, isn't there, in timber and in engineered timber, particularly, that has that scope for a really clever sort of attitude to reuse that isn't locking you into just a systematic kind of component, but does anticipate that later. I don't know, there was another part to your question, wasn't there? I don't know what it was, but I'll let Jez take it.
So a few weeks ago, we spent a couple of days with the researchers from Centre for Timber Engineering, and what we were looking at over 2 days was actually about the grading of hardwoods. But what came out of the 2-day discussion was whether this whole business of different species and the complexity of wood and its qualities that are different not only between different regions. You can take, say, Douglas fir, and it's different not only between different regions of the world, but a forest. The tree itself has more variation in it than actually one side of a valley to another. And if we then wrap up timber reuse within that, essentially, if you as a material user is getting around the complexity of having to use all these different species with all these different properties, then adding reused timber, you could consider it just another species with just another set of properties. And all of a sudden, it doesn't become such a huge leap to try and think about the difficulties of reusing it.
Yeah, the inverse, or maybe the same thing, I guess we saw, didn't we, with the wood chip barn project at Hooke, where the tree forks are scanned and then used. Like, I think that prompted a number of studies which were actually about kind of doing the same process but with steel, scanning bits of dismantled steel and then composing how you reuse them. So yeah, I think there's something in the kind of general in our kind of technological thinking about standardization, isn't there, and how we deal with diversity generally. I guess reused material has to accommodate diversity, and that timber as a natural material sort of inherently has that, so there's kind of a compatibility.
It comes back to that. It comes back to the question about education, actually, and about I think timber and other bio-based materials require a whole different way of looking at materiality. And that needs to start to be taught much better, possibly from a really early age, and probably pre-university, pre-School of Architecture. But you're going to have to deal with a whole load of complexities that perhaps haven't existed in how we've used materials within design in the past. And perhaps it's about re-looking at how we think of vernacular and seeing it much more materialistic way. And because I don't work for the AA anymore, I'll say this, from an educational point of view and from a material point of view, it's tragic that there are students that can go through the school here and not visit Hooke Park and not see the material they're going to use in its raw form.
Absolutely. Should all come. We'll get some tents out. I was going to say, I think there's a mindset shift as well, isn't there? The whole idea of having a plan for 100 years is kind of mind-blowing, I think, to a lot of architects, contemporary architects. It wouldn't have been in the past. You have multi-generational cathedral projects. I think this idea, the mindset of an architect gets you to the moment you hand the building over, the moment of completion. And then there's this kind of line, turn around, move on to the next project. And the mindset shift to almost, to use a phrase from athletics, to run through the tape, right? To think beyond and imagine, take the imaginative leap to think about the building in 10 years, 20 years, 30 years, 100 years. And I think one of the things that is really fascinating about this project the AA taking on a 100-year plan is to try and imagine what the AA looks like in 100 years. Does it exist? Is my first question. And how do you plan a multi-generational project? How does the AA structure a multi-generational project that's going to take X number of generations of students from first to fifth year, tutors, directors, everything else? That's a kind of slightly mind-blowing conversation, I think. Any other questions?
Yeah. It's okay. I was actually going to build on something Jez was saying, the usual eloquence. I also wanted to come back to Alison and the sculpture, actually. I think I was really inspired by, you talked about the customer, and we haven't really talked about customers today. And Kai, you mentioned the customer and the expectation of wanting the building to have its fixed facade forever. And we've seen that in our own personal way at the Wood Centre in Oxfordshire, where we've got the thermally modified brimstone. It arrives completely chocolate coloured. Within a week, though, it's settled into completely new, and it's beautiful. Mm-hmm. But it just struck me that it's also about education, as Jez is saying. But it's education of the customer and the general public. And dare I say, it's back to what I was talking about, the wood culture. It's about actually changing hearts and minds. And whether we're talking about square buildings or curvy buildings, or whether we're talking about wood as a natural material and how it should be perceived, it's actually about taking society with us as thinkers in our fields. Whether we're foresters taking people with us, sculptors and artists enabling people to see what a natural material does, and equally as architects and engineers, how we respond to the challenges of working with natural materials, and dare I say, educating the customer to understand that it's just different. It's not necessarily worse or better, it's just different. And then it's all the way back to what Hooke Park can do and what the AA can do, and actually being the inspiration of that, isn't it, in the future, in 100 years' time.
I don't know if we have any final questions. Might be drinks time in a minute.
Yeah, my question is about to understand a little bit what are the challenges right now that we, maybe young architects, are facing when construction with timber. Francis was telling a little bit about the problems we have with fire and maybe problems with developers or insurances. What is the agenda right now? where we should focus.
Does it work? I think there's one topic we did not discuss today at all is extensions, because I think sustainability works a lot if things are lasting for a long time. And what we do very often is we tear down complete buildings and build them new in a sustainable way. But I think one topic we have done at Bluma Lehmann quite a lot of times is just extensions of existing buildings in cities. You know, you have like 4 stories, and then you have a fantastic material which is lightweight, and you can put 1, 2, or 3 stories on top of an existing building. I think this is a topic which we did not address at all here in this round. But this is where you could say, you ask brick what it wants to be, or their wood is a light material, and you can use it fantastically to combine it with an existing building, and you don't have to tear down everything. And I think this is done not often enough.
Just another comment relating to Hooke Park as well as the AA. I was thinking, Kat, of your upcoming residency and how you're looking to really embed data sets into Hooke Park. And I think that's really critical as a lens for allowing cross-discipline interaction with Hooke Park and with the AA. So, I mean, if you were to invite data scientists or resilience engineers, you know, to come and look at what the forest and its inhabitants are, you know, what the data is giving them, I think this is a really interesting lens into the future, right?
I'm going to hand over to John.
Well, I don't know about you, but I think it's been an extraordinary day. I don't know how often the AA puts on events such as this, but if they're as powerful as this, then I would think that lives are changed. And I hope that those of you here who've had the benefit of such wonderful speakers will feel that your life has shifted in some way, one way or another, towards a clarity about your future and what your role is as a professional. And I think that's a really exciting possibility, and I hope going to be a reality.
Thank you very much. I think that's the note to leave it on. Thank you, John, and thanks again. John's generous support makes this whole thing possible, and thanks to Public Programme and AV for making it happen, and all the speakers. I mean, I agree, it was fascinating, absolutely fascinating. This is one of, hopefully, a number of future points at which we gather a group of people like this who really know what they're talking, multidisciplinary, which is one of John's key kind of ambitions for Hooke, is that the multidisciplinarity of it is where it started, where forestry and architecture and engineering collide and where real expertise comes together. And so hopefully this is food for thought. We will gather, hopefully, some of you back again to have another conversation, and regularly until 100 years' time. There are drinks. Thank you, everyone, for coming. Thank you.